Hello everybody, welcome back. In this video, we're going to be discussing some of the third-party tools and products that we're going to be using to actually achieve our objective of creating a production-ready Django REST API. So the first thing that I'd like to bring your attention to is Heroku.com. Just as a disclaimer, I've not been paid by any of these companies to promote their product. I actually use them in my real life in all of my personal projects as well as professional projects, and I think they're really solid products and they make your life as a developer really easy as well. So the first one is going to be Heroku.com. This is going to be the platform that is going to host not only our Django API but also the database that is going to go along with our Django application. We are also going to have Google Cloud. Google Cloud is just going to give us one very specific product that we need, and that is going to be the cloud storage functionality. And we're going to store all of our media content, such as images, videos, and other stuff like that on Google Cloud, and then access it through here. One other really useful tool that I'd like to point out is Postman. Postman is just going to be a program on your computer, and it's available for all the major operating systems. So you can just download it, and I've already have it downloaded. And when the time comes, I'll actually give you a thorough walkthrough of how Postman works. But for now, you should know that this is going to be something that's going to help us debug our actual Django REST API. It's going to allow us to send requests to the API and receive responses. Just as a side note, the Django REST API framework does provide us with a beautiful GUI, but this is just a helper tool that I think every developer that develops APIs needs to know about. Finally, I'd like to give a shout out to Trello.com, which is just like a collaborative task board where people can actually create lists of things to do and then like complete them, and that was the inspiration for the API that we're creating. So I was like, it's good that I let you guys know about Trello. So with that said, I think that is the end of this video, and I'll see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be taking a quick look over some of the concepts related to web development. The two that we're going to be discussing in this video are going to be HTTP request methods. So let's get started with request methods. So what are request methods? So whenever a client, which in the case of right now is a browser, needs to communicate to the server, what is the context of the request that's being sent? For example, the request that's being sent, is it asking the server for something, or is it giving the server something so that the server can do something with it? So for example, if I go to udemy.com, what the browser actually does internally is that it sends a GET request because it wants to get a resource from the servers where Udemy is hosted. In response, the servers actually return some HTML, CSS, and JavaScript, which then your browser uses to display the homepage for that website. And this happens every time you navigate to something different, whether that be on the website itself or to a different website such as Heroku.com. So now that we know what HTTP request methods are, let's talk about some of the more commonly used ones that we're going to be using. So the first thing that we're going to be talking about besides the GET request is something known as a POST request. In POST request, what happens is that we give some data to the server, and then we specify in our actual HTTP request that this request is of type POST, and then the server knows that it needs to take this data, perform whatever actions it needs to do, and at the end it needs to create a new entity in itself. So this might be me sending a POST request to create a new user, where I send some data regarding a user, and then that data gets sent over to our server, and then the server knows that this is a POST request, hence I need to create this new user inside of the database. Put is similar to POST, but the put method replaces all of the data that currently exists for a already existing resource. And in this case, I might have a user on the server, and that user might have information already associated with them, and I'd like to replace all of that information with new information that I'm now sending. In that case, since I do not want to create a new user, I just want to update all of the data for an already existing user, I'll send a put request. Similar to this, I can send a delete request, and in the case of a delete request, we do not send any data. All we want is to tell the server that I do not want to get this user back. All I want you to do is that I want you to delete this user. And in that case, you send an HTTP request, which has a method of delete, and then the server knows what to do and actually deletes the resource. Finally, another important one is patch. Patch is similar to put, but in patch, you apply partial modifications to the data. So for example, I might have a user and I might want to just change their name and email and leave their password and mailing address unchanged. In that case, I won't be using a put request. I'll use a patch request. And all of the data that I sent, that data is going to be then replacing already existing data where the keys match. Okay, so with this, I'm going to end this video here. We have a basic understanding of what HTTP request methods are. So see you guys in the next one then. Thank you. Hello everyone, welcome back. In this video, we're going to be talking about HTTP response status codes and how they relate to web development in general, and then specifically API development as well. The concepts that we're going to be talking about in this video do not just relate to API development, but web development in general. So in the previous video, we had discussed about HTTP request methods and how they gave context to a request and how they allowed a web application to understand what we wanted it to do. Similar to that, an HTTP response status code is something that is returned to us after a server processes our request that we send to it. Now, these status codes range within a range of 100 to 599. And depending upon what type of response we get, we can have an understanding as to whether the operation was performed successfully on the server or whether there was an error. And in the case of an error, the server might respond with additional data that might help you in the debugging process. So now that we understand a bit about status codes, let's take a deeper look into how they would actually work. So let's just say that I send a post request to our server and I want to create a new resource. And the server is successfully able to create that resource. Well, in that case, the server is going to respond with a 201 status code, which corresponds to created. And if you read the description for this, it should say the request has succeeded and a new resource has been created as a result. This is typically the response sent after post request or some put requests. Similar to this, if I send a request, that is a GET request. And it could be for either getting a list of resources or just a single resource, and it goes through successfully, then I would get a 200 OK response. Let's just say that I try to access a resource that is not available on the server. Well, in that case, I'm not going to get a 204 no content. That is something that happens when the server processes the request successfully, but there's nothing to return. Then you do a 204 no content. But in our case, since we wanted to access a resource that is not available, the error that we're going to get, and this is like fairly common if you've ever browsed the internet, and that is 404 or not found. So typically what you would see is that if there are client-side errors where the client maybe gave incomplete data or maybe tried to access data that's not available or maybe sent a bad request, you're going to get an error between the range of 400 to 499. If there are errors on the server side where the server was doing some kind of processing and it encountered an error, then the errors are going to range between the range 500 to 599. And you can read all about the different errors that are available by going to the MDN web docs available at developer.mozilla.org. They have good documentation regarding everything you need to know about HTTP security, guides, good practices, request methods, headers, and response status codes, and much more. Similar to this, if there is a redirect, which you do not usually work with in REST APIs, these are usually more about web application development, but redirects are in the range of 300 to 399. If you ever have an instance where there's a request that you sent completed successfully, in that case, you're going to get a response that is going to be in the range of 200 to 299. And finally, we have some informational responses, which are just 100 to 103, which are not that common in API development. So with that, I think we have a good understanding of what these HTTP status codes mean and how to implement that and how they can actually help us in our development process. So with that, I'm going to end this video here. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. So I think before we begin building our API, I think it's good for us to understand what functionality our API is going to be encompassing and what the actual end product is going to be like. So without anything further to do, let's get into it. So the first thing that we're going to look at is the actual user management part of our API, which consists of the actual storing of the data that relates to a user as well as the authentication aspect. So for that, what we have are two endpoints in our API. The first one is API/auth. Here we have several different endpoints, each of which performs a very specific action, which we're going to go into much more detail. And the actual specific module related to authentication comes about in this course. For now, all you need to know is that API/auth refers to any kind of authentication endpoint that we might use. For example, invalidate session means that all of the JWT tokens that have been given to a specific user can be invalidated so that they are no longer legal and cannot be used. Hence, if the user can essentially log out from the API. The actual convert token is going to be used for our actual OAuth 2 implementation, where we're going to use the actual Google login, where Google is going to give us an access token, and that access token is going to be actually provided to our convert token endpoint, which will then take that access token that's provided to us by Google, do some magic, let's just say for now, and then it's going to return us in token back, which is going to be then used for every subsequent request that we send to our API to actually verify our identity. And then these other endpoints serve similar functions. Now going back, the next endpoint that I would like to talk about is our accounts endpoint. So here you have two actual endpoints, which is users and profiles. Usually we're just going to focus towards users. Profiles is just going to be used if we want to edit a specific profile. So now, as you can see, if we go to the users endpoint, we actually get a list of different users that have been registered inside of our application. Each user has some corresponding data, such as their username, email, their name, first name, last name, profile. This profile is another object that is then embedded as a JSON inside of the actual parent JSON object of the user. As you can see here, we have a URL that points towards the profile endpoint, and if you click, you can see that I can go here and then I can edit the specific aspects of our profile. So each user also has a profile, and the profile stores extra data, or you can say extend upon the already existing user model that Django provides us. In this case, all we actually keep in profile is the actual house that the user is a member of, the actual image of the user. As you can see, if I go back to another user, for example, user number 5, you see that the image for them works. And the next thing that we're going to do now is that I'm going to go back to a profile for the same user that I'm logged in as. And as you can see, I can actually edit my image and change it to somebody else. But now if I go back and I actually try to edit a profile of a user that I am not actually, for example, Malfoy, the username, you're going to see that I only have the permission to actually see their profile. I do not have any other permissions, such as editing their profile. Same goes for their user. The user endpoint is also going to be the endpoint that we're going to be using if we want to register a new user, where we're going to provide the first name, last name, email address, and password. And then we're going to create a user, and the old password is just for the scenario where we would like to change the actual password of an existing user. So this pretty much completes the actual user management aspect of our API. So now the next thing that we're going to look at is the actual house endpoint. So as we know that this API is going to be kind of a clone of, you could say, Trello, where different houses have tasks and each house has some members, and then each of those members can complete some different tasks in that house. So in this case, if you go to our houses endpoint, you're going to see that we have 3 different houses. Each house object actually gives us some information, such as the URL for the house, the ID of that house, the image for the house, which is stored on Google Cloud, some other specific stuff such as points. Points just relates to how many tasks the house has completed. So for example, the more tasks the house completes, the more points they get. We have completed task counts and then non-completed task counts. We have the different members that are part of the house. We have the actual task list. So each house has a number of different task lists. And each of those task lists then have different tasks in them. And once all of the tasks inside of a task list are completed, we mark the task list as complete as well. We have the amount of members the house has, a description for the house, the actual house manager. So let's just see what the actual privileges a house manager has that members do not have. So if I go to this house, for which I am actually a manager, as you can see, you're going to see that I can delete the house as well as I can update the name of the house, the description, and change the image. And I can actually remove members as well. Join and leave are just two different endpoints where individual users inside of our application can join a house and leave a house. But remove member is only a privilege that is given to the manager, where they can kick somebody out of the house, any of the members. Then if you go to the task list, you can see that this is one of the task lists. We get some information as to when the task list was created, who was it created by, the house that it belongs to, the task that the task list has, the status of the task list. So right now it's complete, the description, the name. And then we have the actual tasks inside. Each task, just a fun side note, can also have attachments. So attachments refer to, like, for example, if I went grocery shopping and I bought something, then I can attach an attachment of a receipt. And then as you can see here, I've attached the receipt, just a dummy receipt I got of Google, to just verify that I had bought some groceries. As you can see, buy bananas, and like that's the receipt for it. That is also stored on Google Cloud. So now, similar to our user endpoint, permissions are also implemented here. So if I'm not a member of a house, hence I cannot go and see their task lists, because you shouldn't be able to see other houses and what their task lists are, as well as their tasks. And I can, even though I can see the house and like the members that are in there and like the member count, I cannot actually do anything with the house. So I cannot like remove members, and I cannot like change the task list and stuff like that. Finally, the last endpoint that I would like to bring about, even though we've already discussed the functionality, is the task endpoint. And this endpoint gives us like 3 different endpoints, such as the task lists, where we can create new task lists and assign them to a house. We have the actual tasks, so we can create new tasks here and see already existing tasks. And these tasks that are shown here are only the tasks that we have created. And then finally, we have an attachments, where we can create new attachments. So this pretty much wraps up all of the stuff that I had to show you, and actually hits all of the marks for the major functionality that our API is going to have. The only thing that I didn't show you maybe was that we also are going to have auth authentication in this application. So people using their Google account are going to be able to log in. And furthermore, we're also going to actually deploy this API to a production platform, so that you can actually serve your API to end users in a stable environment that's well suited to actually handle multiple requests at one time. So without anything further to do, I'm going to see you guys in the next tutorial. Thank you. So without anything further to do, I'm going to see you guys in the next lecture. Thank you. Hello everybody, welcome back. So in this video, what I'd like to do is actually go over how to set up Python in a Unix-based system such as Mac OS or Ubuntu. And then after that, also show you how you can install the virtual env package into your computer and create a virtual environment, which is a separate Python binary from your global Python installation, which we're going to be using to actually install all of our packages, or Python packages, I should say, for developing our REST API. So let's get going. So to install Python, it's fairly simple. All you have to do is that you have to go to python.org. Then you have to click on downloads. From there, you can click on either the operating system that you're on, or you can click on all releases. From there, just scroll down to where you see the specific version of Python you'd like to install. I'd recommend installing Python 3.8 anything. Just make sure that the Python version to install is not 3.9.0, because as the time of this recording, it's fairly new and a lot of packages that we'll be using do not work well with it. So once you have that, what you can do is that you can just click on Python 3.8.6. And then once you're on this page for the specific Python version, just scroll down and download the specific installer. So just click on the installer. In my case, it's Mac OS X. Install it as you would do, and then you should be good to go. So now the next thing to check if Python is installed, what you can do is you can open up terminal in whatever Unix operating system that you're using, and you're going to type in Python. Once you do this, you can do --version, and it should hopefully show you the Python version. So in my case, it's 3.8.3. Once you have this done, the next thing you're going to do is that you have to install the Python virtual environment package, which is going to allow us the ability to actually create the separate Python isolated environments where we can install an independent set of packages that our projects require. So for that, what I'm going to do is that I'm going to do pip install and then virtual env. With that, you can click enter. Since I've already installed this, it's going to say that the requirement is already satisfied, but for you, it should go through the installation process and you should be all good to go after that. So once you have this done, the next thing I'm going to do is that I'm going to, on my desktop, create a new folder that is going to hold all of my code as well as the virtual environment that we are going to be using for developing our API. So I'm going to change directory to my desktop. If you're not comfortable doing these commands on the command line for like changing directories, making folders, stuff like that, you can definitely go ahead and just do them the normal way of like clicking and creating stuff. Here, what I'm going to do is that I'm going to create a new directory and I'm going to call this our taskly_app. Once we have this, the next thing I'm going to do is that I'm going to move into our Taskly app. And here, what I'm going to do is that I'm going to create our virtual environment. To create a virtual environment, it's fairly simple. All you do is you do virtual env, and then after that, you type in the name of whatever virtual environment you want to name it to. So in my case, what I'll do is I'll name it venv. Usually, since I keep my virtual environments right alongside the projects, I usually name all of them venv. But if you like keep them in like a separate place in your system where you have like all virtual environments, then maybe you might want to like name them according to the project that you're working on, such as like Taskly app venv. But in my case, I'll just put it inside of where I'm storing all of the other source code as well. So I'll just do virtual env venv. Okay, so once the virtual environment is created, you should get an output like this where it says created the virtual environment. Now what we can do is that we can just either use ls to list all of the stuff that we have inside of our directory, or you can just double click to make sure that you have like a venv folder, which has like a bin folder and some specific files inside of it, as well as like a lib. So once we have this, the next thing you can do is that depending on what kind of operating system you're on, the method of activating your virtual environment differs a bit, but it's usually generally the same concept. So you can go to docs.python.org/3/library/venv.html. And going down, you can actually see, once you've created a virtual environment, what kind of a command you can use. So in our case, since we have Mac OS and it's actually the bash shell, what I'm going to use, this command. So for this, what you do is you're going to do source, then the actual folder where our virtual environment is. In my case, it was venv / the bin folder and then /activate. If you're wondering how I autocomplete some of the stuff, you can click tab and that auto completes it. And then after this, what you can do is that you can click enter, and you're going to see that this kind of a venv thing pops right before the actual base tag, you could say. And this should give you a hint that your virtual environment is activated. To further like solidify the fact that the virtual environment has been activated, you can do which and then Python. And doing this command should actually point you towards which Python binary it's being used currently. And as you can see, it says users, Hussein desktop, the actual Taskly app, the folder we created, virtual environment, bin, and Python. So with this, you're all good to go. So now the last thing we're going to do is that we're just going to install the actual Django package inside of our virtual environment. So for that, it's fairly simple. All you have to do is you have to do pip install Django. With this, you can click enter and it shall install Django for you. So we'll just wait a couple of seconds and I think we should be good to go. And yeah, there it is. So with this, we have everything set up the way we want it to be. Just as a side note before I end this video, please make sure that the Python version you're using is not Python 2. Just because Python 2 is now end of life. Even if you go back to Python's actual website, you can see it says that 2.7, the latest version that Python 2 had, is now end of life. So I'd recommend just using Python 3. And if you want to just have the exact same setup as I have, then make sure that you have Python 3.8.3, but any version of 3.8 should work. So with that, I'm going to see you guys in the next lesson. Thank you. Hello everybody, welcome back. In this video, we're going to be going over how to create a Django project, and then also how to actually install the Django REST Framework package, and then integrate it with our Django project. So without anything further to do, let's get to it. So the first thing that I would like to point out is make sure before beginning this tutorial that you've actually activated the virtual environment that we've created in the previous videos, and that you've also installed Django inside of that virtual environment or the Django package. And then to just confirm, you can do pip freeze and just make sure that Django pops up. You might have some extra packages, that does not matter, just make sure that you have Django. Okay, so now that that is done, what I would like you to do is that I would like you to navigate to whatever folder you're going to put your Django project into. In my case, I'm going to put it right besides our virtual environment in a folder called source. So the way you're going to start off is that there's a command for Django that's called Django admin. And this is the command that's usually used to generate a new Django project. You can do Django admin and you can do just click enter, and you're going to see that it's going to give you a list of available subcommands. Amongst these, the one that we're interested in is start project, because that's the command that's going to allow us to actually create a project. So I'm going to do Django, and then after that admin, and from there I'm going to do start project, and then I'm going to name my project something. In my case, what I'd like to do is I like to name my project main, because it'll make sense later on in the videos, because in Django, you can think of your project as being built from the combination of individual apps that are placed inside of that project, and those combination of apps together composes the whole Django application. So like the main app, that's like responsible for like joining everything together, is the app that is going to be created with our start project command, and that's why I like to call it main. But in this case, what I'd like to do is actually differ from that method of doing stuff, because I think that'll be confusing for us beginners. And I'm just going to call our app taskful, and then I'm going to say underscore API, underscore app, underscore API. So once this is done, all you have to do is click enter, and the Django project should be created for you. To double check, you can just click open the folder where you had run this command, and you'll see like a folder has appeared which is called taskful API. Inside of this, you should have a manage.py file as well as taskful API. So now the next thing I would like to do is that I don't like to actually have the folder's name be the same name as the name of my actual app inside for my actual Django app. Okay, so once we have this, the next thing I'd like to do is that I'd just like to change the name of the parent folder that encompasses all of the source code for our Django project to something different, because I don't like taskful API. So I usually call it source. This just gives me that's just something that I like to do. So you can change the folder name, no worries, nothing's gonna break. Secondly, what I'd like to point out is if you do not end up on changing this folder name, just please just make sure you never change the actual name of this folder that's inside of your parent folder, which is this, because changing this might cause your app to break, and it might cause discrepancies when you're like importing stuff, or like Django's trying to look for that specific app. So I would never recommend that you actually rename the app here, this app folder. If for some reason you mess up the app name, all you can do is that you can just delete the whole project and then recreate the project. I think that's a better way of going about it. Okay, so once we have this, the next question you might have is, okay, so we have like this demo, we have like the starter template for our Django project. How do I run it? Well, it's fairly simple. All you have to do is that you have to navigate into the folder where all of the source code for the Django project is. In my case, it's the source folder. Remember, I renamed it. And from there, you can do ls, and you're going to see that we have a manage.py file. Well, this manage.py file is like, you can say the do all file for everything Django. If you want to make migrations, which we'll get into later, if you want to run the server, if you want to collect static assets, if you want to do anything that remotely relates to Django, such as create another app inside of your Django project, you'll from now on use manage.py. Think of this as the replacement to the Django admin. So you can do manage.py, and then all we have to do is do run server. Just as a side note, if you want to see all of the commands that manage.py gives you, you can do --help, and it should list all of the available subcommands. So now we're going to do .manage.py run server. Running this should give you an IP here that says that your server is running on port 8000. And then all you have to do is on your browser, you can do 127.0.0.1, that port 8000, and then you can do enter. You're going to see that it gives you a page which says the install worked successfully, congratulations. And now it's all good. We have successfully created a starter Django project. The next thing I'd like to do is to show you where you can get all of the documentation that relates to Django specifically. So I believe that djangoproject.com, the official website for Django, has superb documentation for anything that relates to Django. If you click on the documentation link, it has a ton of material about models, query sets, model instances, migrations, advanced stuff such as raw SQL, transactions, aggregations, and all the jazz that's with Django. So if you ever are confused about anything else, the first place that I recommend you, even before Stack Overflow, is to go to Django Project. And I think it's a good ability, and I think it's really crucial for a developer to navigate documentation of different frameworks that he uses, because that's like a crucial ability for like problem solving and stuff like that. So I'll highly recommend that before you like just type in an error and go search Stack Overflow, take a look at the documentation, familiarize yourself with what's on this page, and I think that's going to serve you really well. So with this done, the next thing I'd like to do now is that just quickly integrate the REST framework into Django. Okay, so now that this is done, I think the next thing that we should do. Okay, so with this, I'm going to see you guys in the next video where we're going to actually just go over the Django project. I'll show you how to open that in a code editor and like what some of the structure to the Django project is, and then what are like some of the important files that you should take into consideration as a starting Django developer. So with that, I'll see you guys in the next one. Thanks. Hello everyone, welcome back. In this video, we're going to take a deeper dive into the architecture of a Django application. So let's get into it. So the first thing I'd like you guys to do is that you can open the code editor of your choice. In my case, it's Visual Studio Code. And then I want you to use the folder that has all of the source code inside of it, as well as the virtual environment, and drag it into Visual Studio Code. And this should open the project inside of Visual Studio Code. Once we have this, the next thing I'd like to do is actually activate the virtual environment we had created in our previous videos. And the process for doing that is completely same. But now what I'm going to do is use the built-in terminal that Visual Studio Code has to actually activate our terminal and then actually run the Django development server. So I'm going to click on New Terminal. On Windows, it should be something fairly similar to this. It should either be Open Command Prompt or Open PowerShell. Once you have that, you can use the platform-specific activation command for your virtual environment, which were discussed in the previous videos. Since I am using macOS, what I'm going to do is that I'm going to do first make sure that I'm in the right directory. So I have virtual environment here. What I'm going to do is I'm going to do source venv bin and then activate. My virtual environment is already activated, as you can see here, but as soon as you do this command, you should be inside of your virtual environment now. So now that we have done this, the next thing I'd like to do is that I'd like to change directory into our source folder, which contains all of our files that relate to Django. And I'd like to run the /manage.py file. And then specifically what I'd like to do is run up in development server. So /manage.py run server. And this command is going to run the Django development server for you. I've just noticed this error. And to fix this, all you have to do is that you have to set debug to true. And then you can do /manage.py run server. The settings.py file is a file that stores all of the settings specific to your Django project, and it's located inside of the starter app that is created when you use the Django admin start project command. And the name of this app is whatever app you input for that command. In my case, since we had used RESTful API, that's what it is called. So now doing /manage.py run server, you're going to see that we get an error that says unapplied migrations. For now, you can just leave it as it is. When the time comes to actually discuss about migrations, we'll take a deeper dive into it. And you can go on to 127.0.0.1 and then the port 8000. Once you do this, you can reload the application. You're going to see that it says that the install worked successfully and we have Django running. So now what I'd like to do is actually discuss a bit more about the settings.py file and what it does. So the settings.py file is the file that encompasses all of the global settings that our Django application requires. For example, it has the secret key that our application uses. And this secret key is used for different things that are done in the Django application, such as hashing passwords. To solve them, the secret key is used. Once we talk about JavaScript web tokens and how they're going to be given to the users to actually encrypt them, this is also something that's used for that purpose. But for now, I'd like to do just one easy thing. I'd like to set the debug mode of the application to false. And as soon as I do that, I do command save, you're going to see that the app automatically reloads, but it kind of crashes. And the reason for that is because our allowed hosts is set to nothing and we have debug false. So we have to tell Django which different hosts or can be used to actually access our API. So in this case, what I want is that I want to use 127.0.0.1 and then port 8000 as an allowed host. Now if I do /manager.py run server, our server should spin up and it should give us a bad request. Since we've disabled debug mode, any helpful messages, any error messages, anything like that, Django is not going to show it. It's just going to give us generic errors. So for the purpose of development, I'd like to enable this again. So I'll just set it to true. The app's going to reload automatically. And now we should see the host. And now we should see the stuff again. The reason we're getting this error is that we do not include the port. So just remove the port. Do command save. And the app should start working again. What I can do now is that I can set the application to false as well. And that was something I did specifically to just show you that, yeah, sometimes if you do not get any output from the API, make sure that you have debug mode set to true so that you actually get helpful errors. And now if I rechange the allowed host to port 8000, do command save, you're going to see we do not get any output from the API. But now I'm just going to set it back to how it should be, 127.0.0.1. And you're going to see that it gives us the appropriate not found response. One useful tip that I think you guys should know is that if you have debug mode set to true and you want the API to be accessible through any host, you can just input a star or an asterisk inside for the values of allowed host. And this should allow us to access the API from any host that points towards it. So I can use localhost port 8000 as well. That would do the same thing. But if I go back and just change it to 127.0.0.1, you're going to see that I'm able to access the API on 127.0.0.0.1, but I'm unable to access it on the localhost because it's a disallowed host. Okay, so now that we have talked a bit about the settings.py file, take a look at the wsgi.py file. The wsgi.py file is used by web servers such as Nginx or Apache to actually understand how to serve our application. And we are not going to do much with this file. So I thought that it would be just beneficial for you to know what the wsgi.py file is for. The next thing that we can take a look at is our urls.py file. So this urls.py file is going to define all of the different URL endpoints that our application is going to have. And for now, our application, as you can see, has this one path. So what this path is that for after our base URL, we can add /admin. And this should take us to the actual admin dashboard. But for now, since we've not applied migrations, you should get this error that says there's no such table as Django session. So just ignore it for now. And in the later sections, when we talk about migrations, this error should resolve itself. So just know that for now, all of the different endpoints or URLs that our application requires, all of them go inside of our urls.py file and specifically inside of the URL patrons list. The next thing I'd like you to know is that there's this dummy SQLite database that's created by Django. So for now, since we've created a fresh project and we haven't actually connected it to a production ready database, Django just for ease of development creates a SQLite database for us that for now we can use to actually develop, debug our application. But when the time comes, we'll actually connect a production-grade PostgreSQL database to our API. Finally, the manage.py file, as I've told, you can think of this as a replacement to the Django admin command, but it's specifically used for managing this specific Django application. If you want to see all of the jazz that manage.py can do, you can just do manage.py, and then what you can do is --help. If some of you are wondering why I'm not doing Python before manage.py, you can do that as well if you feel comfortable with that. I just usually like to do a dot and then a slash. That means the same as adding a Python before the manage.py file, and then do whatever command you want to run. So as you can see, we have a lot of different commands that you can do, such as create a super user, change password, remove stale content types, some Django specific, some session specific stuff, and then static files. But for now, all I need you to know that manage.py file is going to be a replacement to our Django admin command, is going to help us to run some specific management commands on our Django application. So with that, I'm going to end this video here, and I'll see you guys in the next video. Peace. Hello everybody, welcome back. In this video, I'm going to be introducing to you a really powerful feature of Django. That's the Django ORM, and ORM in this case stands for Object Relational Manager. So basically what the Object Relational Manager does is that it makes it really easy for us as developers to interact with our SQL database and run operations on it, as well as perform queries. So to further explain this concept, I'm going to use an image, which is going to help aid your understanding. So the Django ORM works in a two-step process, and you start off by actually defining a class, which we call a model in Django terminology, and this model corresponds to a specific entity that you might want to save in the database. The name for the class corresponds to the name of the table that's going to be used in the database, and then all of the different attributes that the class has are then the fields or the rows of the actual table. For example, I might have some data that I've scraped off of a page on the internet, and I might want to save the title for that page, the permalink, the upload date, and some text or the body of that page. And to do that, I can create a class, which is going to be named page. So I'm going to create a table essentially in the SQL database, which is going to be called page. And then for all of the rows inside of that table, I'm going to have the title, the permalink, upload date, and body text. And then what essentially the Django ORM is going to do is that when we run a really specific Django command, which is called make migrations, it'll take all of the classes that it finds, which corresponds to our model classes, and then it'll generate some automated SQL. And then after we've generated that automated SQL, the final step that we need to do is that we then call the manage.py migrate command, which then takes the SQL that was generated and then applies that to the database. This is a really powerful feature of Django that makes it really easy for developers to quickly get started with the SQL database, and makes it really easy for like beginners that are just new to SQL development in general, easy to get going. Okay, so now that we have a good understanding of what the Django ORM is, what I'm going to do is that I'm going to show you an error that we're getting right now when we try to access the Django admin panel, and then how we can resolve that. So for now, if I run my server, you're going to see, and hopefully you should see this as well if you run your server, that it's going to give you an error saying that you have 18 unapplied migrations. Well, what this means is that Django says that, oh, I've seen some apps that have some model classes that are defined inside of them, but I can't seem to find any migrations as of now. So I think there's something wrong, and I think the database is not quite set up right now. So to fix this, what we have to do is that we can first exit the API, and then we can do /manage.py. And before we actually make the migrations, what I'll like to do is that just show you another error that you might get when you're developing a Django app or even Django REST app. And that is, if I try to go to the admin panel, you're going to see that I get an error that says no such table Django sessions. Sometimes if you see an error that kind of points towards something that's wrong with the database, always make sure that the first thing is that you have created the migrations, if you uploaded any models, and then those migrations have been applied to the database as well. So in this case, I know that I have the migrations, but I haven't applied them. And you might be like, well, I haven't defined any models yet, so why is this giving me an error? Well, Django out of the box does provide you with some out of the box models, such as Django sessions as well as a user model, and that's why it's giving you an error. So if I do /manage.py make migrations, which is a command, as I've mentioned, which takes in all of the models that you've defined, and then it creates the SQL commands for them, you're going to see that I get no changes detected. Django out of the box already has all of the SQL stuff generated, so we don't have to worry about make migrations. But whenever you make a change to a model, you'll have to do the make migrations command first, followed by the migrate command. So now I'll do manage.py migrate, and you're going to see that we'll get a bunch of output, and this essentially just means that all of the different migrations that were created, they are being applied to the database. So once we have done this, our database should now be in a state where it's ready to handle all of the data that we send to it. So if I do run server now, and I reload the app to our admin panel, you're going to see that we are now able to see that admin panel load up, but we cannot still access it. And the reason for that is that there is no user in our app right now, so we have to create a user. Well, luckily, the manage.py file gives us a really handy-dandy function called create super user. And what create super user does is that it allows us to create a super user for our Django application without the need for us to actually write some Python code or maybe create a GUI that allows us to do that. So now what I'm going to do is that for the username, I'll just leave it at blank, and it's going to use my username Hussein. For the email address, I'll do hussein@preneur.com. For the password, I'll just do test123 and then test123. And with this, we should be good, and you should get a command that says the super user has been created successfully. So now if I do /manage.py run server, you're going to see that our server starts up, and now I can reload the app, and then I can input the username that I just used to create my super user. I can input the password. And if I log in, you're going to see that we're inside of the Django admin panel now. So with that, I think we have a fairly good understanding of a really powerful feature that Django provides us, the Django ORM. And I'll see you guys in the next video. Thanks. Hello everyone, welcome back. In this video, we're going to be talking about another powerful feature of Django, known as the Django administration panel. And what the administration panel does is that it allows us to interact with all of the data that's been saved inside of our Django application for all of the models that have been configured to actually show in the Django administration panel. So if a model for some reason is not configured to be shown in the Django admin panel, it by itself is not going to be shown here. The developer has to explicitly specify which models are allowed to be shown in the administration panel, and then you can see them. So for now, out of the box, Django only allows us to interact with the users and groups. So that's what we're going to go along with. Okay, so now what we can do to move forwards is that we can actually take a look at our users model, and then we are going to see that we get a list of all of the users that are registered in our application. Since we just created a user right now, we just have one in our application. But what you can do is to create a new one, you can either click on add here right besides the model name, or you can click on add user here, and then it'll take you to a form. This form is generated automatically, and this is a really powerful feature of Django where it looks at your model and automatically generates forms inside of the admin panel. And I'll create a user which I'll call test Hussein, and then what I'll do is that I'll just copy the same thing for the password and for the password confirmation, but I think this should fail because it should say that the password is too similar to the username. Let me just import a dummy password, save. And as you can see, the user is created. So now if I go back to our users, you're going to see that in our list of users, we get two different users. To delete a user, you can just click on this box, and then from there you can go to actions. From the dropdown, select delete selected users, click on go, and then just click yes, I'm sure, and the user should be deleted. The next thing we can do inside of the Django administration panel is that we can edit specific users as well, or any other specific instance of a model that we might want to edit. So if there was a group you want to edit, the logic would still be the same. To do that, what you do is that you can click on the username for the user, and then it'll give you a bunch of data that you can change about that user, such as are they active, do they have staff status, do they have super user status, their first name, last name. So what I'm going to do is that I'm going to update the first name and last name for my user to my name. I can click on save, and now the data should be updated. You can also filter by the users by all of the different filters that have been defined, and this all needs to be defined. But I can filter users by them having staff status. I can filter users by all of the users, the ones which have staff status and not have staff status, and all sorts of other stuff. You can also search for users, so you can type in, for example, Hussein, and you can click on search, and it'll try to find the user that has either this specific keyword in its username or email address. So for now, I think that is a good basic introduction to the Django administration panel, and we'll be coming back to it a lot during the development of our API in this course. With that, I'm going to end this video here, and I'll see you guys in the next one. Thank you. Hello everyone, welcome back. Now that we have a basic understanding of some of the features of Django, I think it is the right time for us to begin building our API. To do this, the first thing we're going to do is that we're going to be creating a new app, which is going to encompass all of the logic that surrounds our users inside of our application. So logic that corresponds to the profiles of a user, saving data for users, creating new users, and some permissions that are related to our API. So let's get into it. So the first thing I'd like you to do is make sure that your virtual environment is activated and that you've navigated into the folder that contains your manage.py file. In my case, that was source. From there onwards, what I'd like you to do is do /manage.py and then start app command. And then from there onwards, you're going to type in the name of your app. In my case, I'm going to name my app users, and then I'm going to do enter. As soon as you do this, you're going to see that a new folder appears inside of your main source folder, and it's users, and it's going to have some of the files which correspond to some of the files in like our RESTful API app, but there might be some additional files, some as models.py and test.py. Now what we have to do is that we have to actually tell our actual Django app that, oh, I have this new app that I've created and I want to link it to the main Django application. So the way you can do that is that you have to go to the RESTful API folder and then the settings.py file. And inside of settings.py, you're going to go to the installed apps list. Inside of there, you're going to add a new entry, and that is going to be the name of the app that we just created, which is users. Once you've done this, you can do just Alt-Shift-F and Command save, and you should be pretty much good to go. Now we can do /manage.py run server just to make sure that everything works and we don't have any errors. Okay, so now that we have done this, the next thing I'd like to do is that I'd like to actually create the model representation for our user. And what is the model representation, you might ask, because we already have a user model that's provided to us. Well, yes, that is true, but we also want to save some additional data for the user. And the way that I'm going to do this is that I'm going to create a new model, which is going to be called profiles, and this profiles is going to have a one-to-one relation with our user model. So each user in our application is going to have a specific profile that links to them, and that profile is going to store some additional information for that user. So we're going to open our models.py file, and then I'm going to create a new class, and I'm going to name my class profile, and then this class is going to inherit from models.model, and you can get models.model from the import, which is django.db import models. So we're going to do models.model, and then we're going to define the actual one-to-one relationship. So our profile is going to be linked to a user, and to define the one-to-one relationship, we are going to do models.one-to-one field, and then we're going to type in the actual model class. There are two ways you can actually type in the model class reference. One is that you can actually just import the model. To import the user model, what you can do is that you can, after the import for the models class, you can do from django.contrib.auth.models import user, and then you can set the one-to-one field reference to users, and then and then after that there's this one attribute which is really important, and that is on delete. And for now, what we're going to do is that we're going to set that to models.cascade. So what on delete means is that when the user model is deleted, what do we want to do with the profile model? What I want to do in the case of the deletion of a user is that I want to also delete the corresponding profile that they have. And that's why I've selected models.cascade. Once we have that, our relationship is actually defined. The next thing I'd like to do is that I'd like to actually set a new field for our profile, and that is the user's image. And since the image is actually a file, this is going to be a models.file field. And then what I'm going to do is that we're going to have an upload to directory. And this upload to argument means the path to where the image is going to be uploaded. In our case, I'd like to define a custom location where the images are uploaded. And the way we're going to achieve this is that we're going to create a deconstructible class. So for that, what I'd like to do is that I'll like to create another class, and I'll call our class generate profile image path. And then it's going to inherit from object. Once we have this, we need to import a really special constructor that's provided to us by Django, and it is called a deconstructible. So from django.utils.deconstructible, import deconstructible. And what deconstructible does is that it allows our class to be taken in by Django and be converted into a migration. Remember that anything that relates to a model, for it to be represented in the database, Django first needs to create a relevant migration for it and then perform that migration on the database. So a deconstructible decorator on top of our class, which is generate profile image path, would allow Django to create a actual migration for it. Without this, this method would not work, and you would actually get a lot of errors. So then we're going to define the init method, and we're just going to do pass for it. And then I'm going to define another method, which is __call __. And then for this, we'll have three different things that get passed to us, which is self, then the instance, and then the actual file name. So this is stuff that's going to be given to us by Django. First thing I'm going to do is that I'm going to extract the extension of our file. So that is going to be file name dot split, and I'm going to split the string using the dot separator. And then from there, I'm going to take the extension out. Then I'm going to define the path for where our file is going to be saved. So I'm going to use this really handy dandy feature in Python 3, which are called f strings, where you put an f and then you start your string. And this allows us to actually embed variables within our string. And the location where I'd like to save our files is going to be media/accounts/ and then I'd like to actually take the user ID of our user. So that'll be instance.user.id. Instance in this case refers to the instance of the model that the field is on. So our image field is inside of our profile actual model. Hence, the instance in this case refers to profile. Hence, we do instance.user.id. Once we have this, we're going to do /images. And then finally, we can close off the string with a single quote. Once that is done, the next thing I'm going to do is that I'm going to define the name of our file. So the new name, and the new name for our file is going to be another f string, which I'm going to do profile_image, and then dot, and then the actual extension that we had extracted in the previous step. And finally, we'll return the complete path, which I'm going to do using os.path.join, and then I'll join the path and the name. And before you can do save and run the application, what I'd like you to do is actually import os as well. So once we have this, the next thing we're going to do is that we're going to create a variable which are called user profile image path. And from here, I'm going to set it to a new instance of our generate profile image path class. And then the upload to directory is now going to be set equal to this variable. And now our user images are going to be saved in the proper location. Now, once we have this, the next thing I'm going to do is that I'm going to just set this one field that is blank equals to true and null equals to true. So null equals to true is fairly simple, and that just means that the value for this field inside of our SQL table can be null. And then blank just tells Django that in Django admin, if we do not provide a value for the image, then it's considered okay, and Django shouldn't raise an error. Finally, what I'd like to do is do command save, and I'd like to perform this migration on the database. To perform the migration, what we're going to do is /manage.py and then make migrations. And as soon as you do this, you're going to see that it's going to give you an output that says that for the users app /migrations, I've created a new migration for the model profile. And then there should also be a folder inside of the users application which says migrations, and then you should see your initial migration here. So once we have a migration, it's time for us to apply that to our database. So we're going to do /manage.py migrate, and this should apply the migration to our database. Now we are actually ready to run the application. So once we run our server and reload our web app, it should work. But now if I go to our admin dashboard, you're going to see that we cannot see any profiles. So how do we fix that? Well, what I'm going to do is that I'm going to actually register our profile for the admin dashboard. To do that, what you do is that you go to the admin.p file, and this is going to be inside of our users app. And from there, what we're going to do is that we're going to firstly import our profile model. So .models import profile. And that what we're going to do is that we're going to do admin.site.register. And then here what I'm going to do is that I'm going to provide it with the profile model. Once this is done, I'm just going to do command save, and I'll remove this comment as well. And then if we reload our admin, and now profile shows up. So now the next thing I'm going to do is that I'm going to go to profiles, and you should see that we don't have any profiles. So I'm going to click on add profile. I'm going to select our user, and then I'm just going to click save. And you're going to see that we get this object created for us, which is profile object. But I do not like the way that the object is being displayed in the list, and I would like to get much more detail as to what object I'm looking at. So to do this, what we can do is that we can go back to our models.py file, and inside of our actual profile class, we can define a new method, which is the definition __stir __. And then what we can do is that we can inside of here actually define the string representation of our actual class. So we'll get in the actual self, and then from here what I'll do is I'll create an f string, and I'll return the actual self.user.username. And then after that, what I'd like to do is that I'll like to say profile. And then finally, what I'd like to do is just do command save. So now if I reload our admin page, you're going to see that it gives me Hussein's profile. So now I'm getting the different string representation for our model. And I think it's really handy to be able to kind of instantly see whose profile we're looking at. Okay. Finally, what I'd like to do is that inside of our profile, I'd like to have this like read-only field, which like tells me the ID of the user profile. So for that, what we can do is that we can go to our admin.py file, and inside of our admin.py file, I'm going to create an actual model admin class. And a model admin class, what it allows us to do is that it allows us to specify how the data regarding a specific model is going to be shown inside of the admin interface that Django provides. For this, we create a class, which is profile admin, and you can name your class whatever. I usually like to name it the name of the model followed by admin, and then it inherits from admin.modeladmin. Once that is done, I'm going to define a new field inside of it, which is going to be read-only fields, and then we'll set that to ID, and then that's pretty much it, and do command save. So now if I reload the profile, nothing happens, and the reason for that is that I have to actually register it as well. So I'm going to do a comma and then put in the profile admin for the admin.site.register. So the second argument that you provide is the argument for the actual model admin. And we are getting an error which says that the value read-only fields must be a list or tuple. So just add a comma, I guess, and that should fix the problem. Yes, it does. And now if I reload, you're going to see that we get an ID for the model. Okay, so with that, we have a basic implementation of our user model inside of our API. And I'll see you guys in the next lecture. Thank you. Hello everyone, welcome back. In the previous video, we had created our profile class, but there's this one key problem that some of you might have sensed already, and that is that every time that a user is created in our application, we do not want to manually create a profile one for them. We might want to automate this process. And to do that, what we're going to do is that we're going to use a really powerful feature in Django, and that's called signals. What you can think of signals in Django is that they are a way of getting a notification every time something changes in our models. So for example, if a new model is created, we might want to get a notification and might want to perform specific actions. And that is the right use case for using signals. So let's see how to implement signals inside of Django. So the first thing I'd like you to do is that inside of your users app, I'd like you to create a new file and I'd like you to name it signals.py. Once we have this file, the next thing I'd like you to do is that I'd like you to import the actual user model that is provided to us by Django, because we want to listen when something happens to that model. So I'm going to do django.contrib.auth.models. And then from there, I'm going to import user. Once we have that, the next thing I'd like to do is that I'd like to import these signals that I would like to actually receive notifications about. So the signals that we are concerned with as of now is just two signals, and those are post-save and pre-save. So as the name implies, post-saves gives us a notification once a object has been saved in the database, while pre-saves gives us a notification before an object is about to be saved in a database. Finally, I'd like to import the actual decorator that is going to help us actually perform the specific actions that we might do when a specific signal comes about in the application. So for that, we'll import the receiver decorator from Django.dispatch. Finally, I'd also like to import the profile model from our models file. And now we are ready to define a new signal. So what I'm going to do is that I'm going to create a new function, and this function is going to be create user profile. And then what this function would get is a sender, an instance, and then a created, which is an actual bool, and then some keyword arguments, which will say ** quarks. The next thing I'm going to do is that I'm going to do an if statement, if created, and created is a bool, which is only true for the first time that the object is actually created in the database. And if the object has just been created, we want to create a new profile object for that specific object. So I'll do profile.objects.create, and then what we have to do is that we have to set the user for that profile that we're just creating to the actual user instance that gets passed into us. And you might ask, where do we get this instance from? Well, the instance is given to us in the actual method definition, so it gets passed in. And this instance is the instance of whatever object the actual signal is generated from. And now to finally link this method to actually run every time something happens on a specific model, we'll use the add receiver decorator, and then we are going to give it the actual signal that we want this method to be run on. And in this case, we want the method to be run post-save. So once the actual user has been created in the database and saved, and then we actually tell her which model is going to send us the signal. And the model that is going to send us the signal is going to be user. So in essence, what we do is that we have this decorator that says every time something happens to a user model, and that it's saved, I want you to run this function. Inside of this function, we check to see like the instance of the model that just sent us this actual signal. Was it just created right now inside of the database? If that is true, then we actually create a new profile and link it to the actual user. And for that, we do profile.objects.create, and then we set the user to the instance of the model that gets passed into us. And since we know that the instance is going to be a user, we can be confident that this code should work. So after this is done, you can do command save and clear and run the application again. But if you create a new user right now and actually go back to your profiles, you're going to see that no new profile is created. Okay, so if now we could try to create a new user, and I'm just going to call this test user, and then do this again and do save. The password fields didn't match. Let me do that again. You're going to notice that if we go to our profiles, that a new profile is not created for a user that was just created. And the problem for that is that we are not importing our signals anywhere inside of our actual app, and Django has no clue that there are these signals that need to be run. So for that, what we'll do is that we'll go back to our apps.py file, and inside of our apps.py file, we're going to define a new function under the actual users config class, which is ready. And then for inside of the ready function, we're going to actually import the users.signals. We're going to do command save. And you can go and try to create a user again. I won't be doing that, but it's still not going to work because there's like this one really crucial step that still needs to be done. And that is that inside of our __init__.py file for our users app, we have to define the default _app_config, and then set that equal to our user's default app config. And as you saw in the previous step, that the default user app config is inside of our apps.py file, and then it's called user config. So I'm going to set our default app config to users, which is the name of our app.apps.users config. Once we have this, you can do command save and rerun the app, and hopefully there are no errors. So now what we can do is that we can create a new user. So I'm going to create a new user. I'll call him Harry, and then Potter, and then I'm going to set the password, save. And if you go to profile, you're going to see that a new profile is created for Harry Potter, and that the actual user is also set to the correct instance of the newly created user inside of our application. So with that, we've like automated the process of actually creating a new profile every time a new user is created in our profile. The next thing that I'd like to do is just go to the user and just update the first name, the last name, and then the actual email for them. And that's harrypotter.hogwarts@hogwarts.edu, and then just do command save, or save, sorry. And then with that, I'm going to end this lesson here, and we'll continue developing our user application in the next video. So thank you for watching. Hello everyone, welcome back. In the last video, we had created our signals.py file, in which we had a new receiver function that every time a user was created inside of our application, we would create a corresponding profile object for them. And now I think it is the right time for us to begin creating our first functionality for our REST API. So without any further delay, let's get into it. So the first thing I'd like you to do is that I'd like you to make sure that the virtual environment is activated, and then I'd like you to install 3 different packages. So you can do pip install followed by Django, and then it's going to be REST, so no space, REST, Django REST Framework. Once you have this installed, you're going to install the optional markdown package. So markdown, pip install markdown. And since these requirements are already satisfied for me, that's why I'm getting that output. But hopefully this goes through, and then you have all of the required packages installed. And the last package you need to install is Django filters. Okay, so once we have these 3 package is installed, what I'd like you to do is that go to your settings.py file and then include the REST Framework app inside of the actual installed apps list. So we'll add the REST Framework app, and this would tell Django to actually use this application now. And then once we have this, then last thing we can do is that we can just do manage.py run server to make sure that we have no errors and the server runs. Okay, so with that, we are ready to actually start making the first few endpoints for our REST API. So in general, Django REST Framework works upon these three distinct parts. We have routers that actually route the traffic that comes to our API to a specific endpoint. Following a router, we have view sets, which are, you could think of as method handlers, which allow the API to understand the context of the request that's being given to it and then return the appropriate data back. In the case of a GET request, it might return data for a specific instance, while in the case of a POST request, it might take some data and then use the appropriate logic that's inside of our API to actually save that data inside of our database. So following a view set, the last part is a serializer, and that's the thing that we're going to be creating in this video. A serializer is a class inside of our Django application that allows us to take in complex query sets and model instances and then convert them to native Python data types that then can be rendered into either JSON, XML, or any other sort of content type. Serializers also have this unique ability to perform deserialization, where they'll take in some parse data that's already been validated and then convert it back into those complex data types. Okay, so now that we have a basic understanding of what serializers are, I think we are ready to actually create our first serializers. So inside of our users app, we're going to create a new file, and I'm going to call it serializers.py. Once we have the file created, the next thing we're going to do is that import some necessary stuff. So we have to import the actual user model, because the first serializer we're going to be creating is going to be the serializer for our user model. So django.contrib.auth.models import user, and then finally we'll import from REST framework the actual serializers. To define a serializer, you create a class, then you name your class, and in my case what I'm going to do is that I'm going to name it the name of our model followed by the serializer word. And then once we have this, we can actually inherit from serializers.model serializer. Once we have this, we can actually define a meta class inside of which we tell the serializer what model it can actually link itself to. In this case, it's user, and then finally the fields that we want it to actually act upon, and those are going to be URL, and URL is going to be tricky to understand right now, but for now just think of URL as a URL to a specific instance of the object that's inside of our API. So for example, the URL for a specific user or the URL for a specific profile that's inside of our API. So if you think it's a bit confusing right now, don't worry, don't fret. Once we actually create our API further, you're going to understand clearly as to what URL points to. And then the next is going to be ID. ID is simply just going to be the ID of our model, then the username, email, the actual first name, followed by last name, and finally email. Once we have all of these fields defined, we can do command save. And with that, we've created a really basic serializer inside of our application. So now with this, I'm going to end this video here. And now in the next video, we'll actually create the corresponding view set for our serializer, which would then define the actual method handlers that can then be used to actually perform appropriate actions based on the context of the request that gets passed to us. Thank you. Hello everyone, welcome back. In the previous video, we had created our first serializer inside of our Django app, which was the user serializer, which will now allow us the ability to actually take our user model instances and then convert them to native Python data types, and then create a JSON representation for them, while on the flip side also allow us the ability to deserialize already validated parsed data and then convert it back into our user model instances. So with that, the next thing we're going to do is that we're going to create a view set. So a view set is like one of the super cool features of Django REST Framework. View sets are just a class-based view, but instead of providing us method handlers like get, post, patch, and delete, what they do is that they provide us actions such as create, retrieve, update, and destroy. Django REST Framework allows us to actually combine the logic of a set of related views into a single class, and that is what a view set is. So now that we know a bit about view sets, the last thing that I'd like to mention is that once we have our view sets, we'll create an additional class which is called the router, and then router just takes in our view sets and actually registers all of the routes that are linked to that specific view set. So after our router has determined which controller, and controller in this sense means the view set it has to pass the request to, the view set is then responsible for actually making sense of the request and doing the appropriate response. So the first thing we're going to do is that we're going to import the user model from django.contrib.auth.models. We're going to import user. Once we have that, the next thing we're going to do is that from the REST framework package, we're going to import the actual view sets. Once we have these, we can actually define the class-based user view set. So user view set, similar to the naming convention that I followed for my serializer. The naming convention here is the name of the model followed by the actual view set. Then what we'll do is that we'll inherit from viewsets.model view set. So once we have this, the next thing we can do is that we can define the actual query set that our actual view set can act upon. So the query set just tells the actual view set as to objects of a specific model inside of our database the view set has permissions over. So in our case, what we can do is that we can set it to user.objects.all. So all of the users inside of our database. Then we define the actual serializer class that our user view set is going to use. So to do that, what we'll do is that from our actual serializers file, we're going to import our user serializer, and then we'll set that equal to the serializer class. Once we have this, we have actually defined our user view set. And since we were using viewsets.model view set, it'll actually give us an implementation of all of the actions such as create, list, retrieve, and update. And these actions are things that then get mapped to the specific REST API methods such as get, post, patch, and delete. So in the case of a get request, we can either have a get request where we want to pull down all of the users inside of our application, or get a specific user inside of our application. Depending on the use case, we might either call the list function or we might call the retrieve function, which would just return us a single user. All of those actions are then actually implemented inside of our model view set. As you can see, a view set that provides default, create, retrieve, update, partial update, destroy, and list actions. Hence, we do not have to define them ourselves. But if we were using the generic view set, which instead of view sets, we were using model view sets. So instead of using a model view sets, we would have been using viewsets.viewset. Then we would actually have to define the actual different methods such as list, which would take self and request. Request just refers to the request object that gets passed to us. And similar to this, we would also have retrieve, and retrieve would have logic for actually retrieving specific model or specific objects from the database for a specific model. And list would have similar data to retrieve, but list would return a list of objects, while retrieve would just return one. But to make our development lifecycle easier and much more efficient and less prone to bugs, we can just use model view set. So once we have this, we do not have to define anything else when we can do command save. Okay, so now that we have a user view set defined and we understand some of the basic functionality that a view set gives us and the different types of view sets that we can actually inherit from. So with that, I'm going to end this video here. I'm going to see you guys in the next one. Hello everyone, welcome back. In the previous video, we had actually defined our first view set for our user model. But for now, our view set is inside of our application, but we do not have any actual URL endpoints that point towards our user view set. A router is a quick way of declaring all of the common routes for a given resourceful controller. The resourceful container in our case is the user view set. So what we can do is that we can, inside of our users app, we can create a new file and we can call it router.py. Once we have this, the next thing we have to do is that we have to actually create a router. So to create our router, the first thing we have to do is that we have to import from REST Framework the actual routers. Once we have that imported, next thing we have to do is that we have to import the appropriate view set, because our router needs to know which resourceful controller it is going to take into itself and then actually produce the specific routings for it. So in our case, the only user view set we have for now is user view set, so we'll import that. Then we'll define the name of the app. This name of the app recommended needs to be the same as the name of your actual app in which you're creating the router.py file. In our case, it's users. Okay, so once the app name is defined, the next thing we have to do is that we have to create our router. So to do that, I'm going to create this new variable and I'm going to set that equal to routers.default router. Okay, so once we have created our default router, we have to register a route. So to do that, I'll do router.register and we are going to pass in the user view set. But before this, we also have to pass as the first argument the actual endpoint, after which all of the routes for our user view set are going to be mapped. So for that, I'm going to set that to users, and then we can do command save. Once we actually create the actual URL definitions and actually import the router, the actual naming convention here is going to make sense to you. But make sure that the app name corresponds to whatever name of the application that you've created is. So for example, in the case of our users app, I've named the app name variable inside of our router.py file also users. So once we have this done, basically all of the settings that relate to actually setting up Django REST Framework are pretty much done. So the request is going to start off by being given to the router. The router is going to route the request to a actual view set. And then the view set is going to have the appropriate actions inside of it, which if we go and hover over model view sets are create, retrieve, update. And then depending upon the context of the request that gets passed to us, it'll call either one of these actual methods, and then dependent upon that, we'll have an appropriate response given to us. And then for the actual serialization and deserialization process, the view set is going to use our serializer, which will know how to take a model instance and convert that to a JSON representation, as well as take in parsed data and then convert that back into a model instance representation, while also allowing us to interact with the model by giving us a Python data type. So with that, we're good to go. The last thing we have to do is that we have to define the actual URLs inside of our application, which are then going to map to our specific router and actually are going to register our router inside of our main application. So we're going to do that in the next video. So see you guys then, and thank you. Hello everyone, welcome back. In the previous video, we had created our default router for our users app, and now what we have to do is that we have to actually tell Django that it has to actually use our router. So to do that, what we can do is that we can go to our RESTful API app, and then inside of there the urls.py file, and then inside of our urls.py file we're going to actually define the URL schema, you can say, for our actual API. So I want my API to be at a specific endpoint, and that is going to be /API, and then after that we're going to have all of the functionality for our API inside of there. So to do that, what I'll do is that firstly I'll define a new list which I'll call API URL and then patterns, and this is going to have all of the different URL endpoints that I want our API to have. So once the API URL patterns list is created, I'm going to add a new path to it, and a path will actually register our actual routes inside of our router that we had just created. So we'll give an actual endpoint after which all of the routes that have been registered inside of our router can be accessible through. So for my case, what I want is that I want it to be /API/account. So inside of our API URL patterns, I'll set accounts and then /, don't forget the ending slash. And then what I'm going to do is that I'm going to use a handy dandy function provided to us by Django, which is include, which will take in all of the URLs that our router gives us and then actually add them to the path. So to do that, I'll do include. And then from include, what I'll do is that I'll firstly import our actual router. So from our actual users app, I want to import the router file, and as users, and then underscore API underscore router. Once we have this, I'm going to take the users API router, and then from there, I'm going to do router. And then finally, I'm going to do dot URLs. So all of the URLs that are registered by a router. And now we've actually taken all of the routes that are defined by our actual router, and then we've added them after the accounts endpoint. And now we can do save. So now the last thing we have to do is that we have to actually add the top level API endpoint, you could say, for our API, which is /API. And to do that, I'm going to use that function again, path. And this time I'm going to add everything that's inside of our API URL patterns after the API endpoint. So API slash, and then everything that's inside of our actual API URL pattern. So I'll use the include function, and then I'll pass an API URL patterns. So now the way this is going to work is that we are going to have the actual top level domain name or the host name for our API, which in this case is going to be 127.0.0.1 port 8000, after which we are going to have /API, which is going to allow us to access all of the different endpoints that we have for our API. To access the specific endpoints that relate to our users API router, we're going to go to the accounts endpoint. And then from there, to actually access the users, we define that inside of our router.register users endpoint. So we can use users, and then we should have access to all of the available actions that are provided to us by the user view set. So with that, we are pretty much good to go. All we have to do is that we have to do command save, and then we can finally run our API after an eternity, make sure that we have no errors. And now what I'd like you to do is that I'd like you to first just navigate to 127.0.0.1 port 8000, after which I'd like you to go to /API. From there, we'll go to accounts. And as soon as we go to accounts, you're going to see that we get this GUI, which says is the default basic route for our default router. So this actual interface is provided to us automatically by the default router that we had created inside of our router.py file. From here, we can see all of the different endpoints that we had registered. So users was the first one that we had done. And if we click on user, it takes us to our actual user view set. And in the case of the current context of our request, where we're requesting all of the users because we just went to the /users endpoint, and Django considers that to be a request where the user asks for all of the different users that are inside of application. We get a list of users returned to us. And then if we click on a specific URL for a specific user, we can go and see the specific user. And now it might make much more sense to as to what were all of the actions that we had inside of our actual view set. So in the case of the /users endpoint, we would actually call the actual action, which is list, and it would list all of the different users. But when we would actually go to a specific URL requesting for a specific user instance, then we would actually use the retrieve action. And then if we did delete on a specific model instance, then we would have actually the destroy action being called, and the logic continues like that. So with this, the last thing that I'd like to mention is the actual representation you're seeing for our user. This is what the actual serializer is being used for. So for example, if I just remove the ID field from our serializer and I do command save, and then I actually reload our app, you're going to see that the ID is not shown anymore. And if I add it back in, the ID is shown again. So with that, I think we have a basic understanding of the three core components of Django REST Framework, which is the serializer, the actual view set, and then finally the router. So with that, I'm going to end this video here, and thank you for watching. Hello everyone, welcome back. So now that our user serializer is actually working and it is giving us a list of users, and we also have the functionality now to actually go and actually see specific user instances, the next thing I'd like to do is that I'd like to allow the end user the ability to actually create a new account inside of our API by sending a post request to the /API/accounts/users endpoint. So to do this, the first thing we'd like to do is that we'd like to actually add a new field to our user serializer, which would allow end users to actually pass in additional data that might not be included inside of our actual model. And in this case, what I'd like to do is that I'd like to actually define a new field inside of our serializer, which is going to be password, which will allow our user to actually pass in a password to our serializer and would allow our serializer the ability to understand what to do with the provided password. So I'll set the password equals to serializer.character field, short, that's actually char field. And then I'll set this equals to write only equals to true. And then also required equals to false. So required just means that this field is not required for every request that is sent to the user serializer, and that this is an optional field. And write only just means that when an actual JSON representation for the object is actually created by the user serializer, it does not need to include the password. And this is just for security reasons as well as a good practice as well, because we do not want to show the actual password hashes for users on our API, because there's no need to do that. So now that we have defined this field, the next thing I can do is that I can actually tell the user serializer to use it. To do that, I'm going to add the field to the actual fields list and make sure that the names match up, and then do command save. Reloading, you're going to see that now we are actually given a new field for the password. Now, some of you might be wondering, why did we actually add a password field when there is already a password field defined inside of our user model that is provided to us by Django? And the reason for that is that I want to define custom logic for the actual password field. Because if I comment this actual field out and I do command save and I reload, you're going to see that not only are we allowed to actually have the password sent, but we also get the actual password as a key inside of the actual JSON representation for every user object. And that is a big security concern. So to mitigate that, what we do is that we define our own password field, and then we set that equals to just write only, so that it is just a write only field and is not included inside of our JSON representations. And then that solves the issue. And since the field name here matches exactly to the field name that is inside of our actual model, which is the user model, Django knows how to internally link them and take the data that is provided here and put that inside of the specific password field. So now that we have the password field and our user serializer actually expects a password, the next thing we want to do is that we want to tell our user serializer what to do with the password. So to do that, what we're going to do is that inside of our user serializer, we're going to override a method that is provided to us by the model serializer class, which is create. And we're going to be defining it ourselves instead of using the default implementation that's provided to us by model serializer. As mentioned in previous videos, user serializer does have the ability to deserialize data and then actually create objects out from the data that gets passed to it. That's why we have this create function, and this create function is called every time a post request is sent to the actual user serializer. There are two arguments that are actually received by our create method. The first is just self, and then the second is validated data. Validated data includes all of the key value pairs that our user serializer has inside of the fields, which are set to write mode. So if there's something that is set to read only, that is that if I have a password field, for some reason I set that to read only. So for some reason I only want to actually show the passwords, but I don't want the user to have the ability to set them, and I set that read only equals to true, then this key is not going to be included in validated data. But we'll just change that back to the way it was, which was write only equals to true. So now once we have the create function, the next thing we have to do is that we have to define the logic inside of the create function as to how to actually go about creating a new user. So the first thing we'll do is that we'll extract the password from the validated data by doing validated data.pop and then passing in the key, which is password. And what pop would do is that it would return us the value for the key inside of validated data, which is password, but it'll also make sure that the password key is then removed from validated data and is no longer present inside of it. Then we'll create a new user and we'll set that equal to user.objects.create. And then we'll use the 2 asterisks, which will expand our dictionary of validated data and pass them in key by key. And then after that, what I'll do is that I'll do user.setPassword, and I'll set the password equals to the password, and this function is automatically going to take care of all of the hashing logic. So what user.objects.create is going to do is that it is going to create a new user object inside of our database using the validated data fields that are provided to it. But then it is also going to return that user and have it saved inside of our user variable. We'll then use this user variable to actually set the password for the newly created user. And then finally, we'll perform a transaction on our database, which is user.save. And this is because we had just changed the password and we want to actually then perform this transaction on the database. And finally, we'll return the user because the create function actually expects us to return the actual instance of the model that was just created and then do command save. So with this, we've defined all of the logic that is required for actually creating a user. So now with this, I'm just going to reload our page, make sure that we have no errors. And from there, I'm going to try to create a new user. So for the username, what I'll do is that I'll set this equal to her and then Moini Granger. And then the next thing I'm going to do is that I am going to actually set the email address to hermione.granger@hogwarts.edu. Then for the first name, it's the same as the first name in the username. And then for the last name, it is going to be the same. You can do whatever values you want. And finally, what we'll do is that we'll set the password, and I'll just set the password to test123. And then we can do a post request. And you're going to see that we're going to get a HTTP 201 created response. And we're going to actually get a object returned to us for the newly created user object. And you can see that we get the user ID is 6, the URL to see the specific user is this, their email, first name and last name. Now, if we just hop on over to our actual admin panel and we go to home and we click on users, you're going to see that a new user has been created. But if we go to profiles, you're also going to notice that our signals actually did work, and the profile for the newly created account for Hermione Granger was also created. So with that, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, I'd like to bring your attention to a really specific error inside of our API, and that relates to the creation of a user. If we have a post request that is sent to our API where the username corresponds to the username of a user that already exists inside of our API, we are going to get an error. And I can demonstrate that by actually just trying to create a new user with the same username as a user that already exists in our API. I'll set a totally unrelated email, just a dummy email. For the name, I'll also set that equal to the same name. And then finally, I'll set the password to test123. If I try to post this, you're going to see that it gives us the error, a user with the username already exists. What I'd like to do actually is that I'd like to add the ability inside of our API so that usernames are generated automatically. And then the user just has to provide their first name and last name. And based upon that, the usernames are automatically generated and the users cannot change their username. So to do that, the first thing we have to do is that we have to actually define the ability inside of our API to actually create usernames. For that, we're going to be actually using signals. So to start off, the first thing I'm going to do is that I'm going to remove the ability for our users to actually change their username. To do that, I'm going to go to user serializer. And then what I'll do is that I'm going to define a new field, which I'll call username. And I'll set that equal to serializers dot car field. And then I'll just set the read-only property for this equals to true. And now you should see, and this has to be read-only. And now you should see that once we just restart our API, that we have lost the ability to actually change our username because that field is not available anymore inside of the post form. Okay, so once we've done this, the next problem we'll run into is that since we're not providing a username anymore, when we call our user.objects.create function, it's going to give us an error saying that it expected a username, and we have to fix that. So to fix that, what we're going to do is that we are going to create a signal inside of our users app, which is going to actually listen to a very specific signal that is going to occur before a model is saved inside of our database, and then actually set the username for that specific user model. To do that, we'll go on over to our signals.py file, and we're going to then create a new function. And what I'm going to do is that I'm going to create that function below our create user profile function, and I'll set that function's name as to set username. Then what I'll do is that I'll have a sender as one of the arguments, then the actual instance as another argument to our function created, and finally ** quargs, any additional keyword arguments that might get passed to our function. I'll add the decorator on top of our function, which is going to be the receiver decorator. And the signal this time that we're going to be listening to is going to be pre-saved. So before the module is actually saved to our database, and before Django does the actual validation that our model actually conforms to our schema definition. And then I'll set the sender equals to our user model. Once we have this done, the next thing we have to do is that we have to define the actual implementation for set username. So what we'll do is that firstly, we'll check to see if the instance that is given to us is not having a username. So I'll do that by doing if not instance and then dot username. So this means that our username for our instance is null. That means we have to set our username. What I'll do is that I'll set that equal to username equals to an f string, and then I'll do the first name. To do that, we'll take the instance and then dot first name, followed by an underscore, followed by the instance dot last name. And then all of this is all lowercase because I want our username to be just lowercase. Once we have this, the next thing I'm going to do is that I'm going to define a counter. And the reason we're defining a counter is that what if we get a request by a user that has the same first name and last name as some other user that is already registered inside of our application. If that is the case and we do instance.username and then we set that equals to the username that we had just created, we're going to get an error that would say that the username that we are trying to set for the user that was just created matches to a username that is already existing inside of our API. So we don't want that. To do that, what I'm going to do is that I'm going to create a while loop where we'll have user.objects and then .filter. And then we'll have the username equals to username. So what the user.objects.filter is going to do is that it is going to go through all of the users that are inside of our API or inside of our database, sorry, and it's going to check to see all of those users which have a username that matches to our username variable, and then return a list of those usernames. We're going to loop through, and every time there is a username whose username matches to our username, we'll append the counter's value by +1. So for that, I'll do plus equals 1. And then what I'll do is that I'll set the username equal to the f string, which is the instance dot first name. So I'll just copy this over here. But instead of just having instance dot last name as the last thing, we'll also do an underscore and then followed by the actual counter value. And this should make sure that all of the username inside of our API are unique. What I'll also like to do is that I'll like to copy this actual increment after our actual username so that we have usernames that don't start with 2 but actually start with 1. And finally, the last thing we have to do is that once we exit out of our while loop, we have to set the instance.username equals to username. And you do not have to call instance.save. And the reason for that is because this was a pre-save signal, and hence Django is automatically going to call save later on in the actual life cycle of the model instance, and we don't have to call it ourselves. So with this, we've actually defined the function. So just going over it again, we first check to see if our instance has a username. If it doesn't, then we actually create a new username and we set that equals to all lowers. We then define a counter variable. We go through our API to check to see and make sure that there are no users which have the same username as the username that we had just generated. So for every time that happens, we actually generate a new username where we have the first part of the username as the same, but we just tag on an underscore and then the actual counter value, and then we just make sure that it's all lowercase, and then we increment our counter. Once we've made sure that there are no username clashes, we just set the instance.username equals to username, and instance in this case is our actual user model because the sender for this actual receiver decorator is the user model. So with this, we can do command save, and our signals should work because we in previous videos had already done all of the other implementation for signals.py file. So with this, I think we are actually ready to test the creation of a new user inside of our API. So what I'm going to do is that I'm just going to create a new user inside of our API, and I'm going to create the new user as Hermione Granger. So I'm going to just copy the first name for the last name for Granger, so we have the same first name and last name. Hopefully the username would be different. Then I'll set the password, just test123, and the email to the same email as this, or we'll just set it to usain.mustafa7890@gmail.com, just a dummy email. If I do a post request, you're going to see that we have a error that says set username missing one required optional argument. And the reason we got this error is because of the actual created key that is inside of our set username function definition. And we have to remove this because the created argument is only passed in for post-save signals, not pre-save. So if you do command save, we go back. So if I just copy this first name again, this last name again, and then paste in test123, then for the email, use the same email and click post, you should see that the new username for the user that we just created has an _1 tagged onto it. And this would make sure that all of the username inside of our API are unique, and we do not get any issues where people with the same name are having difficulty registering inside of our application. And we've also disallowed the ability for users to actually change their usernames. So with this, I'm going to end this video here. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, I'm going to be talking about permissions inside of Django REST Framework. So authentication by itself is not usually sufficient inside of a REST API because there might be instances where we might want to limit the amount of actions a certain user can perform and only allow certain actions for users that have certain privileges. And for this, we might want to have additional checks in place inside of our REST API. So for now, the first thing that I'm going to do is that I'm going to log down our REST API into a state where users that are not actually authenticated inside of our REST API, they can only see data or they can only perform GET requests. Anything besides GET, such as put, post, they cannot do that. So to define the global permission classes for your Django REST Framework API, what you do is that you go to the settings.py file for your Django application. And then you can scroll down to a suitable place where you would like to actually set up the permissions for REST Framework. I'm going to do that just above the, or just below the auth password validators. I'm going to first create a dictionary, which I'll call REST_framework, and make sure that the name of this dictionary is the same as I've showed here. And inside of here, we'll have specific keys, and for them, we'll have specific values. Since we want to define the default permission classes for REST API, The key that I'm going to be added is going to be called, in all caps, default, and then permission, and then underscore classes. With this, what we can do is that we can add the colon, and then this is going to be actually a list of permission classes. I just realized that I've added a plus sign here instead of an underscore, so I'll do that. Inside of our list, we can define as many permission classes as we want. In our case, REST Framework provides us a handy dandy permission class, which is called isAuthenticated or read-only. To see all of the permissions that are available, what you can do is that you can go to the Django REST Framework website, and then specifically to the section where it says permissions. From here, you can read a bit more about how permissions are determined and object level permissions. We're going to go into how permissions are determined later on in this video. And then you can also see the setting up the default permission policy for the API. So there are many classes that you could use, such as isAuthenticated, all of which you can read about on the side panel here. The one that we're going to be using is called isAuthenticated or read-only. And as you can see in the documentation, it says, the isAuthenticated or read-only will only allow authenticated users to perform any request. Request for unauthorized users will be only permitted if the request method is one of the safe methods, which are get, head, or options. So now that we understand what our actual isAuthenticated or read-only permission is going to do, how do we actually implement that? And for that, we just actually add the actual isAuthenticated or read-only class inside of the list for our default permission classes. So I'll do REST underscore framework, which is the name of the package. From there, we'll access the permissions package. And then from there onwards, we are actually going to use the name of the actual class that we want to use. And that is isAuthenticated or read-only. And be careful with the naming here. It needs to match exactly to what's specified in the documentation. Once we have this, I'm just going to add a trailing comma and do command save. Now, if I reload the app, you're going to see that I'm actually logged in, and that's why it's showing me the form. So for now, since we've not set up any authentication routes, to log out, you can just head on over to the admin panel, and then you can just click on log out, and then you can just reload the page for the actual endpoint API accounts users, and you're going to see that the ability for you to actually post stuff is now taken away from you, and the form has disappeared. If you log in again, you're going to see that the ability comes back to you. But this presents us with another problem. For first-time users that don't have an account, how are they going to create users if they do not have the actual permissions to actually post a request to the API for a user to be created for them? For that, what we can do is that we can define permission specific to a view set, which will then override the permissions that are defined inside of our default permission classes. So to define the permissions for our view set, what we can do is that we can go to our users app, and then I'm going to create a new file inside of here, and I'm going to call it permissions.py. Inside of permissions.py, we're going to actually create a class. I'm going to name the class is user owner, or, and then get and post only. And what this means is that if the user object that we are currently looking at, if the current user that is authenticated inside of the API, if he owns that user object, then he's allowed everything, all of the REST API methods. And if that is not the case, then we'll only allow the unauthenticated user, or the user that is authenticated but not the actual owner, just the post method and get method. So once we actually set this up, it'll make more sense. But before we can start actually setting up the logic, what we have to do is that we have to import the permissions package from REST Framework. So once we have permissions package imported, our actual permission class is going to inherit from permissions.base permission. So this is just the base permission class, which all permission classes should inherit from. And inside of here, what I'm going to do is that I'm going to first define this comment, which will actually let us know what this permission class does. So the definition or the use for this permission class is going to be that this is custom permissions for the actual user view set to only allow. And what do we want to only allow? We only want to allow users to edit their own profile. Otherwise, they can only see other people's profiles, or they can create new users. And for that, we have either get and post only. So once we have this, I'm just going to end our actual top level comment, and then we should be good. So now that we have this, the first function that we're going to define inside of our is user owner or get and post only permission class is going to be the has permission function, which takes in self, request, and view. And what I'm going to do is that I'm going to return true for has permission here. And the reason we want to return true is because the has permission function is only called for the two API methods, which are get and post. So has permission is going to be called every time we either want to make a get request or a post request. If we want to make requests that are specific to an object, such as put, which is to a request which is used to actually edit a resource that is already on the server, such as editing the email address of an already existing user and stuff like that, then we'll have another function, and that is called has object permission. And that also takes in self request view, but it takes in an additional argument, which is the actual object for which we are actually checking the permissions for. So an important thing to note here is that if has permission returns false, then has object permissions is never called. So if sometimes your permissions are not working, make sure that the logic inside of has permission allows the actual Django REST Framework permissions logic to actually execute the has object permission function as well. So inside of has object permissions, the first thing that I'd like to do is that I'd like to check the method of the request that's being sent to us, and we can access that through request.method. And then we'll just check to make sure that the method that we receive, if that method is just a safe method such as get, head, or options, then we can allow that to any user, whether they're unauthenticated or they're authenticated, or whether they're an owner of a profile or not an owner of a profile. And for that, what we can do is that we can use permissions.safe methods. So if the request.method is inside of the safe methods, then we can just return true. So this would allow any user to have access to the actual get request. Now, the next thing we'd like to check is to make sure that only users that are the actual owners of a specific object have the ability to edit it. Because for now, if I log back into the API, or just let me input the correct password, and I go back, you're going to see that if I go to a user profile that I'm not an owner of, such as the second one in this list, ID 4, I can still edit that, and I can still edit my own as well. So we're going to change that with this, where we're going to firstly check to see, and this is a check to see that the request.user is not anonymous, so is anonymous. And this will just make sure that the user that we are going to be checking against is not an anonymous user and that he's authenticated inside of an API, because only then will we have access to the actual request.user object, and we're going to compare that to the actual object. Object is in this case is going to be the object of whatever view set we place this permission class on. Since we're going to be placing this permission class on the user view set, and it is a view set that manages the user model, hence object in this case is going to be the user model object. And finally, if these two things do not work out and we just escape both of these statements, then we can just return false. And we can do command save. So now if we go back to the actual API/account/users and I log out of the API and then I reload, you're going to see that we do not have the ability to actually create new users because we still haven't implemented the actual class inside of our user view set. So now we're going to go back to our view sets. We're going to import the specific permission, and then it's going to be is user owner or get and post only. And then inside of our user view set, we'll define a new list, which is called permission underscore classes. And we'll set that equal to the is user owner get and post only. I'll add a trailing comma and do command save. So now I'm logged out of our API. And if I reload, you're going to see that this permission class actually overrides the global permission class that we set inside of our settings.py file here. Furthermore, all of the logics that is defined inside of this permission class now takes preference over whatever was inside of our settings.py file's default permission class. So the first thing that we want to see is that, yeah, for an unauthenticated user, we have the ability to actually post, which because of has permission is true, hence we have the ability to post. And then since has permission also works for the get request, I'll also have the ability to actually see all of the stuff here. If you go to a specific instance of an object, such as users1, then the has object permission function is going to be called. Since a get request is considered to be a safe method, we are allowed that as an unauthenticated user, but we do not have the ability to actually edit the profile. Finally, now what I'll do is that I'll go back and I'll try to log in to the API. And now I'll just reload that page, and you're going to see that the username should pop up in the top bar. And for now, it shouldn't do anything, but this is an indication that you're logged in as some kind of user in the API or the Django application. And now if I go to my own user, you're going to see that I have the ability to actually edit stuff. So what I'm going to do is that I'm going to change my name from Hussein Mustafa to Hussein Test, just to test this out, do a put request, and you're going to see that the actual object updates, and I'm just going to change it back. So if I now go back to another user object for which I do not have permissions or I am not the actual owner of, such as the ID for user, you're going to see that the ability for me to do a put or a patch request has been taken away from me, as well as the ability to delete. Well, all of those abilities are provided here. Finally, the last thing that I'd like to do is that I'd like to just show you what's going on again in the permissions. So for anything that relates to the actual endpoints where we grab a list of data or we actually make post requests, the has permission function is called. And for any other endpoints where we are specifically talking about a specific instance of an object, such as user/1, user/4, then the has object permission function is going to be called to determine the actual privileges that the certain user has over the resource that is being currently viewed. In our case, even authenticated users are still allowed to have access to save methods, but only users that own a specific resource are able to edit that resource, as you can see here. So with that, we've defined the first set of permissions for our user view set. And with that, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this lecture, I'd like to add the ability to our browsable API, whereby users can actually log in and log out using session-based authentication for our browsable API. As you can see, as of now, for us to actually log in or log out of our API, we have to go to the admin panel and then log in from there and log out from there. And that is something that is not only inconvenient, but also does not allow users that do not have admin privileges inside of our API to authenticate themselves. This is just one of the types of authentication that our API is going to be using, and later on in the upcoming videos, we'll also implement token-based authentication, which will thereby allow users to send credentials to our API, which is then going to respond with a JWT token, which is a JSON Web Token, which will be used in every subsequent request for the user to be authenticated. So without any further delay, let's get into it. So to get browsable API login and logout views working inside of our Django REST Framework API, the first thing we have to do is that we have to actually tell Django to actually use the login and logout views. And to do that, we have to go to our urls.py file. And once we are inside of our urls.py file, we have to actually define the URLs that we're going to be using for this type of login and logout logic. So I'm going to create a new list of actually authentication related API URLs that is not only going to encompass the authentication URLs for the browsable API login and logout, but also stuff that relates to authentication via tokens, as well as OAuth2 based authentication. But for now, we'll leave this list empty. And what I'm going to do is that I'm going to firstly check to see if our API is running in debug mode. And if it is, only then are we going to allow users to actually log in through the browsable API using the login and logout views that are provided to us by Django REST Framework. So to do that, firstly, we'll check to see if our API is in debug mode. And for that, we can import django.conf. And then from there, we can import settings. Then I'll check if settings.debug. And this settings refers to the settings.py file that is inside of our application. And you can see that on top we have a variable that is debug. So just check that variable, make sure that debug is set to true. And if that is the case, then we actually append to our auth API URLs. And what do we append? Well, we're going to append a path. And the path is going to be verify. And then after that, I'm going to include all of the URLs that are provided to us by REST framework in particular. So I'll do REST_framework and .urls. Once we have this, I'm going to do command save, make sure that our server runs. And now if you go to the base endpoint of our API, which is /API, you're going to see that nothing shows up now. And that is because we've not added the auth API URLs to our API URL patterns. So to do that, I'll add another path to our API URL patterns. Inside of here, I'm going to define the actual endpoint that is going to be used for authentication purposes, and that is auth. And then I'm going to include everything that is inside of our auth API URLs by using the include function and then passing in the list. I'm going to add the trailing comma, do command save. And hopefully if we now reload, you're going to see that we have API/accounts available or API/auth available. One thing to make sure is that you add these trailing slashes after each of your endpoints that you define here, else this is not going to work. So once we do this, you should hopefully see that we have these trailing slashes being shown. So now if I go to API/auth/, and then from there we have the actual verify endpoint, you can see that we have the ability to use the browsable API's login and logout features. So we can do login and we can do logout as well. And this will log me out. So now that we have this, the next thing we have to do is that we have to enable the Django REST Framework session-based authentication inside of our API. To do that, we're going to go to our settings.py file, and then we're going to browse down to where we have settings that are specific to REST Framework. And once we're there, we're going to be adding a new key inside of this dictionary, and it is going to be called default, then underscore authentication, and then underscore classes. And this will let our REST framework know which type of authentication classes are to be used inside REST framework. So once we have this, I'm just going to add a comment where I'm going to actually just type in that all of the stuff that I'm going to be adding here relates to REST framework authentication classes. And then the two authentication classes that we'd like to add are firstly the basic authentication and then the session authentication. So to do this, I'll do REST_framework and then .authentication and then finally basic authentication. And then similar to this, we'll also have another one which is going to be REST_framework .authentication .session authentication. If we did not use these and you actually logged in through the views that are provided to us by Django REST Framework that we had just added, you would see that the actual authentication flow would work, but you wouldn't have the actual session saved in the API, and hence you wouldn't actually be logged into the API. So once we have this, we can just do command save, And we can see that we get some errors, and it says that there's no module named REST Framework, and I think I've added a actual comma instead of a dot. So just reload, and the API now works. So what I'm going to do is that instead of using the admin endpoints login, I'm going to do API/accounts or API/auth/verify/login. And here I'm going to log in with the account that I had created for myself. And if I log in, you're going to see that the API redirects us back to the account/profile. So now that we have this, if I go to API/accounts, and then to users, you're going to see that I'm logged in, but I also have the ability to log out now. And if I click on log out, I'm going to log out. And now on top of our browsable API, you're going to see that we get this button, which will allow us the ability to actually log in using session-based authentication for our browsable API. So click on login, then I'll type in the credentials for our test account, log in, and you're going to see that we have session authentication enabled now, and we can easily log in and log out using our browsable API instead of relying on going to the admin endpoint and then logging in from there, which would not be possible for users that do not have admin privileges inside of our API. So with this, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In the previous video, we had successfully implemented the session-based authentication for our browsable API, where the user were able to now log in regardless of being able to access the admin panel or not and browse the API. In this video, what we're going to be doing is that we're going to be taking a look at how to implement token-based authentication so that our API, when given the proper credentials, can respond with a JWT token that can then be included in every subsequent request. And this way the users can be authenticated. And this is the main authentication mode that is going to be used by all of the third-party clients that are going to actually consume our API. So for example, this could be a web front end such as React or Angular. It could be a mobile development framework such as Flutter, and all of those would actually use this JWT token, which they would then in every subsequent request actually send with the request, and that way the server is going to be able to authenticate the user who's sending the request and then actually grant them privileges or access to resources as need be. So without any further delay, let's get into it. So the first thing we're going to do is that we're going to install a package. And all of the steps that I'm going to be taking can easily be accessed through the Django REST Framework's official docs. And the exact place that you have to go to, I'm going to show you guys, is that if you go to the official Django REST Framework website, from there you can go to API Guide, click on Authentication, then scroll down, and you can take a read as how to authentication is determined, and you can also see how we had implemented these default authentication classes. But now since we want to implement token-based authentication, what we're going to be doing is that we're going to be using a third-party package that is called Django REST Framework Social OAuth 2. Django REST Framework Social OAuth 2 is not only going to allow us to implement token-based authentication, but on top of that, it's going to allow us to actually implement OAuth 2 based authentication as well, where clients can actually go to Facebook, Twitter, Google, or other social plugins that provide OAuth 2 capabilities, grab a token from them, send that token to our server, and in response get a new token given back to them, and that token is then going to be used for every subsequent request. So you can think of the Django REST Framework Social OAuth 2 package as a package that takes the JSON Web Token Authentication package and then extends upon it by adding OAuth 2 functionality as well. So the first thing we have to do is that we have, and if you want to read more in detail as to what the actual package is all about, you can click on this link in the description and it'll take you to the actual GitHub page for it. So now that we have this, what I'm going to do is that I'm just going to drag this out and we are good to go. So the first thing we're going to do is that we're going to make sure, as always, that our virtual environment is activated, and we're going to install a package. And the package we're going to be installing is called Django REST Framework Social OAuth 2. Enter. And hopefully this goes through and all of the packages are going to be installed for you. Once this is done, what we're going to do is that we're going to now tell Django to actually use all of this stuff. To do that, similar to REST framework, we're going to go to our installed apps, and then we're going to be adding 3 new apps to it. And the 3 new apps that we're going to be adding are going to be, firstly, the actual app, the actual plugin that we had just downloaded. But apart from that, we also are going to add 2 additional packages or apps in this case that are automatically installed when we install the Django REST Framework Social OAuth 2 plugin. So the first one is going to be OAuth, then 2, and then provider. Once we have this, the second one is going to be social Django. And finally, we'll have REST underscore framework underscore social underscore OAuth 2, and then we can add a comma and we should be good to go. So with this, what I'm going to do is that I'm going to do command save. I'm going to just run the API, make sure that we get no errors. So yeah, as you can see, as of now, we might get some migration issues, and that's a good thing, because if Django can send some kind of migrations, that means that it was able to successfully load these 3 apps in. So now that we have this, the next thing we have to do is that we have to perform the actual migrations for these apps. And for that, what we can do is that we can do /manage.py and then make migrations just as a good step. And then we can do manage.py migrate, and this should actually perform the migrations on the database. Once we have these 2 steps, we can just run the server, and now the migration issue should be no more. Now that we have these, the next thing we have to do is that we have to go to our actual URLs, and we have to actually register the authentication URLs. In the case of the browsable APIs URLs, I only wanted to add them if the API was running in debug mode. But in the case of the authentication URLs that we're implementing right now for token-based authentication, regardless of whether the API is in debug mode or not, we still want to include the endpoints. And for that, what we're going to do is that we're going to add the actual endpoints to our auth API URLs list. So inside of here, I'm going to add a path. And then this path, I'm just going to leave it empty. So what this means that we're just going to have auth, and then after that, we're going to include everything. And then the endpoints that we have to include are going to be all that are going to come from the REST underscore framework underscore social underscore OAuth 2, and then finally .urls. Then I'll just add a trailing comma here, or not here, sorry, after the second closing bracket, do command save, and hopefully everything works. Now to make sure that this actually worked, what we can do is that we can go to /API and then /auth. And you're going to see that now we have a bunch of other endpoints in addition to our actual auth/verify endpoint as well. So all of these endpoints were just added by the Django Social OAuth 2 framework. So now that we have this, the next thing we have to do is that we have to actually add these context processors to our settings.py file. And to do this, what we're going to do is that we're going to go to the settings.py file inside of our app. And then we're going to actually browse down to a specific section inside of Django, which is called templates, as you can see here. And then inside of templates, we're going to have a section which is called context processors. Inside of here, what we're going to do is that we're going to add 2 new context processors. The first is going to be social underscore Django dot context underscore processors, and then dot backends. And then from there, we're also going to add another, and that is going to be social underscore Django dot context underscore processors, and the P is does not need to be capital, processors, and then dot login underscore redirect. Make sure you add these 2, and then do command save. Hopefully the app reloads without any errors. So now that we have this, the last thing we have to do is that we have to tell Django to actually use the JSON Web Token authentication. To do this, what we have to do is that we have to go similarly to what we did for our session-based authentication to the default authentication classes for our REST framework. And here we're going to add our 2 new authentication classes. So I'm going to add a comment, and this comment is just for like my internal understanding of what we're adding. And I'm just going to do OAuth 2 authentication classes. And then what I'm going to do is that I'm going to add them now. So the first one that we have to add is OAuth 2 underscore provider dot contrib and contrib dot rest underscore framework dot OAuth, and make sure that OAuth is spelled like this, not all caps, and then OAuth 2 authentication. And then from there, we have to add another one, which is going to be rest underscore framework underscore social underscore OAuth 2 dot authentication, and then dot social and social authentication. That's a mouthful. And then do a comma and do command save. Hopefully this works. And all of this information again is available on the actual GitHub page for Django REST Framework Social Auth 2, so you can go there if you're ever confused with any of the steps. Okay, so now that we've done all of this, the last thing we have to do is that we have to define some authentication backends. And what are authentication backends? Well, these are things specific to our actual token-based authentication, where we let Django know which different backends for this token-based authentication do we support. So what we're going to do is that outside of the REST framework dictionary that we defined, we're going to create a new dictionary, and we're going to call it authentication underscore backends. And here we define all of the different backends that our actual token-based authentication can use. So the one that we want to use right now is going to be Django .contrib .auth .backends .model backend. And we can add a comma here just for good practice. And another one after this is going to be rest underscore framework underscore social underscore OAuth 2 dot backends dot Django OAuth 2. And once we have these two, we can just add another comma and do command save. Everything should work good. So once we have all of this done, all of the setup that was required for implementing the Django REST Framework Social OAuth 2 package is now done. So I'm going to end this video here, and now in the next video, we're actually going to be testing if our implementation was successful or not. So with that, I'll see you guys in the next one. Thank you. Hello everyone, welcome back. In the previous video, we had implemented a package known as Django REST Framework Social Auth 2 inside of our API, which will now grant us the ability to actually have token-based authentication as well as OAuth 2 authentication abilities inside of our API. In this video, we're actually going to test our implementation and actually check to see if it works or not. So to test our implementation, the first thing I'd like you to do is that you have to head on over to the admin panel. So that would be the base URL/admin. And then you're going to see that you have these two new tables that have appeared because of the migrations that we have applied and the apps that we have added to our installed app. We're going to click on applications under Django OAuth Toolkit. And from there onwards, we're going to click on add application. Inside of here, what we're going to do is that we're going to leave client ID as it is. And for the user, I'm going to select the user that I have just created inside of the API known as management. And then from there, I'm going to set the client type to confidential. And I'm going to set the authorization grant type to resource owner password based. And I'm going to leave the client ID and client secret unchanged, and then I'll set the name to OAuth2 application, and then I'll click on save. One thing I've noticed is that our actual users our actual management user is not a super user. So I'm going to go and I'm going to change the privileges or the permissions for our actual management user to be super user as well as staff status, and click save. Heading on over to our application, I'm going to click on it or click on the ID, and for now we're done. And what this application is going to do is that it is going to handle all of the logic that is based on OAuth2 authentication and token-based authentication. And that's why we had to create this application. Now what I'd like you to do to actually test the endpoint, I'd like you to open Postman. And once Postman is open, what I'd like you to do is that I'd like you to click on the plus sign here. Once you have clicked on the plus sign, this new window is going to open where we're going to actually configure the request that we're going to be sending to our server. The first thing that I'd like to do is that I'd like to define the endpoint or the URL where we're going to be sending our request. In our case, it's going to be API/auth/token. And I'm going to copy this and I'm going to put it here. The next thing I'm going to do is that I'm going to change the request type from get to post and do command save. And what command save does is that it allows us to save this request so that we can reuse it later on. And to save, what you do is that you can create a new collection and you can call it Taskly app and Taskly API. And then from inside of here, you can just click save to Taskly API, and then the request would be saved. You can also change the name of the request by just clicking on rename. And then, so once we have this, the next thing I'm going to do is that I'm going to head on over to our body section inside of our request, because we have to send some data to the server because it expects the username, the password, and some other additional data that it needs to actually process our request successfully. So the first thing that we have to do is that we have to send the client ID. Then we also have to send the client secret. Then we have to send the grant type. So the grant type specifies what type of information we're sending and how the server can actually interpret it, and then check our authentication and validate our identity. For the username, I'll just set that to the username that I had created, and then the password as well. For the grant type, it's going to be password, since we're using password-based authentication. Finally, we'll use the client ID and the secret. To get those, you'll go to the application and then you'll copy the client ID and paste it in for the client ID. Copy the client secret, paste it in for the client secret, do command save. And then now we're finally ready. Just as a side note, make sure that all of these headers are included, and Postman should add them automatically once you've configured the request the way that I had shown, and then you can click on send. As soon as you send the request, you're going to see that you get a status, which is of 200 OK, which means that our request was processed successfully. We get a time to show how long it took for the request to actually complete. Then we'll see a size. So the size was the size of the body and the header combined, which was returned back to us. And finally, we'll see the response of what the server had sent us. So let's see what the server sent us. Firstly, it sent us an access token, the token that we're going to be using in every subsequent request to actually authenticate ourselves. Then it sent us an expires in integer, and this tells us from the point that we sent this request 36,000 seconds later, this token is going to be invalid. And to revalidate the token, we're going to be using our refresh token. And to refresh the token, we're going to be sending another request to the same endpoint. So I'm just going to click on the top tab and I'm going to click on duplicate. And once it's duplicated, all we have to do is that we have to change the grant type to refresh token. And then we have to remove the username and the password. So I'll just remove the password. And you can click on the X here to remove it. And then we'll change the username key to actually refresh token. We'll copy the refresh token that was provided to us, and we'll set it as the value for refresh token, and then everything else should be the same. And now if I click on send, what's going to happen is that the API is we are going to send a request to the API again, where we're going to give it a refresh token. And that's why the grant type is different. And then the API is going to return us a new token, which will allow us to actually authenticate ourselves for the subsequent requests. And that token is also going to be valid for the next 3600 seconds. So if I do send, you're going to see that we get a response with a new access token. Finally, we have the token type, which is bearer. So this is just the type of token that is being used. And then we have scope, and that is what our user is allowed to do, and our user is allowed to read as well as write to the API. So with this, our token-based authentication is now working perfectly. We have all the required endpoints that are necessary for OAuth 2-based authentication as well as token-based authentication implemented our API. If you now go to the access tokens inside of the Django OAuth toolkit, you're going to see that we can see the access tokens for our specific user. And we can also see the refresh tokens for the user as well. So it looks like that everything is working perfectly inside of our API. So with this, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be implementing, or extending, I should say, the base update method that is provided to us by our model serializer class. And the way we're going to be And the reason we're extending our update method is because we want to add the ability to our user serializer for actually allowing users to change their password. The update function is going to be called every time the user sends either a put or a patch request to our API, which then is going to transport that request to the appropriate serializer. And when a put or patch request comes to our user serializer, then this specific update function is going to be called. The update function is just not going to be responsible only for changing the password of our user, but it is also going to handle all of the other logic, such as handling email changing requests, first name change requests, and all of the other fields that are associated with our user model. So the update field is going to get firstly self passed to it, secondly the instance that the user serializer is currently working with, and finally the validated data, which is the same as what we get in our create function. The instance in this case is going to be the entity that is saved inside of our database and that we're going to be performing the actions on, or the entity for which the put or patch up request was sent. So the first thing we have to do to update the user's password is that we have to get the user. To do that, what we'll do is that we'll create a new variable and we'll call it user, and I'll set that to instance. The reason we're doing that because instance in this case is going to be the specific user model that we already need. So hence we can just set user equals to instance because the update actions are going to be performed on a user object. Secondly, we need the password. So for that, I'm going to take the validated data and then I'm going to pop the password from it. Then we require the old password as well because we need to check to see whether the old password is what the user's password is currently, and if that matches, then we can actually update it to the new password. And for this, we'll have the old password as our key for our validated data. So now that we have all of the required data, we have to make sure that the old password that is provided matches with the existing password for our user. For this, we can use the handy dandy function that the user object provides us, and that is check password. And then you just pass in the password string that you want to compare the password against. And if this check passes, then we can just set the user password to the new password by using the function on the same user object called setPassword and then passing in the new password. If this check fails, we'd like to actually raise an exception. And the exception would be old password is incorrect. But we do not have any exception handling logic. So what do? Well, for that, we can encompass all of our code inside of a try except block. So I'm going to go to the top, I'm going to add a try block. And then after that, I'm just going to highlight all of this code, and then I'm going to do tab to just shift it, or indent it, I should say. And then after this, I'm just going to follow with an except block, and then I'm going to do exception as an error, or error, and then I'm going to raise a validation error for our serializer. So I'm going to do serializers.validation error, and this is going to produce the appropriate response for our client and let them know that something went wrong. And what is the message that we want to give our actual client? Well, it's going to be the error that gets passed in, and in this case, this error is going to be old password is incorrect. So once we have this, we have defined the exception logic. There's still one step we need to do to actually save these changes onto the database, and that is actually calling our users.save function. So I'll just do user.save at the end inside of here, just to make sure that this transaction does take place on the database, and then we're all good. But if we just end the update function here, you're going to notice that the password update logic is going to work flawlessly. But if you send a request, whether put or patch, for updating the first name, last name, you're going to notice that those are not going to work, and the values are just going to remain unchanged for our object. And the reason for that is because we've actually overridden our update method, and we've not defined the logic on how to handle first name changes or email address changes or any other changes for the fields that are on our user serializer. And the way we're going to fix this is that instead of defining all of the logic again ourselves, we're just going to call the update method on our base class, which is model serializer. To do that, you'll just do super, open bracket, and then you're going to pass in the serializer, which is user serializer, and then self, and then we'll call the update function on this base class, which in this case would be model serializer. And then we're going to pass in the instance of the model that we want to perform the update function on, and then finally the validated data. Keep in mind that the validated data that is passed does not include the keys password and old password, because if you do, then you're going to get a key error that the amount of arguments that were provided to the update method were more than what were expected. And to actually fix this problem, we don't have to do anything, because we're using the pop function on our validated data dictionary, which automatically takes care of actually retrieving the value and removing that key from the dictionary. But if you were, instead of doing pop, you were doing password like this to access the password from the validated data dictionary, then you would have that, then you are going to encounter that problem. Hence, I'll just recommend using pop. So with this, our update method is defined, so we can test it out. So for testing it out, we can do a simple thing. We can just use the built-in GUI that Django provides us. And what I'm going to do is that firstly, I'm going to go to /API/accounts, then to users, and I'm going to select the appropriate user for which I have the privilege to actually edit the user object for. So for example, since I'm not Harry Potter or Hermione Granger, if I click on those users, the form doesn't show up for me. And I can assure you, if you use Postman to actually send the request, it's just going to give you an error saying that you're not allowed to perform this action. So I'm going to go to the user that I'm logged in as, and that's Hussein, and then you're going to see that the form pops up for me. And then finally, I'm going to change the password. For the old password, I'm going to type in the password that I currently have, and then for the new password, I'll just type in test123 and just replace the last character, and then do a put request. And the password should be changed. And now to actually see if the password change was successful, I'm just going to log out, and then I'm going to try to log back in using the old password first, and that is not going to work. But if I just now use the new password that I just defined, that's going to work. The next thing I'd like to do is that I'd like to test to see that if I pass in a wrong password, that the actual exception logic runs and we get an appropriate response back. So for the password, I'll just do a dummy value because that doesn't matter. The thing that matters is the old password. And for the old password, I'll send in a wrong password. So I'll just do test123 4, which is the wrong password. This is not the current password that is set. And if I do a put request, you're going to see that we get a 400 bad request response. And the error that we get is old password is incorrect. To further improve the readability, what we can do is that inside of our serializers.validation error, instead of just sending the error, we can just do a key, which could be info, and then info could be set to error. And if you do command save, reload the page, resend the request with the wrong password, you're going to see that we get info, old password is incorrect. So with that, we have successfully implemented the update password logic inside of our API. So I'm going to end this video here. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. Up till now, we've implemented a lot of functionality into our user serializer, such as giving the user serializer the ability to create user objects, as well as defining the update method, which not only allows us to update some of the fields that our user model has, but also allows us the ability to change the user's password. But all of this is of no use if you're not validating the data that is coming to us. And for now, you could see that we try to get the password from the actual serializer field that we've defined here. But there is no place where we actually mention that this password field is required. On the contrary, we actually say that this password field is not required. Hence, in the case of a put request, patch, or a post request, if the password or old password keys are not included, the request would still go through. And at some point, it might fail because it might try to access that data and it might not be available to it. So what we'll be doing in this video is actually creating some logic inside of our user serializer, which will allow us to validate the data conditionally and see if the password field or old password field is required, and if it's required, is it given to us, and if not, return the appropriate responses back to the client that's actually sending the request. So with that said, let's get into it. So to actually perform all of the validation logic, there are two main ways you can do it. The first is that you can define validation logic for a specific field. But right now, what I'd like to do is that I'd like to define the validation logic for the whole user serializer as a whole. And for that, what we can do is that we can create a method that is called validate. And validate is going to take in two attributes. The first is self, as always, and this next is going to be data. Data in this case is going to refer to the actual raw data that we get from the actual data that is submitted to us through the client, and not the actual validated data that gets passed to us and create an update. So the first thing that I'm going to do inside of our validate function is I'm going to check as to what type of a request did I get, whether the request was a put or a patch or a post. And to do this, we have to firstly access the request object, and that is going to be self.context, and then we get passed in the request key to actually get the request object, and then from there we can access the method. Just do command Z to undo it and method. Okay, so now that we have the request method, the next thing we have to do is that we have to actually attain the password if it's passed to us. And the reason I'm trying to access the password right now is because we need to know if a password is given to us in the case that we either get a post request, because then it's necessary for us to be given a password because we're creating a new user and the new user needs a password. And also in the case of a put or patch request, because depending on if we get a password or do not get a password, we'll actually perform the validation logic of checking if we get an old password as well. And as we actually progress through the creation of this function, you'll understand a bit more as to why we need the password right now. To get the password, what we'll do is that we'll use the data.get method. And the reason I'm doing this is because it's unclear as to whether we'll have the password or not inside of our actual data dictionary. So we'll do the data.get method. And if there is a password, then we'll get the appropriate value for that password. And if it isn't, then we'll just get none. And then what I'm going to do is that I'm going to now check the request method and check to see if it is post. So in the case of post, what we need to make sure is that we're giving a password. We do not care about old password. We just care about having a password. So for that, I'll just do password, and I'll do that is equal to none. So if the password is equal to none, which means we weren't given a password. I'm going to actually raise a validation error. So the same way we did for our update method, we'll do serializers.validation error. And then here, I'm just going to pass in a key, which is going to be please, and then provide a password. And the next thing I'm going to do is that instead of just sending this string, I'm going to just have this kind of a dictionary, and then I'm going to add a key, which I'll call info, and that info key is going to hold the actual message that we want to send, and that will be please provide a password. Do command save. So now that we have this, the next thing I'd like to do is that I'd like to check to see if the appropriate fields are given to us if the request method is actually put or patch. So for that, again, I'm going to check to see if the request method is either put or the request method is patch. So either one of these. In that case, if we're given a password, then I need to check to see if we also have an old password. So the first thing I'm going to do is that I'll try to get the old password. So I'll do the same thing as we did for our password, data.get, and then old_password, and then comma none. And if we have the old password, then we're all good. But what if we don't? Well, if you don't have the old password, just give a validation error. The reason behind that is not all put or patch requests are going to be for password change. Some of them might be for other stuff. So to make the implementation concrete, what we can do is that we can check to see if a password was provided to us. So if it's a put or a patch request and the user provides us a password, which is not the default behavior, then we have to make sure that the old password is also not none. And if the user does provide us a password, that's why I'm checking not equals to null, and the old password is none, that means that the user had an intent of actually changing their password, but they didn't provide the old password. Hence, we can raise a validation error, which can point the user towards actually providing us an old password. So validation error, and then inside of here, I'll do the same thing. So a key, which is called info, and then the actual error, which would be please provide the old password. So now the last thing we have to do is to make sure that if all of these validation errors do not run, that means that our data was successfully validated. The last thing we have to do is just return the data. So if none of these validation errors occur, that means the data is valid and we can just return the data. So with that, we've actually defined our actual validate function. So to test this, we can use Postman this time. So what I would like you to do is open Postman up and then open the username authentication request that we had created previously. What I'd like you to do is that right click on it and click on duplicate. Once the request is duplicated, we can just rename it to user account update. And then we can change the request method to patch. You can test it with a put as well. I'll go to our actual API, so /API/ and then from there accounts, endpoint and users, and then I'm going to go to the appropriate account that I want to change the stuff for and that I have permission for. In this case, that is the user account with ID 1. I'll copy that resource URL, paste it in here, and do command save. Then for the body, the first thing I'd like to do is that I'd like to just remove the client ID, the client secret, the grant type, but I'd like to also remove username, password, and refresh token. I'd like to create a new user just as a test. So to create a new user, we have to give an email, we have to give a username, or sorry, not a username, you have to give a email, we have to give a first name, a last name, and then finally a password. Now if I send a dummy email and I can do test_user@test.com, same as the first name, test, and same as the last name, user, and then password could be test123. And if I send a request right now, it's not going to work because we copied the wrong resource. So I'm just going to remove the one here for now, do command save and change this to a post, and we'll just run with this, and we do not need anything else. And if I do is a send request, before doing a send request, Let's just remove the password and let's just see if our check works. So if we do a send request, you're going to see that we get an error. If you scroll down, it should give you the actual, oh, we had to add an ending slash. So now if I do a send, you're going to see that it gives us an info that is, please provide a password. Always make sure that the trailing slashes are always in your API endpoints. Sometimes Django REST Framework is really finicky, and if you don't add that trailing end slash, you get weird behavior where it says that either an endpoint doesn't exist or the data that is being provided to the endpoint is wrong and stuff like that. So just make sure that you have that endpoint. So now that we validated that it actually asks us for a password every time we try to create a user, let's try to create a user by giving a password. Hopefully that test passes. Send. Yes, that test actually passed. And now we have a new user created. Next thing I'd like to do is that I'd like to actually change the password for this user. So I'll copy the URL for this user and I'll now change it to this user's. I don't know why that didn't work, but again, copy, and then I think it's just copying the whole response. Yeah. So just do Command Z to get back to this point, and then just at the end of the URL, just add this 10, and then you should be pointing towards the right resource. What I like to change for the user firstly is just their email. So I'll uncheck the password, first, last name, and first name. I'll change this to a patch request, and I'll try to update the user instead of test_user@test.com. I'll do it at hogwarts.edu. So now we're sending a patch request. We just want to change a subset of the data that is available for our model. The specific thing we want to change is the email. But if we send the request right now, we're going to get an error that the authentication's credentials were not provided, since to perform an action such as this, you need to be authenticated with the API. So we need to get the credentials for that user. To do that, we can go to the previously created username authentication request. And inside of here, make sure that you have all of these keys set and have them set to the appropriate values. So these might differ depending on the application that you've created in previous, but for the grant type, set it to password, and then for the username, I'll set it to the recently created user's username. So that was test user, and the password was test123. Do Command save, send the request. Let's see, this might work. Yes. So we should get the access token, and now we can go back to our user account, and then we can click on the authorization tab. We can click on type and then do bearer token, and then paste in the token here. And what essentially this does is that if you go to the headers tab, you're going to see that we have this new header key inside of our request that is authorization, and that's set to this specific value where we have bearer space the actual token. So now if we send the request to our API, you're going to see, okay, so while sending a patch request to update the user's email, you might get an error which says that the password needs to be given to us. And that is because we're trying to validate inside, and that is because inside of our update function, we're trying to pop the password even though it's not provided to us. So to fix this, what we're going to do is that we're just going to add an if statement, which is if password invalidated data. And then we're just going to call all of the logic that's associated with actually changing the password for our user. And we don't have to check for old passwords since we already validate this inside of our validate function. But since the update function gets called for every patch request, regardless of whether the user wants to update just their password or something else, hence we have to have this additional check inside of our update function. So adding this just if statement at the top, and then going back to Postman, if you send a send request now, you're going to see that the email for the user gets updated, and I can change the email to something else as well. So I can do testuser@test.com, test.edu, send. It should work. I can change the first name, last name as well. So I can say that it's a user and then test, and then do send, and that'll update the first name and last name. And finally, I can update the password as well. So I just have to add the password key. And then for the password, if I try to just send this, you're going to see that I get an error. Please provide an old password. As soon as I provide an old password, and the way you do that is just by adding another key, old password, and then providing the password as test123. And I'm just going to do the @ symbol, send. you're going to see that it says old password is incorrect, and that is because it is. Update that to this, and then update the old password to the new password I want to set. Click send. The old password should get updated now. So now if I log out, I try to log back in, and I'm going to try to log back in as the test user, so test_user, and then for the password I'm going to do test, and then 1 2 3, and I'll use the old password first. That didn't work, and now I'm going to copy the new password, paste in, and do login, and that should work. Finally, the last thing I'll do is I'll show you how to delete the user. You can either delete a specific user if you have the permissions to do so by going to the user list and then clicking on the user that you have permission for, or you can just do the same in Postman, where you send a delete request to the specific resource that you have the permissions for. In this case, since I'm authenticated as the test user, as you can see from here, the token that we get corresponds to the username test user, and this token is valid for the next 24 hours from the time that I actually am given this token. Then I can use the refresh token to get the new token. I can just send, instead of patch, a delete request. Don't have to remove anything from the body. Postman automatically knows that in a delete request it doesn't have to send anything for the body. I can click on send. Boom, it gets deleted. And you might say, where's the delete function implemented inside of the user serializer? Well, since we inherit from our model serializer, the model serializer does provide us an implementation. So just to verify that this works, firstly, we get a 204 status, so anything in the range of 200 means good. And if I reload, you're going to see that yes, the user is deleted, and we do not get them in the list anymore. And I've also been logged out, if you can see. So finally, I'll just change the request back to a put or a patch. You can test it with a put, it should work as well. Patch, and then just unclick some of the stuff, click save, and to save you just do Command S or Control S in Windows. And then with that, I'm going to see you guys in the next video. Thank you for watching. Hello everyone, welcome back. As we get closer to the completion of this section inside of our course, there still remains this one crucial step that we've still not implemented inside of our API. And that is information regarding the different profiles of each of the users that we have inside of our application, as well as the abilities for different users to edit their profiles. And as I had alluded to in my previous videos, the profile is just an extension of our user model that allows us to store additional data corresponding to each specific user. So with that said, let's get into it. So to start off, the first thing we need is that, similar to our user serializer, we need a profile serializer, which will allow us the ability to serialize and deserialize our user objects. So to get started, what I'll do is that I'll create a new serializer class for our profile serializer, and I'll call it profile and then serializer. Once this is done, I'll make sure that it also inherits from serializers.model serializer. And once we have this, the next thing I'm going to do is that I'm going to define the meta attribute for our class. And then inside of here, I'm going to define the model that this serializer is going to act upon. In this case, it's going to be our profile model. So I'm going to import that by doing from.models, then import the profile model. Once we have this, the next thing I'm going to do is that I'm going to set the model to profile. And finally, I'll define the fields that this serializer is able to act upon. So the first one is going to be the URL. This would be the actual URL corresponding to the URL to access each of our different resource instances. Then we would have the ID. So this would be the actual ID of our profile. Then we are going to have the actual user. And this user is going to be a reference to the user that this profile is attached to. And finally, we'll have image. And that's all for now. So once we have this, what we're going to do is that I'm going to do Command save and just make sure that the app restarts. So now that we have the profile serializer defined, the next thing that we can do is that we can define the actual view set that's going to connect to our serializer. To do that, we're going to go to our viewsets.py, and similar to our user profile or our user view set, we're going to create a profile view set. So down here, I'm going to create a new class. I'll call this profile view set. And then this is going to inherit from viewsets.model viewset. Once we have this, what we're going to do is that we're going to define the actual query set that our view set is going to act upon. So that's going to be all of our profile objects. So to get the profile objects, again, similar to how we imported the model inside of our serializers.py file, we'll import it here as well. So for models, import profile. And then we'll set this equal to profile.objects.all. And then finally, the last thing we need to do is define the serializer class, or the actual serializer class this profile view set is going to use. And that's going to be from our serializers.py file. So where I import the user serializer, I'm just going to add a comma and then import the profile serializer and set the serializer class to profile serializer. So now that this step is done, the final step that we have to do is that we have to define all of the routes that our profile view set has inside of our Django REST Framework API. To do that, we're going to go to our router.py file, and then to our existing router, what I'm going to do is that I'm going to do router.register. So I'm going to add some new routes to it under the profile endpoint. So profiles, and then finally, I'll import our view set. So where I'm importing our user view set, I'll also import profile view set, and then just set that equal to profile view set. So now with this done, we've basically taken care of everything, and now our actual profile should start showing up inside of our API. So if I go to the API root, you're now going to see that at API/accounts, we not only get the users endpoint, but we also have a profiles endpoint. And clicking on this, we actually get information regarding the different profiles. And as you can see, the URL here points towards each of the specific URL profile instances that we have. So now that I have this, the next thing I need to do is that I need to actually show inside of our users endpoint for each of the different user objects that we get the corresponding profile to them. So the simplest way of going about this would be to actually go to our serializers.py file, and then inside of our user serializer, going to the fields and then adding the profile here. If I do this, you're going to see that once the app reloads, we're going to get this ID for each of the profiles for these corresponding users. And while this is a fair enough implementation, I think it doesn't give us much information, or doesn't point us towards the right resource. So the way we're going to fix this is that we're actually going to embed our profile object for this profile key. So we'll have another dictionary for our profile key. So to do this, what I'll have to do is that I'll have to go to our user serializer, and I'll have to define a new field. And this field is going to be called profile. And instead of doing it in the middle, I'll do it after the username. So I'll call this profile. And then I'll set this equal to our profile serializer, which we've defined here. And then inside of here, the next thing I'm going to do is that I'm going to set read only equals to false. We do not want the users to be able to change the profile that they are linked to. So this is just a read only field, and it just gives us information about the field. And if I do command save and I reload the actual API endpoint at API/accounts/users, you're going to see that now for our profile, we actually get a serialized representation of our profile objects for each of the corresponding users. And all of the fields that we have inside of our profile serializer are shown here. So those are the URL, the ID, user, and the image. But if you go down to the HTML form, you can see that there's no ability for us to change our profile. And that is because, firstly, we create unique profiles when a user is created, and those profiles should remain with the same user regardless of whatever happens inside of our API. Hence, it is only a read-only field. But there might be instances where we might want to update specific data that is inside of our profile, such as the image, for example. And we're going to get to that in the next steps. Okay, so now that we have the corresponding profile data for each of the user objects that we have, the next step that I'd like to do is that I'd like to actually change the way that the user relationship is shown here inside of our profile serializer, and maybe make it so that we get a URL that points towards the specific user that the profile is linked to. To do this, what we'll do is that we'll define a new field inside of our profile serializer, and I'll do user is equal to. And as long as the name of your field matches to the name of an already existing field inside of your model class, Django automatically knows which field it refers to. But if that is not the case, then you can actually set a source parameter and actually type in the actual field name there. So I'll show you how that works later on. But for now, instead of having an actual serializer for our user, there's another way that we can define relationships, and that is using hyperlinked related fields. So what essentially hyperlinked related fields do is that they allow us the ability to actually embed a URL for each of the specific keys, and then that URL points to the specific entity. In this case, we'll embed a URL which is going to point to the specific user instance. So for the user, what I'll do is I'll set that equal to serializers dot, and then and I don't know why it's not autofilling, so serializers, oh yeah, it's serializers dot, and then hyper linked related field. And then finally for this, the first thing I'd like to do is that I'd like to make sure that this field is read only, because we don't want to change the user that a profile is linked to. Secondly, what I'll do is that I'll set the many attribute to false, and many means that for this relationship, do we expect there to be a lot of different results that come to us? And that is not the case for this, since each profile has a one-to-one relationship with a user object. Hence, the many attribute is going to be false. But if we had a many-to-many relationship or a one-to-many relationship, then maybe many would have been set to true. And many just means, are we going to have many results returned for this specific field? And finally, the last thing we have to do is that we have to define the view name. And the view name refers to the actual view that this hyperlink related field is going to point towards. And the way we can actually find the view name is that it's just the name of the model. If you're using the default router, then it's, and we are using the default router, as you can see, it's just the name of the model followed by a dash and followed by detail. So if it was profile, then it would be profile dash detail. In this case, it's user dash detail, because we are defining a relationship to the user model from our profile serializer. Then do command save. And this is all we would have to do. I'm getting an error that says that the serializers does not have anything that is hyperlinked related field. Okay, sir, the error was just that I was typing it in the wrong way, so just do hyperlinked related field this way where the L is not capitalized, and then you should be all good to go. So make sure that the L, instead of being a capital L, is just a small L. Do command save again. Hopefully the server is going to spin up this time without any errors. And now if we reload our application or our API endpoint, you're going to see that inside of our profile serializer, the actual user key is not going to point towards the actual user object that the profile is linked to. And if you click on it, it'll take us to that specific user instance. So with that, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be updating some of the functionality associated with our profile view set. If we for now click on our profile view set, you can see that we get a list of profiles returned back to us. I think this functionality is not required in our use case, because if we go back to our users profiles, our users list, you're going to see that for each of the user, we get a corresponding profile object. And in there, we have a URL that points to the specific profile of that user. Hence, I think that it is not necessary for us to include a list of profiles for our profiles endpoint. Secondly, as you can see that we have the ability to create profiles. And this is a problem because inside of our Django application, the profile creation logic is automatically taken care of by the application on listening to signals on the user model, and then every time a new user model is created, creating a new profile for them. So we have to fix this as well. And finally, the third problem that currently our profile view set has is that each user has the ability to edit whatever profile they want, regardless of whether they are an owner for it or not. So let's get started by first defining the permissions for our profile view set, and then moving onwards from there. So to define the permissions, what we're going to do is that we're going to go to our permissions.py file, and then we're going to create a new class. And this permission class is going to be used for a profile view set. So I'm going to say is profile owner or read only. And then I'm going to say permissions.base permissions is going to be the class then we inherit from. Once we have this, I'm just going to copy this top comment string and put this here. And now what I'm going to do is that I'm going to say it is custom permissions for profile view set to only allow user to edit their own profile, otherwise get and post only. And I just see that I made a mistake here. There should be on user, not on profile on the top one. So once we have this comment string defined, the next thing we're going to do is that we're going to define our has permission method. So for our has permission method, what I'm going to do is that I am going to return true. So I'm going to do definition has permission. We'll get self request in view. And then what I'm going to do is that I am going to just return true. Once we have this, the next thing I'm going to do is that I'm going to define the has object permission. And inside of has object permission, we're going to actually check to see if a user is the owner of a profile. And if they are, then only allow them to edit that profile. So firstly, we're going to see if the request that we get is just a method which is in safe methods. So in permissions.safe methods. So if it's a get request, then it's a safe method and we just can return true. And safe methods are usually, I think, get options and head, as you can see, get options and head. And if that is not the case, then what we'll do, if it's any other request, we'll do the request.user.profile and then set that equal to object. But now there is a problem. Since we're not checking in has permission that the user is not anonymous, if we try to access the request.user.profile and the user is anonymous, we are going to get a crash in our API because we're going to access the user. And since the user is going to be anonymous, the request wouldn't have a user object and hence we would get a crash. So to fix this, what we'll do is that what we did for our has object permissions in our is user owner or get and post only class, we'll just copy this if command, paste it in, and then followed by it, we'll check to see if the request.user.profile is equals to an object object, and this object in this case is going to be profile. And the reason for that is because this permission class is going to be used on the profile view set, and the model that is linked to profile view set is the profile model. Hence the object would be a profile object. And finally, if this is not the case, then we'll just return false as a default. So once we have this, we can go back to our viewsets.py file. We can import our permissions class. So is profile owner. We can go to our profile view set. We can define the permission classes, and then we can create the new list and add is profile owner or read only, do a comma, do command save. So now if I go to our API root, go to profiles, and I try to edit a profile that I'm in owner of, and I know that my profile is the profile with ID 1, you're going to see that I have the ability to edit it by changing the image. But for any other profiles, I do not have that ability. Okay, so now that the permissions are fixed, let's fix the general functionality associated with our profile view set. So we're going to go back to our viewsets.py file, and instead of inheriting from viewsets.model viewsets, what we're going to do is that we're going to be nitpicking the functionality that we require for our profile view set by using some mixin classes. So to start off, the first thing we need is that we need the basis for our profile view set, and every view set inherits from generic view set. So to start off, we need the generic view set because it'll provide us the ability to have the get object and get query set methods, as well as allow the API to understand the permission classes query set and serializer class keys. Once we have inherited from generic view set, there is a problem. Generic view set does not provide us implementations for all of the different methods that model view set provides us, because model view set is an extension of generic view set. As you can see, since model view set provides us default implementations of create, retrieve, update, partial update, destroy, and list, those are not going to be available to us anymore. So what we're going to be doing is that now we're going to be nitpicking the functionality for our profile view set as to what we need. So for our profile view set, what we need firstly is the ability to retrieve models. For that, what we're going to do is that we're going to go to where we import view sets from REST Framework, and I'm going to import mixins. Then we'll come down and we're going to do mixins, and then mixins dot, and then we'll have the retrieve model mixin. And this is going to allow our view set the ability to retrieve a model instance. The next thing that I'd like to do is that I'd like to also give our view sets the ability to update models. And for that, we'll use a mixin, which is called mixins.update model mixin. That is it. These are the only two mixins that we need, because we just want our view set to have the ability to retrieve objects and give us the ability to update already existing objects. And that's all. We do not want our view set to have the functionality to allow us to create objects, to delete objects, because we don't want people to create profiles, and we don't want people to destroy profiles as well. And although we could have used permissions to limit that, I think this is a better way of doing it, where we just altogether remove that functionality. So now once I reload my profiles endpoints, you're going to see that we get a 404 error, which means not found. But now if I go back to our users, and then I go to the profile for a user and then click on their URL, you're going to see that it takes us to that specific URL, and we can actually retrieve that URL. But if we go back to our profiles endpoint, we do not get a list of URLs returned to us. Similar to that, our permission still works. So if I go to a user that I am not the owner of, for example, and I go to their profile, I can still see their profile, but I do not have the ability to edit it. So now the next question that might arise is that what if you'd like to actually have the ability to create profiles, or to have the ability to actually list off all of the profile objects? Well, for that, you can either go the route of inheriting from model view set, or you can just add those mixins. So you can add the mixins dot list model mixin, and this list model mixin now is going to allow our view set the ability to give us a list of objects back. So now, as you can see, if we go to profiles, we get a list. If I want the creation as well, I can do mixins dot create model mixin, and now we'll have the ability to create objects as well, as you can see right here. And then finally, if I want the ability for deletion as well, I can do mixins and then dot delete or destroy model mixin, sorry. And this should give us the ability to destroy as well, because if I go to a profile that I have the permissions to edit, you're going to see that the delete option pops up. But if I comment this out and then move this to a new line, followed by a comma, and then move this to a new line and remove the comment, to Alt-Shift-F, Command save. Alt-Shift-F just means reformatting the code. You're going to see that the delete is now removed. So now I'm just going to comment these two things out as well. So comment list model mixin, create, and destroy model mixin, because I do not want these functionalities for this profile view set. And with that, I'm just going to add the space and then do the formatting of the code by Alt-Shift-F and then do Command save. And now the permissions for our profiles view set should be defined. So if I go to users, I can see the profiles for the users. And if I click on that specific profile, it takes me to the profile. And that's pretty much it. That's all that we had to fix for our users endpoint. So with that, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In the previous video, we implemented the final fair bit of functionality that was required for our users app. And with that, we can call our user app 90% complete. There are going to be still some specific instances in the development of our API later down the road where we might have to come and edit some few changes for our users app. But the majority of the functionality that the user app required is now complete. So with that, we're just going to go over all of the functionality that we implemented during the videos in this module. and just give ourselves a round of applause for the wonderful work we've done. So let's get going. Now, if you go to the API/accounts endpoint, you're going to see that we have a users endpoint. And that user endpoint now gives us a list of all of the different users that are inside of our API. Following that, we implemented permissions, and people with the specific privileges only had the ability to edit their own profiles as well as their user objects. So as you can see, since I've logged in as Hussein, I can only edit the profile that corresponds to Hussein and the user object that corresponds to Hussein. And if I go back to any other user, I do not have privileges to edit their profiles or user objects. Another thing that we did was allow the users the ability to register using the API/account/users endpoint by sending a post request with all of the relevant data, which was first name, last name, password, and email. Furthermore, we allowed users to change their passwords by giving them that functionality. Going onwards from this, we also limited the functionality that our profile view set had, which was to limit the profile view set to just allow the retrieval as well as the updating of model instances and nothing more. Finally, we implemented all of the authentication logic related to our API, and we put all of those endpoints following the API/auth endpoint. We had a basic overview of Postman, where we went over how to send requests using Postman. And the two requests that we actually did were getting a token for a user by sending the username and a password, as well as trying to update a user's email by sending a patch request. So with that, I'm going to end this video here. I'm going to see you guys in the next module, where we're going to further develop our API and bring it more closer to its completion. I hope you're enjoying this course up till now. And if you are, then don't forget to give it a review. And if you're confused at any moment, don't forget to reach out for help to me or all of the fellow students that are taking the course with you in the course Q&A section. And with that, thank you. Hello everyone. Welcome to this module, inside of which we're going to be creating the House app for our Django REST API. The House app is going to encompass all of the functionality that is associated with houses inside of our Django REST Framework API. Similar to our API/accounts, we're going to have a API/house endpoint, which is then going to encompass all of the functionality that relates to our House app. We're going to have just one endpoint that is going to be known as houses, which will give us a list of houses that are registered inside of the application. For each of the houses, we'll have information corresponding to them, such as the members of that house, the amount of members that are in this house, so a count of the members, the description, the name, the task list for that specific house, and stuff like that. Furthermore, we'll also define some custom actions that we've not yet seen for our view sets, which will allow us to embed custom functionality for our view sets that was not available beforehand, such as joining or leaving a house, as well as having the ability to remove members if you're the manager for a house. We'll also implement custom permissions such that depending upon whether you're a manager or a member of a house, you'll have different privileges. So only managers for a house are going to be able to change the name, description for the house, while members would have the ability to actually complete tasks and edit task lists and mark tasks as incomplete. So now that we have a basic overview of what we're going to be developing inside of this module, let's get going and let's create the House app. So to create the House app, it's going to be a fairly similar process to what we did for our Users app, where we're going to make sure that our virtual environment is activated. We're in the folder, which has the manage.py file, and then we're going to do manage.py, start app, and then from there, followed by the app's name, and in my case, the name of the app that I want is going to be House. Doing that, you're going to see that a new folder is going to appear inside of our source parent folder, which is going to have all of the boilerplate code for our newly created app. So now that we have the app created, the next thing I'm going to do is that I'm going to let our Django application know that it needs to use this app. So I'll go to the settings.py file, I'll go to where we have installed apps, and then following users, I'll add a new key, and this will be House. So once I have this, I'll add a comma, do Alt-Shift-F, Command, save. And with this, if I just run our app and make sure that we do not have any errors, we can confirm that the installation was successful, and now the house app is also linked with our app. So now with this, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In the previous video, we had created our house application and then linked it to our main Django app by adding it inside of our installed apps list inside of the settings.py file, so that Django knows that it needs to load all of the data or all of the code that is inside of our house app. And in this video, we're going to further develop the house app by creating our house model. So let's get going. So to start off, I'll create a class house inside of our models.py file for our house app. And this is going to inherit from models.model. Once we have this, the first thing I'm going to do is that I'm going to add the name field to our house model. And this is going to be models dot and then character field, so car field. And then it's going to have a max length. And the max length that I like this field to have is going to be 120. The next thing I'm going to do now is that I'm going to define the image that our house is going to have. And this is going to be models.file field, similar to how we had a file field for the profile image. And then we'll have an upload to location. And before I define the upload to location, I'd like to set blank equals to true, and then null equals to true as well. So null just means that this value can be null, and black means that inside of our Django admin, if you do not provide an image, then that's okay and it shouldn't raise an error. So now that we have this, we can define the upload to image path. I'd like to define a custom upload to location, which is going to be unique to every house. So what I'm going to do is that I'm going to create the deconstructible class, which is going to be responsible for generating the house's image path. So I'll do class generate, and then house image path. And then we'll do object, and then finally, we'll do the def underscore init underscore method, and we'll just do pass for this. So this is exactly same as to what we did for our profiles app, and then underscore call underscore method, which will get self, comma instance, comma file name as the 3 arguments passed to it. Inside of here, first I'll derive the extension for our file, and that is going to be file name and then dot split, and I'll split using the dot separator. And then finally, I'll take the extension out. Once we have this, I'm going to define the path for our file, and the path is just going to be an F string, and it's going to be media. So the media folder, then we have a houses folder. Inside of here, we'll have the house ID, so that'll be instance.id, because the instance in this case refers to the house object instance. And then from there, we'll have /images. And then I'll have name of our file. And the name for our file is just going to be main dot, and then we'll have the actual extension. And finally, we'll just return the os.path.join path, comma name. And we need to import os. So we import os on top. So once we have this, we can do command save, and then what we can do is that we can go down here, we can define a new variable which will say house image path, and we can set that equal to generate house image path, and then the upload to location can be set equal to house image path. Now with this done, you can do command save. Okay, so looks like there are APIs, no errors. But if we try to create a house right now, whether through the Django admin interface or through our REST API, provided that we create all of the necessary logic required, you're going to see that during the creation of a new house, if we provide an image file, we're going to get an error, and the error is going to relate somewhat to the app not being able to generate the actual house image path. And the reason for that is because we'll provide an image before the actual house object has been saved into the database, and hence the house object is not going to have an ID. Then Django is going to try to access the ID here when it's trying to create a path, and it'll see that the instance is not saved in the database, and hence is no ID, and it's going to produce an error. And the reason for that is because Django, when an object is not being saved into the database, does not assign the object an ID. Hence, our house wouldn't have an ID. But to circumvent this problem, what we can do is that we can define our own custom ID field that is going to replace the ID field implementation as given to us by Django. And then that ID we can make sure is available before the object is actually saved inside of our database. And this way we can circumvent this problem. So to do that, I'll define a new field ID, which will override the default ID field implementation. And what we'll do for this is that we'll do models and then .uuid field. And then we'll set the primary key attribute for this set to true. The ID column is going to be the primary key for our house table. And then what we'll do is that we'll define the actual value that this ID field should have, and that is going to be default equals to, and then there's a package that we need to import, and then that is called UUID. So import UUID, and with this we can set the default equals to UUID dot, and then from there we can do UUID.4. So UUID 4. And then finally we'll set the editable property for this equals to false, because we do not want this property to be editable anymore. So once this is done, now our problem should be fixed, because now the ID is going to be generated before the actual object is saved inside of our database, and hence it is going to be available before the house object has been saved into the database, and hence this code is not going to error out when the Django application actually tries to generate a path for our house image. So now that this is done, we can continue developing our model. So the next thing we need is going to be a created on field, and this is just the date that the house was created on. So this could be models.datetime field. And then what we'll do is that for created on, we'll add a property which is called auto_now_add, and we'll set that equals to true. And what auto_now_add does is that it just signifies to Django that populate this field with the date and time of whenever the object was created, and then that's it. This cannot be edited anymore. That's what auto_now_add lets us do. Similar to auto now head, we have also auto now, that for every update to our model actually updates the actual date time field. But since we just want the date time field to be populated once on the creation of our actual object, we'll just do auto_now_add equals to true. Once we have this, we can set the description for our house. So the description is going to be models and then dot text field, because we do not want a max length limit around description. Our description can be as long as we want. Finally, what we'll have is also a manager for our house. So the manager of a house is going to be a one-to-one field. And the reason for this is because a user can be the manager of only one house, and a house can only have one manager. Then this relationship is going to be on the users.profile model. So I'll set the string as this. And once we've defined the actual relation to the profile object, the next thing we have to do is that we have to define the deletion logic, so that if a profile is deleted, what happens to this relation. And what we're going to do is that we're just going to set the manager to null. So there's this thing called models.setNull. But this then implies that our actual field also needs to be null. So this means that a house can have no manager, and for that we can do blank equals to true and then null equals to true, similar to what we did for our actual image. So it's not required that a house has a manager at all times. And then finally, the last thing that I'm going to do is that I'm going to define the related_name attribute for our manager, and this is going to be managed_house. And this just means that if we are on our profile object and we want to access the house that is managed by that specific profile, then we can do the profile.managedHouse, and then that'll give us the house object. So this is kind of like the reverse identifier. Finally, the next property that we're going to define are going to be points for the house. So we'll do points equals to models.integer field, and then we'll just do default equals to 0. And then we'll do completed_tasks_count. And we'll set that equals to models.integer field again. And the integer field means that we can only store integers in here, which are whole numbers and no decimals. And then this is also going to be default 0. And then finally, I'll have a other property that is called not completed underscore tasks underscore count. And this would also be the same thing as the two before them, which is models.integer field and default 0. With this, I'm going to do command save. So with this, we can close down our server. I usually do that if the server is running by doing Control-C to exit the server. And then from there, what we can do is that /manage.py make migrations to actually make the specific migrations required. And it's giving us an error. And the error is because the generated house image path class is not being marked as a deconstructible. So I'm going to firstly import the deconstructible decorator. So from django.utils.deconstruct, I'm going to import the deconstructible decorator, and then I'm going to mark our class as deconstructible, do command save. The deconstructible decorator would allow Django to actually convert our generated house image path into a migration. And then we can do /manage.py make migrations. And hopefully this works. And as you can see, it says that migrations for the house app, I've created an initial migration, create model house. And then we can just apply these migrations by doing manage.py migrate. So with that, we've created the house model that is going to be used inside of our Django application. It is still not complete. There are still some fields that we're going to add to this model in the future. But for now, this is all of the data that was required. So with that, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello, everyone. Welcome back. In the previous video, we had created our house model inside of our house application. And in this video, we're going to be creating the corresponding serializer for our house model so that we have the ability to serialize and deserialize instances of house objects that have been saved in our database. So with that said, let's get into it. So similar to what we've been doing previously inside of our house app, I'm going to create a new file. I'll call this serializers.py. Once the serializers.py class has been created, I'm going to create a new class, and I'll call this house serializer. And then what I'm going to do is that I'm going to inherit from serializers.model serializer. But before we can do that, I have to actually import the serializer. So on the top of our file, I'm going to do from REST Framework import serializers. Once we have this, the next thing we need to import is our actual house model. So I'll do from .models import house. So now that we have the serializers and house imported, we can firstly inherit our house serializer class from model serializer. And then from there, we can define the different fields that our serializer is going to have. So starting off, what I'd like to do is that I'd like to create the meta class for our house serializer and define the actual model that this serializer is going to be linked to. In our case, that is going to be house. The actual fields that this serializer is going to be working upon. So in this case, I need URL, the ID of our house. With this, we also need the image, the name of the house. We would also need the actual created on date. So created _on. Then I'll add a comma, and then I'll do an enter to just break it down to another line just for ease of readability. From there, I'll add the manager for our house. Once we have the manager, we'll have the description for our house. After the description, we'll also have the amount of members our house has. So that is members _count. Once we have this, then I'll also have the actual members list. So members. And then from there onwards, we'll also have points for our house. Following the points, we'll have completed task counts. So I'll add another enter just for ease of readability. And then I'll do completed _tasks _count. And then finally, I'll have not completed _tasks _count. And with that, what I'll do is that that's pretty much it. And with that, we've defined all of the fields that are required as of now for our house serializer. So you might see that for some of these fields, we just want read-only functionality, and these fields should not be able to be updated by the user. Solutions to this problem would have been to define custom serializer fields for each of the fields that we might want to change the default implementation for. So for example, in my case, if I do not want member count to be updated or updatable by the users and have it as a read-only field only, what I could have done was to do members_count and then set that equals to serializers and then .integer field. And for the integer field, I could replace the read-only property to be true. And this way our members count is just going to be a read-only field. But there is another way you can go about this. And this is a good way of going about things if the only thing that you want to do is make fields read-only. And that is that inside of the meta class for your serializer, you can define a list of read-only fields. And please take note that these fields need to be present inside of the fields list as well, because field list tells what are all of the fields that our house serializer can work with. And then read-only fields just takes part of the fields that are inside of our fields list and just tags on an additional information to them, telling the Django REST framework that, yeah, these fields are only going to be read-only. So what I'd like to do in this case is that I'd like to set the points field as read-only. So make note that points is also in the fields list. Then I'll have completed _ tasks _ count as also a read-only field, and then not completed. And all of these read-only fields, we would like to have the logic for actually updating fields embedded inside of our API rather than giving the user the ability to change these. And once we have this, these are the only 3 read-only fields we need. Yes, I can move member counts to this as well, but I just want to leave both of these implementations here so that if you guys want to reference any one of them, you can look at them. So you could either go this way where you can define the custom serializer field and then just set it to read-only, or you could just define read-only fields if you do not want to add any other properties to a custom defined serializer field, and all you want to do is just make sure that the fields are read-only. Okay, so with that, I think we're done with our house serializer. I'm going to end this video here, and I'm going to see you guys in the next one, where we're going to be creating the corresponding view set for the serializer to link with. Thank you. Hello everyone, welcome back. In the previous video, we had created our house serializer class. And in this video, we're going to be creating the corresponding resourceful controller for our house serializer, which in this case is going to be a view set. So let's get going. So in your house app, create a new file. And for the new file, we're going to name it viewsets.py. Once we have the file created, the next thing we're going to do is that we're going to start off by creating the house view set. So I'm going to create a new class, and I'll use the same naming convention that we've been using throughout this course, and that is going to be the name of our model followed by view set. Then what I'll do is that I'll import the corresponding import that we need. So firstly, a really important import that we need is going to be the actual view sets import, which is going to be imported from REST framework. So from REST framework, import view sets. So once we have this, what I can do is that I can go back and make sure that our house view set inherits from the viewsets.modelViewSet class. Once we have this, the first thing I'm going to do is that I'm going to define the query set that our view set is going to have. To define the query set, we need the access to our model. And to get access to our model, I'll import it from the .models file. And then the model we need is going to be house. And then we can do query set is equal to house.objects.all. Once we have this, the next thing I'm going to do is that I'm going to define the actual serializer class. And the serializer class is going to be imported from our serializer file. So from .serializers import house serializer. Once we have this, I'm going to set the serializer class to house serializer. Once we have the query set and the serializer class defined, what I'm going to do now is that I'm going to set up the permissions for our house view set. So what I'm going to do to start off is that I'm going to define the actual permission classes property, and for now set it to an empty list. I'll go and create a new file inside of our house app, and name it permissions.py. Once we have this, I'm going to create a new class inside of here, and I'll call this class is house manager or none. And this class is just going to be classes that are going to respond to being a house manager or not, and granting you privileges if you are a house manager. This class is then going to inherit from the permissions.base permission class. So I'm going to import that from REST Framework, import permissions. And then here, I'm just going to do permissions.base permission. So once we have this, what we can do is that we can define the has permission function first. So has underscore permission, and then it'll get self request and view passed into it. And I'll just return true, because what we really want to do is that we have to check the object permissions. So for that, I'll do has object permission. And inside of here, the first thing I'm going to do is that I'm going to check if the request.method is in permissions.save methods. So if it is, then we could just return true. So any save method such as get, head, or options, that's going to be allowed for everybody. But if you want to do like specific actions such as put and patch, then we'll check to see if the request.user.profile is the same as the object, which in this case is going to be a house object, and then the actual manager for that house. So if the manager object is same as the user's profile object, then we allow them some other features as well. You might have noticed that we have an issue here, and the issue is that we're not checking if the user is logged in or not. So to fix that, what I'll do is that I'll go to our has permission function, and here I'm going to define the logic. So first I'm going to check to see if request.method is in permissions.save methods. If it is, I'm going to return true. So we allow get request, head request, and options request. If we want to have a post request, because has permission, it also gets run for post request, I'm going to first check to make sure that the user is not anonymous. So for request.user.is underscore anonymous, so anonymous, and if he isn't anonymous, then we'll return true. And then finally, we'll just return false here. And with this, we've solved the problem. And the reason behind that is because in has permission, we check to see and make sure that the user is not anonymous, because if they are anonymous, then the function returns false. And since has permission has already returned false, has object permission is never going to be called at all. Hence, since we make sure in has permission that the user is not anonymous, and only then does it return true, hence we can effectively say that has object permission is not going to error out by saying that the request.user is none. So with this, we can just do command save for the permissions, and then we can just head on over back to our viewsets.py file and import our permissions. So I'd just like to add some space between our imports, and then do .from permissions import, and then is house manager or none, and then set that here, and do Alt-Shift-F, command save. And with this, we are all done with our house view set. So I'm going to end this video here, and I'm going to see you guys in the next one. Hello everyone, welcome back. In this video, we're going to be defining the default router for our house app, which is then going to define all of the routes for all of the view sets that we're going to have inside of our house application. Just as a side note, we're just going to have one view set, but we still need a router, similar to how we had things working in our users app. So let's get going. So to create the router, I'm going to firstly create a new file, and I'll call this router.py. And inside of router.py, the first thing I'm going to do is that I'm going to import from REST Framework the actual routers package. So routers. Once we have this, the next thing I'm going to do is that I'm going to import the view set. And the view set that we require is going to be house view set. Then I'm going to define the actual app name inside of our router.py file, and app name is going to be the same as our actual app's name, which in this case is house. And then just remove the space here, and then remove the space here as well, and we should be all good. Now the next thing I'm going to do is that I'm going to create the router for our application, and we're going to do that by doing routers.default router. Once that is done, I'll do router.register, and then from there I'll define the endpoint after which we want all of our specific endpoints defined for our house view set, and that is going to be houses, followed by the actual view set that we want to use, and that is going to be house view set. So with this, I'm going to do command save, and now our router is defined and it has the corresponding view set linked up to it. So now what we have to do is that we have to import all of the routes that have been defined by our router inside of our house app inside of our urls.py file for our main RESTful API application. So to do that, we'll head on over to our urls.py file, and here first thing we're going to do is that we're going to import the router. So I'm going to do from house import router, and then I'm going to name it as house underscore API underscore router. And with this done, what I'm going to do is that I'm going to head on over to our API underscore URL underscore patterns list, and following the path that we've defined for our counts endpoint, I'm going to define a new path, which is going to be house endpoint, and following that will include all of the routes that are defined by the default router that is inside of our house application here. So I'm going to do include, and then from there I'll do house API router, so house._API_router. That's how we imported it. And then from there I'll just do URLs. With this done, I'll just add a trailing comma, do Alt-Shift-F, command save just to reformat the file, and then reload everything. And it's giving me an error saying that there's no attribute URLs. And the problem with that is because it's not just URLs, it's router. So house API router.router.urls. And then we can do command save. Our router is successfully loaded up. So now if I go to the main API endpoint, so that would be 127.0.0.1 port 8000 followed by API. You're going to see an API slash. You're going to see that we have 3 endpoints, which is API/auth, API/accounts, and API/house. And I forgot one thing, and that was to add a trailing / to our actual endpoint, do command save. And with this, if I reload the app, you're going to see we have house. And if I go to that endpoint house, you're going to see that we now get our new houses endpoint. With that, I'm going to end this video here, and I'm going to see you guys in the next one. Hello everyone, welcome back. So up till this video, we've defined our house model for our house app inside of our models.py file. We've defined the corresponding serializer for that house model. We've then defined the view set, and then we've implemented the actual router for our application as well. And finally, we've imported all of these URLs inside of our main urls.py file. And now we have access to this specific endpoint that gives us information regarding all of the different houses that are inside of our application. But we still don't have any houses inside of our application. So this video will just create 2 houses and then try to join them. Let's get going. So the way I'd like to create these houses is first by actually creating one from the admin panel, and then the other house we're going to be creating by sending a post request to actual API endpoint. So to get started, what I'll do is that I'll firstly define the logic that we require for our admin panel so that the actual house model actually shows up in there. So to do that, we'll do what we did for our users app as well, where inside of our admin.py file, we are going to set up the logic so that our model is registered inside of the admin panel. So to do that, it's fairly easy. I'll just do admin.site and then .register, and then I'll send in the actual model. So we have to import the model. So that's going to be from .models import house, and the I for the import is going to be small, import house, and I'll set house equals to house. And then what I'll do is that I'll also define the custom admin class for our house admin to define the read-only fields for these model class. And we need to import from the base class, which is admin.modeladmin, and not import, inherit from admin.modeladmin. And then we can set the read-only fields for these models. So the read-only fields in this case are going to be ID followed by the created on, because we do not want these fields to be able to be changed. So I do not want the created on field to be changed through the admin panel, and I do not want the ID to be able to be changed. And once this is done, I'll just set the admin class for our actual house model to be house admin, and then we can do command save. So now I'm going to open up a new tab, and I'm going to go to the admin endpoint, log in, and hopefully that works. So now, as you can see, we have this new section inside of our admin panel which says house, which is the name of our app, and then the houses. So I'm going to go in here and I'm going to create a new house. So the name of our house, what is the name of our house going to be? So I'd like to make this Harry Potter inspired. So I'm going to search for Gryffindor information first. And then I'm going to go to this website, which is harrypotter.fandom.com. And I'm just going to copy some information from here. So I'm going to copy the name. So once we've defined the name, the next thing we have to define is the description. So for the description, I'm just going to go down and I'm just going to copy the first paragraph that we have here. I'm going to come back, I'm going to paste it in. And then I'll just remove these curly brackets with like numbers in them. And I think all of that is done. So once this is done, I'm going to define the actual manager for the house. So that is going to be my profile, as you can see, Hussein's profile. And then we can just leave points to 0, complete task counts to 0, and not completed task counts to 0 as well. And then I'll do save. And now our house is created. But it looks kind of weird, doesn't it? If you go to our houses list, it kind of like appears as like this house object with like this random ID. And I want to give some more meaning, and I want to actually show the actual house name here instead of this house object. So to do that, what we'll do is that we will go to our models.py file, and then we're going to override the stir method, which is underscore underscore stir underscore underscore. We'll get in self. And then for this, we'll return an f string with self.id followed by self.name. So now each of our house model, whenever we need a string representation for it, is going to be returned in this fashion, where we'll have a ID followed by the name of the house. So with this, if I reload our app, you're going to see that now we have the ID for the house followed by the name of the house. I think that gives us a bit more understanding of what we're actually seeing displayed on the screen. So now that this is done, I'm going to try to create another house, but from our API endpoint. So to do that, I'll just go to /API/house and then the houses endpoint. And it says that the field name members is not valid for house model. Oh, and the reason for this is because we don't have a member field associated with our house model. So I'm going to go back to our serializers, and then I'm going to remove the members field, do command save, reload, and hopefully everything should be good now. So yeah, it is. So now I'm going to try to create a new house. This time I'm going to create Slytherin. So I'm just going to go back and type Slytherin in, go to the exact same website, which is Harry Potter Fandom, and then just copy some data from here. So for the name, we'll do Slytherin. For the manager, I'll do Malfoy, but I don't have him. So let's create a new user. So I'm going to go to our admin. I'm going to go to users. I'm going to click on add a user. And then what I'll do is I'll search for Malfoy on Google, just because I don't want to butcher his name. And then I'm going to just copy some data in from here. So for the username, we can just do Draco_Malfoy. Then password name is all of the other passwords we've had. Test123. Save, and we're good. So now for the first name, I'll just do Draco. This is going to be Malfoy. And then the email just be Draco_Malfoy @ and then from there we can just have Hogwarts.edu and do save. Voila. So now we have a new user. I'm going to go back, I'm going to reload the page just so that we can pull the new data down. And now there should be Draco here as well. So now we're good to go. So I'm going to go back, copy the name for Slytherin, put it here, set the manager to be Draco, and then for description, what do? Well, we do the same thing we did for Gryffindor, and I'll just copy the first paragraph from Harry Potter fandom, paste it in, and then make sure that I just remove these numbers, and then we should be good. Everything's good. So now I'm going to try to do a post. And as you can see, the post was successful. How do I know that? Look here, it gives me HTTP 201 created. And as we've discussed, any code in the 200 range means the operation was successful. So with this, we now have 2 houses. And to confirm, we can just go back to our admin panel, click on the houses, and just see that 2 houses pop up. And if I go to Slytherin, you should see that the manager is now set to Draco Malfoy. And you should also notice that the created on date was automatically filled, and that the ID is only read-only as well as the created on date. Furthermore, if we go to our house lists and I go to API root and then from there houses, you can see that for a house, which in this case is Gryffindor, if I go, some of the fields are read-only, such as points, complete task counts, not completed, because those fields are not present inside of the HTML form. And you can try sending these fields, they're just going to be ignored by Django. So with that, I'm gonna end this video here, and I'm gonna see you guys in the next one. Thank you. Hello everyone, welcome back. So now that we have populated our application with 2 houses, I think it is prime time for us to implement the functionality for users being able to join a house. For this, we'll have to define a new relationship, which is going to be a one-to-many relationship, where we'll allow each user to be a member of just a single house, while a house can have many different profiles as its members. So to get started, what we can do is that we can go to our models.py file, which is located inside of our users app, and we're going to edit our profile model. I'm going to be adding a one-to-many relationship here, and I'll call it a house. And this is going to be the house that the user, or in this case, the profile, is a part of. And then I'm going to set this equal to models dot and then foreign key. And what foreign key allows us to do is that it allows us to define a one-to-many relationship where the one side of the relationship exists on the model that is defining the relationship. And that's why we're doing that for our profile model here, because each profile can just have one house attributed to it, while each house can have many profiles as members of it. And you can think of profiles as just users, because we do know that profile model is just an extension of our user model just for us, so that we can store some additional data that the user model does not provide to us. So now that I've defined the models.foreign key relationship, the first thing we have to do, just like we did for a one-to-one relationship, is to actually define what model this relationship is going to be working with. And in our case, it's going to be the house model. So one way you could do this would be to actually go to the top and then import from house.models, import house. And then once you have it imported, you can set that here house as the first argument, and then Django would understand which relationship this foreign key has to link to. But in our case, I'm just going to remove this import statement, and I'm just going to add a string here in which I'm going to have the name of our app, followed by a dot, followed by the name of the model that exists inside of that app, and our model's name is house. So I'll do the app name, which is house, and then dot, and then the actual model name, which is capital house. And this might be a bit confusing, but this is the name of the app, followed by a dot, followed by the name of the actual model. So once we've defined this, the next thing we're going to do is that we're going to define the onDelete attribute, so that every time a house is deleted, what do we want this relationship to do? In our case, what I'd like to do if a house is deleted is that I'd like to set the profiles house to be null. So since we're setting it to null, we also have to tell Django that it's okay for this field to be empty. And then I'll also set blank equals to true. So that's why we set null equals to true. And then finally, I'll set the related name attribute. And this time I'm going to set related name to members. So if I want to access the house for a specific profile, I'll do profile.house. But on the contrary, if I want to access all of the profiles that are a member of a specific house, I'll do the house dot and then members, which is the reverse identifier for this relationship. And then I'll get all of the list of the different profiles that are a member for that house. So once we have this, we can do command and save. I get an error, and the error is because we've misspelled blank. So I'll do command save again, exit our server, and then run it again, manage.py run server, and hopefully this time it should work. So now that the server is working, the next thing I'd like to do is that I'd like to apply the changes that I've made to our model to the database. To do that, the first step is to make migrations. So I'll do /manage.py make migrations. And then there onwards, I'll apply these migrations. So /manage.py and then migrate. And now our database should be up to date with the changes that we've made to our model. So now with this, I can do run server. So now that this is done, I'm going to reload our actual houses endpoint, which is api/house/houses. And the next thing I'd like to do is that I'd like to update our serializer so that we get a list of members displayed for each of the different house objects that we have. To do this, we can go on over to our serializers.py file, which exists inside of our house application. And then here, I'm going to create a new field on top. And it's going to be after members count, and I'm going to call it members. And I'm going to set that equal to serializers dot, and then from there I'll say hyperlinked related field, and then I'm going to set this as a read-only field. So and then I'm going to also set the many at property for this hyperlinked related field to true, because we do know that this is a one-to-many relationship. And in this case, for the house, we are going to have a list of members, and hence the many option needs to be true. And finally, the last thing we have to do is that we have to define the view name. And the view name, since we're using the default router, in our case is just going to be the name of the model, which our case is profile, followed by a dash, followed by detail. And this is always going to be the case whenever you're using the default router, where you have the name of the model, followed by a dash, followed by detail. If you do command save, our API should hopefully restart. And once we have made sure that there are no errors, I'm going to go to our fields, and then I'm going to add this after members count. So I'm going to add a new key here inside of the fields list, and I'm going to call this members. Do command save. And now hopefully when I reload the API endpoint, we should get a list of members. But since our houses do not have any members for now, we have to fix that. So for now, a quick way would be to go to our admin panel, and then I'm going to go to profiles. And then I'm going to go to my profile, which is Hussein's profile. And here I'm going to change the house that I'm a member of, and I'm going to set that to Gryffindor and click on save. As soon as I've done this, I can actually reload the endpoint, and you're going to see that now my actual profile appears to be a member for the first house. Similarly to this, I'll go back to profiles, I'll go to Draco's profile, and then from here, I'll click on house, and I'll set that to Slytherin, and I'm going to click then save. And now if I reload the API endpoint again, you're going to see that the member for this specific house, which is Slytherin, is now Malfoy, which is profile ID 9. If we click on the actual URL, you're going to see that it takes us to that specific resource. Okay, finally, the last thing I'd like to do is that I'd like to update how our actual manager field is represented inside of our serializers. Because for now, if you see, we are showing an actual URL to a specific profile for our members, but for our manager field, we just show an ID for the profile of the manager. So I'd like to change this, and I'd like to make it similar to how we have our members field. So I need a hyperlink related field for this as well. So to do this, I'll update the manager field, and I'll create a new serializer hyperlink related field for it. So I'll do serializers dot and then hyperlinked, and make sure the L in the linked is lowercase related field. And then I'll set the read-only attribute for this to true as well. And then from there, I'll set the many property for this equals to false, because the manager is a one-to-one relationship. Each house can only have one manager. Hence, the many property is going to be false, because we're not going to have many results returned to us. And finally, the view name. And you've guessed it, the view name is going to be the same as what we had for our members. hyperlink related field, which is going to be profile followed by a dash followed by detail. Now, if I do command save, reload our endpoint, you're going to see the representation of our relationship is now being updated to an actual URL that points towards the profile, which is the manager for this specific house, Gryffindor, which is me. So if I click on this, it should take me to my specific profile. And if I click on the user that's pointed by this profile, you're going to see that it's me, as you can see, denoted by the username. So with that, I'm going to end this video here. And now in the next video, we're actually going to be working towards implementing some custom actions to our house view set so that members can easily join and leave houses. So with that, I'll see you guys in the next one. Thank you. Hello everyone, welcome back. In the previous video, we implemented functionality inside of our Django application so that houses could now have members associated with them. And we also tried to add members in for specific houses by going to the Django admin panel and then specifying which houses each of the corresponding profiles were a part of. But I think it's prime time that we actually add this functionality to our actual API endpoints so that users have the ability to do these actions without going to the admin panel. To achieve this, what we're going to be doing is that we're going to be defining custom actions on our house view set, which are going to be custom functions that are going to be run and are going to be accessible through a URL endpoint, you can say. So to get started, what I'd like you to do is that I'd like you to head on over to your house viewset class, which is inside of viewsets.py file, which is inside of our house app. And here you're going to create a new function. And I'm going to call this function join. And the reason I'm calling it join is because that's what the function is going to do. It's going to allow a user to actually join a house. And then I'm going to have 3 parameters that get passed to this function. They are going to be self, request, and finally primary key equals to none. And this PK parameter is the primary key for the model instance that this specific function gets called on. Okay, so now that we define the function, how do we actually tell our view set that this function needs to be accessible and it needs to create or generate a route for it? Well, to do that, the first thing we have to do is that we have to import a decorator. And that decorator is going to be available from the REST Framework.decorators package. So I'm going to go to the top, and here I'm going to do from REST Framework.decorators import, and then I'm going to import the actual action decorator. Once we have the action decorator imported, I'll decorate our actual join method with the action decorator. And then there are some properties that we have to set for this decorator. The first one is going to be a property known as detail, and I'll set detail to true. And this detail property actually determines whether this action is going to be available for a specific instance of a model, or is it going to be applicable for the actual list of objects that get returned to us. If you hover over this, you're going to see that it says that detail required determines whether this action applies to a viewset method as a routable action. Since we want this function to be applicable to individual house instances because users are going to join individual houses, we are going to set detail equals to true. And I'm going to show you if I set detail equals to false, what's going to happen. But for now, just do detail equals to true. Once we have this, the next thing we're going to do is that we're going to define the methods that are allowed for this specific action. We just want a post method to be allowed for this specific action. And finally, we'll give our actual method or our route a name, and the name that I'm going to give is going to be join. Once we have this, we can do command save, and now we can actually define our function. So what I'm going to do is that I'm going to create a try except block, and I'm going to do tab to autocomplete this expression. And from there onwards, I'll try to first get the house instance that our user has tried to join. To do that, we have the self parameter that gets passed to us. And if you do self.getObject, it'll actually return the object that this action was called upon. From there, the next thing we need is the user profile as well, because we got to add that user to our actual house. So I'm going to do user profile equals to request.user.profile. So now that this is done, the next thing I'm going to do is that I'm going to create an if statement. And then inside of our if statement, I'm going to check if the profile of our current user does not have a house, because if the user has a house, then he cannot join a house anyway. So to do that, I'll do user underscore profile and then dot house, because that's the attribute we have for our model. And then I'm going to check if it's none. If it is none, then what we're going to do is that we're going to set the user profile and then the house equals to the house object that just we pulled from self.getObject. And then what we're going to do is that we're going to perform the actual transaction on the database by calling userprofile.save to actually save. And finally, we'll return the response. And the response is going to be a class that we have to import. And this class is going to be imported from REST Framework.response package. So I'm going to go to the top again, and I'm going to do REST Framework.response. And then I'm going to import response. Once we have this, we can go back and do return the response. And for our actual response, we have to define the status of our response. And in this case, our action was performed successfully. So what I'm going to do is that I'm going to set the status to status dot. And I just remembered that we also have to import the status as well. So I'm going to go to the top again, and from REST Framework, where I'm importing view sets, I'll also import status. And then I'll do status dot, and then from there I'm going to do http underscore 204 underscore no underscore content. And then once we have this, we can do command save. So now that we have defined the logic for if the user doesn't have a house, I think we can move on to if the user is already in the house. So what if the user is already in the house? Then I think we should actually have a separate useful message that gets returned to the user, letting them know that you're already part of this house. And for that, what I'll do is that I'll take the user profile, and then I'll check to see that is this user profile inside of the members list that this specific house has. And for that, I'll access the members property. And if you are confused as to where does members come from, because our actual house model doesn't have a members field, well, if you remember back to when we edited our profile model, we defined our house relationship, and inside of there we gave it our foreign key, a related name parameter, which was members. And this is what we're using here now to actually access all of the members that are a part of this specific house. So we'll do house.members, and from there I'm going to do all. And now if this is actually true, then what we're going to do is that we're going to return a response again. And this time I'm going to return a response, but with a message as well. So firstly, I'll define a message. It's going to be a dictionary where I'll have a detail key, and then the actual message is going to be already a member. And then from there, we're going to say that already a member in this house. And then I'm going to add a period and then finally I'll add the status. And the status for this request is going to be status and then dot http, and it's http underscore 404 and then, or not 404, sorry, 400 bat request. Finally, if the user house is not none and the user is not in this house, that means the user is a member of another house. So I'm going to have this else statement in which I'm going to return a response, which is going to be similar to the response we return for the else if statement. And this response, we're just going to say that already a member in another house. And then the status is still going to be 400 bat request. And finally, for our expression, I'm going to do exception as, and then E. And then finally, what I'll do is that I'll return a response. And this response is going to be status, and then the status is going to be status dot and then http underscore 500, and we'll just call it an internal server error. And that's pretty much it. And I'm going to do command save. So now you're going to see that the API loads up correctly. And if I actually reload the application, you're going to see that we get no changes to our actual REST Framework GUI. But if I go to a specific URL endpoint that pertains to a specific house instance, you're going to see that we get this new button, which is called extra actions. And if I click on it, you'll see that we have this new action available to us, which is called join. If I click on it, you're going to see that now we have this specific URL, which we can send a post request. And that post request will allow us to actually join the house. And now you might be asking, where does this detail part come in action? Well, if I set detail to false, then this action is not going to be attributed to a specific house instance. As you can see, the extractions are removed from here, but it's actually going to be available for the whole actual house list that we get, where we get multiple instances for all of the houses that we have inside of our application. And here you can see that we have this extra action. But since we want this action to be applicable to specific house instances and not the whole list of houses that we get, hence we set detail equals to true. So with this, the next thing I'd like to do is that I'd like to quickly define the leave function for house. To do this, we'll do similar to what we did for our actual join function, where I'm going to define a method first, which I'll call definition leave. It'll also get self request, and then finally the primary key equals to none as a default. We'll add the decorator to it. So I'm just going to copy it from the top. I'm going to paste it here, and then we'll just keep the first two parameters the same, but for the name, we'll just set that to leave. And then from there, we'll just create a new try except block inside of our actual method and press tab to auto-complete it. And then what we'll do is that we'll firstly get the house. So it's going to be house equals to self.get object. Once we have the house, the next thing we have to do is that we have to get the actual user profile. So that is going to be user profile, and that is equal to request.user.profile. Once we have this, what I'll do is that I'll have an if check to see if the user is in our house. So that's going to be the same as we did for our else if statement in our join function, where if the user profile is in house.members.all, then we'll remove the house. And to do this, what we'll do is that we'll set the user underscore profile dot house is equals to none. And then we'll do user underscore profile dot save to perform this on the database. And then we'll just return a response. And the response is going to be the same as we did for our join house. For a successful operation, return the response with a status code of 204 no content. If this is not the case and the user is not a member of this house, we'll just do an else statement. And inside of here, we'll return a response. And I'm just going to copy it in because it's really similar or exactly the same as what we've been doing for our join function. We'll return a response where we'll say user not a member in this house, and then we'll return a 400 bad request status. Finally, for our exception, I'll do exception as E. So this is just the identifier for our exception. And then I'll just return the same response that I return for our actual join function, and that is going to be return response status.http 500 internal server error. With this, I'll do command save. And I think with this, we're done with the actual join and leave functions for our house. In the next video, we're actually going to be using Postman to actually test these and make sure that they work. So with that, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In the previous video, we had defined two new custom actions for our house view set, which gave the ability to our API users to actually join and leave a house. And now in this video, we're going to be using Postman to actually test the functionality out. But before we get going, I would like to point out a small mistake that we made in the previous video while defining custom actions that we wanted to define for our house view set, which were join and leave. And that was that we did not define the actual permission classes attribute for our actual actions. And if we do not define this attribute for some reason, then the actual permission classes that are defined for the house view set are also going to be applied to these actions as well. And hence, if we are not the house manager, then we are not going to be able to perform the join or leave action. And we do not want this. We want any user that is authenticated with our API to be able to do that. Hence, we need to override the permission classes for these two specific actions. And the way we're going to do this is that we're going to set the permission classes attribute for both of these actions to empty permission classes. This way, only the base permission classes that are defined inside of our settings.py or the global permission class is only going to be applied. And I'm going to copy this. I'm going to paste it here as well. And now with this, our small mistake should be resolved. So now we're ready. So the first thing I'd like to do is that I'd like to go to our admin panel, and I'd like to just grab a profile that is not a part of a house right now. So I think Hermione isn't, and I think also Harry isn't as well. Oh, Harry actually is. So let's edit this relation by setting it to none and do save. And now Harry isn't as well. So now we can start off by adding Harry Potter to a house. So to do this, the first thing I have to do is that I need to be authenticated with the API. And how do I do that? I need to get a token first. So I'll use the username authentication request. And inside of the body, I'm just going to change the username to Harry Potter. And then with that, I think all of the other parameters can be left the same. And then with this, I can do click send. I should receive an access token. Once I have this access token, I'm going to create a new request by clicking on the plus button. And then I'm going to set the method for this request to post. I'm going to go to the authorization tab and set the authorization type to bearer token and paste in our token. And finally, I'm going to do command save and save this request inside of our Taskly API folder, where I'll create a new folder, which I'll name the name of our app, which is house, inside of which I'll save our request, and I'll name our request join house. And finally, I'll do save. So once we have this request, the next thing I have to do is make sure that the body is set to none, because we don't have to send anything for this request. All we have to do is send a post request. And finally, I have to get the actual URL for the house that I want to join. So I'd like Harry to join Gryffindor. And for that, I am going to click on the URL for the Gryffindor house's instance, and then click on the extra actions icon and click on join. And now I have the complete URL, which I can use to send the post request to. So I'll copy this URL, I'll come back to Postman, and then I'm going to paste this in for the request URL to command save to save the request. And hopefully, fingers crossed, once we send request, we should get a 204 status. So once I send the request, you're going to see that we get an empty response, but with the status code of 204 no content. If you hover over it, it says that the server successfully processed the request. So now to just verify our changes, if we go back to our house list and we reload the actual API endpoint houses, you're going to see that now our members list for our actual house Gryffindor has 2 new members. So now the next thing that I'd like to do now is that I'd like to make sure that the already a member in this house functionality works as well. So I'll just send another request again with the same settings as before, and hopefully this time we should get a 400 bad request error which says already a member in this house. Okay, so now that once this is also done, the last thing that I would like to test out is that I'd like to make another user join the house, and in this case I'd like Hermione to join our Gryffindor house as well. So I'm going to go to our username authentication request, and I'll grab a token for Hermione. So Hermione and then underscore Granger. And then from there, I'll send, I think the password should be the same. I'll send the request, and it says invalid credentials. Let's see if it's this. And it's invalid as well. So let's change the password for Hermione now. If I scroll down somewhere, there should be this option to change password, and it's here. But you can change the password using this form. And I'll set the password to what we have for all of the other accounts. And then the password is changed. So now if I send a request and do send, we should get the access token. I'm going to copy this access token, go back to join house, go back to our authorization, set it to bearer token, paste in our new token. And this time the request we sent is going to have a token that's associated with Hermione. The API would have add her to the house. So now I don't have to change anything else. And if I do send, I should be able to join the house. And if I reload, yes, Hermione is now also part of the house, as you can see. And finally, what I'll do is I like to check the leave functionality as well. So I'll just replace the join endpoint with leave and do send. And hopefully I should get a 204. And if I reload our house's endpoint, members list should have 1 less member. And yeah, that is the case. Hermione was removed. If I try to leave again, I get an error. User not a member in this house. And finally, the last thing I'd like to do is that I'd like to join back. So now I'm back again, a member of Gryffindor. And now what I'd like to do is that I'd like to become a member of Slytherin while already being a member for another house, which in this case is Gryffindor. So if I copy the actual ID for the Slytherin house, and then I come back to our actual join house request, and I replace the ID for our house here from Gryffindor to Slytherin. So now we're pointing towards Slytherin, and do a send request. You're going to see that we get an error which says already a member in another house. So all of the logic seems to be working perfectly. So with that, we were successfully able to actually implement 2 new custom actions to our house view set, which gave us the ability to actually join and leave houses now. And with that, I'm going to end this video here. I'm going to see you guys in the next one, where we're going to be defining a really specific new action that is just going to be accessible by our house manager, which is going to allow the house manager to actually kick members out of the house. So with that, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be implementing a custom action to our house view set that is going to allow house managers to actually remove member from houses. So without anything further to do, let's get into it. So to do this, what I'll do is I'll follow the same blueprints that I've been doing for our join and leave actions, where I'll first create a new method, which I'm going to call remove_member. And then this is going to get self request and then primary key, which we can default to none, passed into it. And then what we'll have is we're going to have a try except block. Once we have this, the next thing I'd like to do is that I'd like to mark our actual function with the action decorator. And then I'm going to set the detail attribute for this equals to true. Following that, we also have to set the actual methods. And in this case, the methods are also going to be post and post only. And keep in mind, post needs to be all small letters. And finally, following that, we'll have a permission classes attribute, which we'll set to the permission classes that are going to work upon this specific action. Since our view set has the permission classes is house manager or none, to have the same permissions as our view set applied to our remove member action, all we can do is that we can just omit the permission classes option, and this way whatever permissions that our house view set is subject to, our action is going to be subject to as well. So now that we have this, the final last thing I have to do is that I have to define the name, and the name for this is going to be and it's going to be remove member. So once we have these 3 new properties defined for our actual action decorator, we can start coding our actual function. So the first thing is always I'll try to get the house, which is going to be self.getObject. Once we have the actual house object, the next thing I'm going to do is that I'm going to get the actual user ID that our actual house manager wants to remove. So for this, what we'll do is that we'll have the user who's sending us a request pass us a user ID in the request body, and then we'll get that here. So for that, I'll take the user ID from request, which gets passed to us, as you can see, as the second argument. Then we'll have the data property for that request, and from there we're going to do get. And what are we going to get? Well, we're going to get user ID. And if we are unable to find this specific key, then we'll just return none for the user ID. And now I'll check to see that if the user ID is none, because if it is none, then we cannot proceed, and we have to return a error telling our user that they have to provide an actual user ID. In this case, we'll return a response in which we'll have this dictionary where we'll set our actual user ID key, and then I'll just give a message to it which will say not provided. So which will indicate to the actual user that they have to provide our user ID. And then finally, what I'll do is that I'll set the status for this actual response to status .http. And then it's going to be 400 bad requests. If I just scroll down, there it is, http://400_bad_request. So we'll only proceed ahead of this point if we have access to the user ID. Once I have access to the user ID, I need to get the specific user profile. To do that, I'll create a new variable in which I'm going to store the user profile. And to get the user profile, we'll have to filter the user database, find the user with the specified user ID, and then get the profile from them. But before we can begin, we need to import the user model. So I'm going to go to the top of our actual viewsets.py file, and then from Django.contrib.auth, I'm going to import the actual user model. And it's actually auth.models. So auth.models and then import user. So once I have the user model imported, I'm going to go down and I'm going to do user.objects. And from the objects, we require a specific object. Hence, we're going to use a get function on this. And then inside of get, we can pass in the actual key that we want to filter by. And in our case, I want to filter or get the user, which has the ID that was given to us. To do that, we'll set the primary key equals to the user ID. So in this way, we're going to get the user object from our database for which the primary key, which is the ID of the user, matches our user ID. And then following that, I'll access the user's profile. So now that we have this, the next thing I'm going to do is that I'm going to now perform an if check to see if the user is in our house. So I'm going to do user profile in, and then from there, we're going to do house.members.all. And if the user is in our house, then we can actually remove them. And the way we're going to remove them is that we're going to get our actual house members list, and then we're going to remove the actual user profile from it. So for that, we need a reference to it. So I'm going to go and create the actual house members variable here, which will store a reference to our house members list for this specific house. And to access that, I'll do house.members. Then I'll replace this statement where we do house.members.all with just housemembers.all, because now we have access to house.members from house_members variable. Then we can do the all method on it. And now what we can do, if we know that the user is in the house, we can do housemembers.remove. And this will remove the specified user profile from the house members. And finally, what I'll do is that I'm going to do house.save. With this, I'll return a response, and the response in this case is going to be a success response that we usually send empty. And so I'm just going to return a response, which is going to be status.http_204, no content. If our user is not a house member, then what we're going to do is that we're going to return a response, which will just say that the user is not a member for this house. So I'll just return response detail, user not a member in this house, and then the status of 400. And now I'm going to catch a very specific exception, and that is going to be the exception in the case that we try to access or get a user object which does not exist, or the provided user ID is invalid. In that case, I'm going to catch an exception, and I'm going to accept this, and I'm going to catch this exception by doing accept user dot does not exist exception as E. And then what I'm going to do is that I'm going to return an actual response that will let the user know that the provided user does not exist. So I'm just going to return a response in which I'll have the detail which says provided user ID does not exist, and then status, which is going to be 400 bad request. With this, we can do command save. So now to test this, what I'm going to do is that I'm going to firstly run our server. Then I'm going to open up Postman. And to verify, I'll go to our actual houses endpoint for our house, which is going to be Gryffindor, for which I'm the manager. And here in extra actions, I can now see remove member is an option. So I'm going to click on remove member and just copy the URL. And then I'm going to go to our actual join house request, and I'm going to right click on it and click on duplicate. And then here, I'm just going to rename this request. I'm going to rename to remove member. With this, what I'll do is that I'll actually set the authorization to bearer token, which is already set. And now I need a new token. So I'm going to go to username authentication, and I'll try to get a token for the Gryffindor house manager. And the house manager in this case is me, Hussein. So I'm going to get the token for us because only house managers are able to remove members. I'm going to send this request, get the specified token, and then put it here for the token. With this, what I'm going to do is that I'm going to replace the actual join URL so with the remove member URL. So just copy and paste it in here. And I know that Hussein is the manager for this house with this specific ID, hence this should work. And then finally in our body, I'm going to click on form data and then give it the user ID. And which user would I like to remove? Let's go back. So I have a choice of 3 users. I'll remove the user with profile ID 2. and that user has ID 4. So I'm going to copy this user ID and I'm going to put it here. And with this, if I send a post request, hopefully this should work. So sending a post request, we get a success status code for the 204 no content. And if I go back to our actual house lists and I reload the actual house list, you're going to see that for our house Gryffindor, we only have 2 members now. It's 1 and 4. And finally, the last thing I'll do is I'll make Harry Potter join the house again. So for that, I'm going to go to your username authentication. I'm going to authenticate as Harry Potter to get a token for them. Get the token, and then go to our join house request. And then for the authorization, update the token, go to and then make sure that the house ID is correct, which I know is correct. It corresponds to Gryffindor's ID. And then if I click send, we are all good now. So with that, we're done. And we have successfully implemented the functionality for our house managers to actually remove members from our house. So with that, I'm going to end this video here. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this lecture, we're going to be taking over a look at how we can implement saving media files locally inside of our Django application, because as of right now, our API is still not complete and there's a long way before we actually deploy our API to a production ready environment and link it to Google Cloud as our media storage solution. Hence, for the time being, just to test the functionality out and kind of see whether fields work or not, we're going to implement a solution where we'll be able to save files locally on our file system, and then Django is going to actually serve them from there. And this is going to be a fairly simple process. All we have to do is add 3 more lines of code and we should be all set. So to get started, the first thing I'd like you to do is that I'd like you to go to the settings.py file inside of the taskful_API folder. I'd like you to go to the bottom of it, and then I'd like you to add 2 new variables. The first is going to be media_root, all capital, and then the value for this is going to be os.path.join. And then the first argument is going to be base there. And base directory is going to come from something that is already defined inside of our settings.py file. If we go to the top, as you can see here, already included by Django. And then after that, we'll actually add the path or the folder where we want to save all of our media files. And I'm going to set that to media. Now you might see that we get an error that OS is not defined. And for that, just go to the top and actually import the OS package. So now that this is done, the error should be resolved. Next thing I'd like you to do is that I'd like you to add a new variable apart from the media root, which is going to be media_URL. And this is going to tell Django after which URL are all of our media assets going to be accessible. And we want all of our media assets to be accessible after /media. So I'm going to do command save. But before we can actually test this out, there's one key thing that we have to do, and that is that we have to go to where we have our context processors defined, and that's inside of our templates list, and then inside of there the dictionary that we have, and then inside of there the context processor. And here we have to add this new context processor, which is going to be django.template.context_processors.media. As soon as you do this, command save, all of the stuff that needs to be implemented for actually serving media content is now good. So you can reload the application, and now we're ready to test it out. So to test it, I'm going to test it out 2 ways. One, by sending a patch request, and the other way by actually doing an update from the admin panel. So to get started, we'll test it through the admin panel. So I'm going to go to our admin panel, and from there, I'm going to click on the houses, and I'm going to select one of the houses for which I want to update the image. I'm going to select the first one. And then inside of here, I'm going to clear the image first because it already has an image. And I'm going to click on choose image. And then I'm going to select the image. This was one that I downloaded from the internet, and I'm going to click on save. And you're going to see that the image is going to now be saved for our house. And if you take a look at the actual project hierarchy, you're going to see that a new folder appears, which is called media, or new directory, inside of which we have some folders which are media, then houses, followed by the actual house ID, and then images. And this will become more prominent once I upload a second image as well. So what I'm going to do now is that I'm going to go to our GUI for our actual houses endpoint. And you're now going to see that we actually get a URL for our image for the second house for which we have just uploaded an image. And here you can see that the actual media file accessible from the /media endpoint. So I'm going to click on it, and you're going to see that it's going to give us an error, and that says that it wasn't able to actually match this endpoint to any specific URL. And to fix this issue, it's really easy. All we have to do is that we have to go to our urls.py file. And then inside of there, the first thing we have to do is that we have to import the static function, which is going to be imported from django.conf.urls.static. Once you have the static function imported, you're going to do is that you're going to come down to the bottom, and then you're going to append to the URL patterns our actual static URL. So to do that, you'll do URL patterns plus equals, and then you're going to call the static function. And then here you're going to do settings.media URL as the first argument. And this is going to be the endpoint after which our media static assets are going to be available. And then for the document root, which is a argument that you have to give to the static function, you're going to do that as settings.media_root. So this document root will actually tell Django where to find the actual files. And I've just duplicated this line, so I'm just going to remove the other one and do command save. And if you do this, and then if you reload the actual app, you're going to see that now it displays the image. So now that we've solved this problem, we can go back to our original goal of actually uploading an image for the Slytherin house. So I'm going to click on the corresponding URL for Slytherin. And since I'm not the house manager, I'm not allowed. So I'm going to log out. I'm going to log back in. And this time I'm going to log in as Draco Malfoy. And then I'm going to put in the specific password, log in, and now I should be able to upload an image. I'm going to choose file. And then the file that I'm going to select is going to be this one, the one that I downloaded from the internet. Click on open and then do put. And now you should see that the file is successfully uploaded. If you go to our media folder, you're going to see that we have these two new folders. And if I extend them, you're going to actually see that they actually follow the convention that we had actually defined inside of our file field for our house model, where we have media/houses/ the ID of the house /images, and then we have the actual main.png. So one of the houses, Slytherin, has this, while Gryffindor has this. So now that we've defined a temporary solution, which also can be a permanent solution in some cases for actually storing media files, I think I'm going to end this video here. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. We spent a lot of time developing our actual house app, and I think it's now a good time for us to divert our attention to creating the third main part of our Django REST Framework API, which is going to be the task app. And I say this because most of the functionality that was required by a house app has already been implemented. We now have a houses endpoint where we can see the different houses that are inside of our application. We can see the points they have, the tasks that have been completed, the members that that house has, the manager for the house, and depending upon our privileges, we can actually change specific data regarding a house, as well as have the ability, if we're a registered member inside of their API, to join and leave a house. So with that, we can close this section off. And even though there still exists some functionality that still needs to be implemented for our house app, we are going to be implementing that once we have finished our task API. And in the final section of our course, we're going to be linking all of these app togethers and making the final touches so that everything works cohesively. So with that, I'm going to end this video here, and I'll see you guys in the next one. Thank you. Hello everyone, welcome to this brand new module. In this module, we're going to be focusing towards creating the third and final main part of our Django REST application, and that is going to be the task app. The task app is going to allow us to add functionality to our API regarding task lists and tasks. Each house is going to have a specific set of task lists, which will have a specific number of tasks inside of them. And then these tasks can be completed, and depending upon the completion of all of the tasks, the task list can then be marked complete as well. So now that we have a basic understanding of what we're going to be working towards developing, let's just take a quick look at the actual implementation of it. So I'm running the actual completed version of the API right now in the browser. And our API is now going to have an actual endpoint, which is going to be at API/task, where we're going to be given 3 new endpoints, mainly task lists, tasks, and attachments. The task list endpoint is going to allow us to create new task lists, and then view existing task lists. The tasks endpoint is going to allow us to actually create new tasks. And then finally, we'll have an attachments endpoint as well. And the attachments endpoint is going to allow us to actually view attachments. And to actually view these, I can actually log in. And then logging in, you're going to see that for our actual tasks endpoint, we're going to see all of the tasks that we've created. We'll have the ability to create new tasks and then set them to specific task lists. And then we'll have attachments where we can see all of the attachments that we've created as well. So now if I go to the task list endpoint, you're going to see that we do not get a list of task lists. And the reason for that is because we do not want other people to see the task list for houses. So if you go to the actual endpoint for our houses, which is going to be API/house/houses, you're going to see that now each house is going to have an additional new key attached to it, which will be a list of different task lists that that house has. For example, in this case, Gryffindor has just one task list. If I click on it, it'll take me to the specific object instance for that task list. Here I can see all of the different tasks that that task list has, the status for the task list, and stuff like that. Similar to this, I can click on the task, and then this can take me to the task, and I can see when the task was created, when was it completed, who was it created by, who completed it, the specific task list, and the attachments that that task might have. So in this case, since this task was by bananas, I assume there's going to be a receipt that's attached to it. And if we click on the attachment, it takes us to the specific attachment, which then gives us a data attribute where we can click and actually see the specific receipt, which is just a dummy one attached. So now that we have a basic understanding of all of the functionality that we are going to be achieving by creating this new app, which is going to be called Task inside of API, I'm going to end this video here. I'm going to see you guys in the next one, where we'll be starting our actual endeavor. Thank you for watching. Hello, everybody. In this video, we're going to be creating our actual Task app and then actually creating one of the models that is required by our Task app, and that is going to be the actual Task model. So without any further ado, let's get into it. So to start off, make sure that the virtual environment is activated, and then we're going to run the manage.py start app command followed by the name of the app. In our case, that is going to be task. Doing this, you're going to see that a new folder appears with the specified starter files for our newly created app. And now we're ready to define our first model. So the first model that I'm going to be creating is going to be the task model. And the task model is going to allow us to store data for task inside of our API. So to start off, task class in this case is going to inherit from models.model base class. And then the first field that our model is going to have is going to be created_on, which will be populated the first time this task gets created. And it's going to be a datetime field. And then we'll set the auto_now_add property for this to true. So once we have this, the next thing is going to be the completed on property for our actual task, and the completed on is also going to be a models.datetime field. And this time we're going to specify to our actual Django application that it's okay for this field to be empty, because when our task is created, this field is going to be empty, and only when is it completed we're going to actually populate it. And then I'm going to set the value for the blank property to false as well. So once we have the completed on as well, I'm going to add the created by property, and the created by property will hold a reference to the actual profile that actually created this task. So we're going to have a foreign key relationship, or as I like to say, a one-to-many relationship, because each task can only be created by one person, but a person can have many different tasks created by them. Hence we need a one-to-many relationship where the one side of the relationship is the task and the many side of the relationship is the actual user profile. So I'm going to do models.foreign key, then I'll define the actual model to which this foreign key links to, and that is going to be the users.profile model, followed by null equals to true and blank equals to true. And this is because if a profile gets deleted, I do not want their task to be deleted as well, because we want to keep a list of all of the tasks that were kept. So if there's a user that gets deleted from our application, hence I'm going to set the null and blank attribute to true. And then for the on delete functionality for this actual reference, I'll set it to set null. So if the profile gets deleted, we just want this relationship to be set to null. And finally, I'll add the related name field, and the related name in this field is going to be created underscore tasks. So if I want to access all of the tasks that were created by a particular profile, I'm going to do profile.created tasks to get a list of all of the tasks that was created by them. Following this, we'll also have a completed by property or field for our actual model, and this will be exactly same as our created by. And the only thing that we're going to change for this field is going to be the related name, where instead of doing created tasks, we're just going to say completed tasks. So all of the tasks that have been completed by a specific profile, we can access through the completed tasks. The next thing now is going to be the name for our task. So what our task is going to be called, this is going to be a models.character field. And the max length for this is going to be 120 characters long. Then we'll have a description as well. And the description is going to be a models.text field. And I'll make the description optional. And to do that, I'll just set the null property to true and then the blank property to true as well. And finally, the last thing that we need is a status for our task. So is our task complete or not? And to do that, what we'll do is that we'll create a new status field, and we'll set that equals to model.character field. We'll only allow Django to save a specific subset of characters in this field. And the way we do that is that we're going to go to the top, and we're going to create a new list, which is going to be called task status choices. And we're going to add to this list all of the different choices that we can have for our task. And in our case, a task can be either complete or not complete. So I'm going to first create the not complete choice. So not complete. And then I'll set the value for this to be not completed. And I'll let you know what this non-complete is. But this not completed is going to be the actual option we get from our drop-down menu as a representation inside of maybe Django admin or the automatically generated forms that the Django REST Framework GUI gives us. And then complete as well. And complete, we'll just have this as complete for the string. And this not complete is just going to be a variable that we created, where we're going to actually set not complete as NC and complete as C. So this means that the complete value is going to be C and the not complete value is going to be NC. And this is how the status is going to be represented inside of our database. And that's why we're using a character field. Then what I'm going to do is that I'm going to let the char field know that the max length in this case is just going to be maximum of 2 characters. The choices we have are going to be the task status choices. And finally, the default choice or the default value when a task is actually created is going to be not complete, because when a task is completed, we assume it to be not complete at that time. Hence, we'll set that to not complete. And with this, we can do Alt-Shift-F, Command, Save. So now that we've actually created our task model, what I'm going to do is that I'm going to just define the actual __str___ method so that we get a custom representation for every time we require a string representation for our task object. And I'm going to return the self.id followed by the self.name. And with this, we can do Command Save. The final step we have to do is that we have to tell Django to actually load up our task app and actually use it. And that's going to be the same thing that we've been doing for all the other apps, where we go to settings.py file and then we go to our installed apps list. And then following our house app, I'm going to add our task app as a new addition to the installed apps list, do Alt-Shift-F, Command, Save. And if I run /manage.py run server, fingers crossed, we should get no errors. So start app, and it says that the actual not complete tuple object is not callable. So let's go back and let's see what the issue is. Oh, and the issue is because I haven't added a comma here. So I'm going to add this comma, do Command Save, rerun the app. and hopefully everything should work. So yeah, with this done, I'd just like to apply the changes that we've made to our model, or in this case, we've created a new model to our database. So for that, I'll make a migration. So /manage.py make migrations, and then followed by manage.py, and then migrate. And with this, our changes have been applied to our database, and our database should now be ready to actually handle any data that we pass to it regarding our task model. So with that, I'm going to end this video here, and I'm going to see you guys in the next one, where we're going to create the additional two models that our task app requires, which are going to be attachment and task list. Thank you for watching. Hello everyone, welcome back. In this video, we're going to be creating the two additional models that our task app requires, and that are going to be an attachment model, which is going to allow us to actually have attachments linked to our task model so that people can actually upload like images of receipts or any other thing they want as a file to our actual tasks. And then we'll also have a task list model, and the task list is going to be the actual parent model that is going to hold all of the tasks inside of it, and then each task list is going to be assigned to a specific house. So with that said, let's get going. So the first model that we're going to be creating is going to be our task list model. So I'm going to create the task list model by creating the task list class, and then making sure that it inherits from models.model base class. Once we have this, we'll have the two properties that we have for our task app, for our task list app as well, and that are going to be the created on property and the create completed on property. So I'll just copy these and paste them in. The reason for that is because they're exactly the same for the task list as well. Following that, the next thing we need is going to be the actual house that the task list is going to be attached to. In this case, our relationship is going to be a one-to-many relationship, or in actuality, a models.foreign key field. And the reason for this is because each task list can only be assigned to one house, but each house can have a myriad of different task lists. Hence, we need a one-to-many relationship where the one side of the relationship is going to be the task list and the many side of the relationship is going to be the house. So firstly, I have to tell the foreign key as to which model is this relationship going to be linked to. So that is going to be our house.house model. So house in this case refers to the app, and then the actual house.house refers to the actual house model inside of our house app. Following that, we'll define the actual onDelete function. And if a house gets deleted, what I'd like to do is that I'd like to also delete all of the associated task list with that house, because that's data that's associated with the house. So I'll do models and then .cascade for this. So if a house gets deleted, the corresponding task list to that house gets deleted as well, as specified by the onDelete option that we've set to models.cascade. Finally, the last thing that I'm going to do is that I'm going to set the related name field, and the related name field in this case is just going to be lists. So if I want to access all of the task lists for a specific house, I can do house.list. Okay, now that we have this done, the next thing I'd like to do is that I'd like to add a property to our actual task list, which is going to be created by, which is going to let us know which user actually created our task list. So I'm just going to copy the created by field from our task. I'm going to paste it in here because that's going to be exactly the same, because we need the same models.foreign key field. It links to the same users.profile model. It has the same attributes. And the only thing that we have to change is going to be the related name field, which we're going to set to lists as well. The reason we're setting this to list is because if we want to access all of the different task lists that were created by a specific user, we can do that user's profile.list, and then we'll have access to all of the different task lists that were created by them. Now we need a field to store the actual name for our task list. So that is going to be models.character field, and then we'll have a max length of 120 characters. Then we'll have a description for our actual task list. So the description is going to be the same as our tasks description field. So we can just paste and copy that in. And finally, we'll have our actual status for our task list. And that is going to be also exactly the same as our task status. Because once all of the different tasks inside of our task list are marked completed, the task list is automatically going to be marked complete by some of the logic that we'll implement in the API later on in the course. So I'll add the status field as well. And finally, the last thing that I'm going to do is that I'm going to add the actual string method to our task list, and that is also going to be the same as our task. So I'm just going to copy and paste it in here as well. So now our task list model is defined as well. The final thing that we have to do is that we have to actually create a relationship between our task and our task list model so that each task can be assigned to a specific task list. To do this, what I'll do is that I'll go to our task model and then I'll go down and I'll add a new field. And this field is going to be underscore, it's going to be task underscore list. And I'll set this equals to models.foreign key. And the reason for this is because this is also a one-to-many relationship where each task can only be associated with a single task list, while a task list can have multiple different tasks. I'll let the foreign key field know as to which model this relationship belongs to, and that is going to be task list. So tasks in this case is the name of our app, and it's actually task, not so it's task, not tasks. So task, and then task list is the name of the actual model. And following this, we'll also have the on delete functionality specified, and I'd like to delete all of the tasks for a specific task list if the task list gets deleted. And for that, I'll do models.cascade as an option for on delete property. And finally, we'll have our related name field, and the related name field is just going to be, in this case, our actual tasks. So I'm just going to set that to tasks. To access all of the tasks for a specific task list, we'll do the task list.tasks, and then we'll get a list of all of the tasks. So with this, I can do command save, and now our task model should be linked to our task list. Finally, the last thing we have to do is that we have to create an attachment model. So I'm going to create a new class, and I'll call that attachment. I'll make sure that it inherits from models.model base class. Our attachments is going to have an ID, and the reason we need an ID because we'll have a file field inside of our attachments model class, and the file field is going to have a custom upload to location, and for that we'll require an ID to be available to us even before the actual attachment model is saved in the database. Hence, we need to override the pre-existing ID field that Django gives us, which only gets populated once the model is actually saved to the database, and implement our own ID field, which will be populated before the actual model instance gets saved into our database. So I'll call this models.uuid field. The primary key, this is going to be the primary key, hence I'll set the primary key attribute to true. Then we'll have the default value for this. The default value in this case is going to be uuid.uuid4. And for this, we have to import the UUID package. So I'm going to go to the top, and I'm going to import UUID. And once I've imported UUID, the error should be resolved. And finally, I'll set the editable property for this to false because we do not want the ID to be editable. Then I'll create the created on field, which is going to be populated automatically. This is just a timestamp to as when the attachment was created. We'll have the actual data that's associated with our attachment. So that is going to be models.file field. And then we'll have an upload to location. And before we define the upload to, I'll just set the actual task relationship. So each attachment is going to be related to a specific task. So we're going to create a models.foreign key field. And in this case, the relationship is going to be between the task model and the attachment model. Hence, the foreign key needs to have a relationship set to the task.task model. And following that, we'll have the on delete. So if a task gets deleted, I will also want to delete all of the specified attachments related to it. Hence, I'll do models.cascade. And finally, the related name in this case is just going to be called attachments. So I'll do attachments. So if I want to access all of the attachments for a specific task, I'll do task.attachments. So now that we have this, I'll just override the stir method first before we define the custom upload to location, and that is going to be stir. And then we'll return an f string where we'll have self.id followed by self.task. And then I can do command save. Okay, so the last step that remains is to actually define the custom upload to location for our data. And to do that, we'll do something similar to what we had done for our actual house app as well, where we created a new deconstructible class, which held all of the actual logic for actually generating the path to where the actual data or the image file for the house was going to be saved. In this case, we'll create a new class at the top, and I'm going to call this class generate attachment file path, and then it'll inherit from object. We'll have the underscore underscore init method, for which we'll have self pass to us, and then we'll just pass, and then we'll have the underscore underscore call method, which will actually encompass all of the functionality. We'll have self instance and file name passed to us. I'll firstly get the extension of our file, and that is going to be from file name dot split, and we're going to split using the period, and then we're going to get the extension. Once we have this, I'm going to define the path where our actual file is going to be saved. So that is going to be media/tasks/ the actual task ID. Instance is this case is going to be the actual attachment instance, and each attachment instance has a relationship to the task. So to access the task's ID, we'll do instance, then the task, and then the corresponding ID for it. And then from there, we'll go to attachments, and this should be the appropriate path for our actual attachment. And then following this, we'll have the name for our file, and the name for our file is just going to be the actual ID of the attachment that was just created. So that is going to be instance.id, because instance, this case again, is the attachment object, followed by the extension. And then finally, the last step would be just to return the complete path, which is going to be os.path.join, and then we'll return path, name. But since OS isn't imported, we have to import it. So I'll go to top and I'll import OS. And with this, the error should be resolved. And the final step we have to do is that we have to import the actual deconstructible class from Django utils.deconstructible, and it's not the deconstructible class, it's actually the deconstructible decorator. So it's going to be imported from django.utils.deconstruct and then deconstructible. I'll mark our class as deconstructible, and then I'll create a new variable which is going to actually store a reference to our attachments location. So attachment file path, and I misspelled attachment, so let me just fix that. And then I'll set that equal to a new instance of our generate attachment file path class. And then I'll copy the attachment file path and I'll set the upload location to it. And then we should be all good. So now the final step is to just make the migrations. And the migration would say that you are trying to add a non-nullable field task list to a task without a default. So to fix this problem, it's going to be somewhat of a lengthy, not a lengthy process, but it's going to make this video really long. So what I'll do is that I'll just quit for now by just inputting 2. And then in the next video, I'll actually show you how to actually resolve this problem. So thank you for watching. Hello everyone, welcome back. In the previous video, we had defined our 2 new models inside of our models.py file for our task application, which namely were the attachment and then the task list model. And we had also modified the task model by adding a new field to it, which was task list. When we tried to apply the migrations by firstly doing the make migration step, we realized that we got a prompt by Django asking us to provide a one-off default value. And what this means in the context of the specific migration that we're trying to apply for now is that Django says that there's a non-nullable field for a model that you have, and the model in this case is the task model, and the non-nullable field in this case is task list, and non-nullable just means that this field cannot be empty. And Django is essentially saying if there are any tasks already existing in our database, and we've added this new field in task list now, which needs to be added to those existing model instances as well, what do I set that value to? And for that, we can do 2 things. Either we can just press 2 to quit this and then modify our task model, do something else to it and try to fix it up another way, or to actually provide a one-off default value for all of the existing task object instances that are in our database. We can press on 1, And this should open an interactive Python shell in which we can actually type Python code and actually then assign the value that we want to that specific field. In my case, I know that as of now, our database does not have any task or task list. Hence, what I'm going to do is that I'm just going to add one here. And this just means that for any task object that exists inside of our database, the task list value can be set to ID 1, which means it's going to hold the reference towards a task list with the ID of 1. Since we don't have any task in the database anyway, this is just going to not change anything, but we still have to do this to make the migration. So if I do enter now, you're going to see that it says that it's created the migration, and you're going to see that it says that I created the model task list, I created the model attachment, and then I added field task list to task. So with this, we can do clear to just clear the console. Now that we have done that, the next thing we have to do is that we have to migrate the migrations. So to actually take the migrations that have been generated and then migrate them. And you're going to see that the migrations get applied, and you can see here that it says that I've applied this migration. So once this is done, we can do run server. And now we can go to our actual Django admin backend. And from here, we'll have the list of the 3 new models that we've added. And the first thing I'm going to do is that I'm going to try to create a task list. Once I've created a task list, I'll try to create an actual task. And then finally, we'll create an attachment as well for the task. So let's get going. So for the task list, I'll create a task list. I'll click on add task list. And then from there onwards, what I'll do is that I'll do created by me. For the house, I'll set that to Gryffindor. For our name, for this, what I'm going to do is that I'm going to set the name to be groceries list. And then from there, I'll just set the description to nothing. And then for the status, that's going to be not completed. And with this, I'll do save. And you're going to see that our new groceries list has been created now. The next thing I'm going to do is that I'm going to go to our tasks. I'm going to click on add a task. And now I'm going to select which task list I want this task to be added to. That is going to be the groceries list. The name for this task is going to be buy oranges, let's just say. And then the status is done to be not completed. And then the created by a field, I'll just set that to Hussein. And then with this, I'll click on save. So now we've created a task as well. And now finally, we can create an attachment for the new task that we just created. So I'm going to go to attachments and click on add an attachment. And then I'm going to select the task that I want to add this attachment to. And as you can see here, the ID has already been generated, even though we've not yet saved the actual attachment to our database. And the reason for that is because we actually defined our custom ID field for the model. And then finally, for the data, I'll just put this as a dummy picture. And then click save. And voila, it's saved now. And if you go to the actual media folder, so this would have task/1/attachments, and then here we have the actual image uploaded. So with this, we can see that our migrations were applied successfully. We were able to create a task list, a task, and a corresponding attachment for our task. And all of the data that we required to be shown in our admin interface for our actual 3 models can now be seen. So with this, I'm going to end this video here. And now in the next video, we're actually going to be creating the first serializer for our task app. So with that, I'll end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be creating the first serializer for our task application, and the serializer that we're going to be creating in this video is going to be the task list serializer, which is going to serialize and deserialize our task list model. So with that said, let's get into it. So I'm going to click and create a new file inside of our task app, and I'm going to call it serializers .py. And I do not know why I did pu, but I'll just rename it to py. Once we've done this, the next thing I'm going to do is that I'm going to import the serializer package from REST frameworks. Then I'll also import the corresponding model from the .models file. So from .models import, and then we require the task list. But I'll import all of them right now, the 3 models that we have to create the serializers for, and that is going to be task, task list, and then attachment. And finally, what I'm going to do is that I'm going to now create the class that is going to actually serialize and deserialize our task list model, and that is going to be the task list serializer class. And then I'll make sure that this class inherits from the serializers.model serializer base class. So for this, I'll define the meta class for our actual task list serializer. And here we'll firstly define the model that this serializer is going to attach itself to, and that is going to be the task list model. Then we'll define the fields that our serializer is going to work upon, and those are going to be URL, ID, the actual name for our task list, followed by the actual description. Once we have the description, the next thing that I'd like to do is show the status for our actual task list, followed by an enter so that we have better readability, and then we'll have the created on field. And after we have created on, the next field is going to be created by. Following that, we'll also have the house field, which will be which house our actual task list belongs to. Okay, so with that, we're done. There's still one additional field we need to add for now, but we'll add it later on, and that's the task field, which will show us all of the tasks that correspond to a specific task list. With this done, I'll define the read-only fields for our actual serializer, so read-only fields. And in this, we'll just have two, and that are going to be created _on, followed by the status. And the reason I'm setting the status field to read only as well is because we're going to have logic that's going to automatically be run in our API, where every time a task gets updated, the corresponding task list for that task is going to check that if all of its tasks are completed, then it can mark itself as complete. So that logic would be automatically handled. The user would only have the ability to mark individual tasks as completed or not completed. So once we have this, the next thing I'm going to do is that I'm going to actually define a hyperlinked related field for our house field. So I'm going to set the house field equal to serializers dot hyperlinked related field. And then since this hyperlinked related field is not going to be read only, because we want end users to be able to edit what house a specific task field belongs to, and when they're creating a task list, have a field of house available to them. What we have to do is that we have to define a query set parameter instead of the read-only parameter, and then we have to set the query set parameter equal to the objects that we want the hyperlink related field to be able to use. In our case, what I want is that I want all of the house objects available to the hyperlink related field as options for the task list to be linked to. Hence, I'm going to firstly import the actual house model from the house.models file. So house in this case is going to be the actual house app we have, and then the models file from it, and then we'll import the actual house model. And then we'll set the query set to house.objects.all. So once we've defined as to which models instances our actual hyperlink related field can be set to by defining the query set parameter, the next thing we have to do is that we have to define the many property. In this case, the many property is going to be false because we know that each task list can just be attached to a single house. Hence, that's false. And finally, we have to define the view name. And the view name, since we're using the default router, is just going to be house, the name of the model, -detail. And then the view name is actually view_name. So with this, I'm going to do command save, add a space here, and we should be all good. So once this is done, the next thing I'm going to do is that I'm going to also override the created by field. What I want to do is that I want to show an actual hyperlink related field for this as well. And what I'm going to do this time is that I'll just copy the top field, I'll paste it in here, but this time we'll remove the query set parameter and we'll just set this field to read only. And the reason for this is because every time a task list is created, whoever is going to send us the post request, we'll automatically take that user out, and then we'll set that user as this user who created the task list. And then after that, we do not want the ability for end users to be able to change who created the task list. Hence, I'll set this field to read only, and then I'll set that to true. And then we know that many is going to be false because a task list is only created by a single user. And then finally, the view name is going to be profile-detail. And with this, we can do command save. So now that we've defined our actual serializer, I'm going to end this video here. And now in the next video, we're going to be defining the actual corresponding task list view set for our actual task list serializer, because that is going to be the resourceful controller that is going to manage requests that pertain to task lists. So with that, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In the previous video, we had created our task list serializer, And in this video, we're going to be creating the view set that is going to correspond to our task list serializer. So we have a resourceful controller that knows how to handle requests that pertain to our task list. So with that said, let's get into it. So I'm going to firstly create a new file, and this is going to be called viewsets.py. Then inside of our new file, the first thing we have to do is that we have to make the necessary imports. The first thing that I have to import is going to be the actual viewsets package from the REST Framework package. So, and this is going to be viewsets. Once we have the viewsets package imported, the next thing I'd like to do is that I also like to import the mixins package. And then finally, what I'll do is that I'll import the serializer that we require, task list serializer. Once we have the task list serializer imported, the next thing I'll do is that also import the corresponding task list model. But while at it, I'm also going to import the task model, the task list model, as well as the attachment model. And following this, the final thing that I'm going to do is that I'm going to create the actual class, which is going to be our actual viewset class, and I'll call it task list viewset. I'll make sure that it inherits from the mixins that we require. And the reason we're using mixins in this case and not actually our viewsets.model viewset class is because I want to limit some of the functionality that our task list viewset can do. And the functionality in specific that I want to limit is the ability for our task list model to list multiple instances for our task list. But for now, what I'll do is that I'll add all of the mixins, and then we'll just comment out the ones that we don't need. So I need the ability for the end users to be able to create a task list, hence we'll have the create model mixin. Similar to this, we also want to retrieve specific list models, hence retrieve model mixin. Following that, we also need the mixins.update because we want to update the actual list. Then after that, we also need the ability to be able to delete actual list. So that's why we are going to have the destroy model mixin. And I'll just do Alt-Shift-F to reformat the code, and then I'm just going to hit enter for each of the mixins before their names so that they are on separate lines for ease of readability. After this, the next one we'll need is the mixins.list model mixin so that we can retrieve multiple different instances of our task list objects. And then finally, the last thing we have to do is that we have to make sure that our viewset inherits from the viewsets.generic viewset, because that'll implement some of the functionality that every generic viewset needs, and that is like get object and get query set methods. So once we have this, the next thing I'm going to do is that I'm going to define the actual query set for our class, and that is going to be equal to our actual task list model.objects.all. So all of our task list objects. After that, I'll also define the serializer class, which is going to be task list serializer. Once this is done, I'm going to do command save. But before we can call this video an end, I'll also like to define the custom permission class for our actual task list view set. So I'll define the permission classes property, and then I'll set that to an empty list for now. We'll create a new permissions.py file inside of our task app. And then we'll now create the specific permission class. So I'm going to firstly import the permissions package from REST Framework. So from REST Framework, import permissions. Okay, so once we have the permissions package imported, I'll create the actual permission class, and I'll call this is allowed to edit task list else none. And then I'll make sure that they inherit from base from permissions.base permission class. And once we have this, I'll define the docstring for our actual class just so that we know what this permission class is for, and also custom permissions for task list view set to only allow the creator editing permission. Yeah. Once we have this, I'll define the two new functions that we need. The first function is going to be as permission, and for now we'll just do pass, and then we'll also have the has object permission, which I'll also do pass for now. Inside of has permission, what we want is that we want to allow a get request regardless of whether a user is authenticated or not. So for that, what I'll do is that I'll do if the request.method is in permissions.save methods, then we'll just return true. And this way we'll allow the get method, the method and the options. In the case of a post request, because has permission is also cost for post request, I'll need to make sure that the user is authenticated. For that, I'll check to see that the user is not anonymous. So if not request.user.is_anonymous, and if the user is not anonymous, then we'll return true. Else, if this is not the case, and we come to the end of the function, we'll just return false. So once we have has permission defined, now it's time to define our has object permission. For has object permission, since we've already checked to make sure that the user is authenticated, we can just directly go and check if the user is the actual creator for our specific object. And if it is, then they are going to have the put and patch abilities, which in normal terms would be called editing permissions. So for that, what I'll do is that I'll return request.user.profile, and that is equals to the object, which in this case is going to be a task list. And if we go back to our actual models.py file, you're going to see that for our task list, we have a created by field, hence .created_by. If this Boolean expression returns true, then the user would have permissions, else they won't. So then we can do command save. We can go back to our usage.py file. We can import the permission from the permissions import is allowed to edit task list, else none. I'll paste that in for the permission class. I'll add a comma at the end, do Alt-Shift-F, command save, and make sure that we get no errors, and then we should be good to go. So I'll just do clear, and then I'll just rerun our server and make sure that we get no errors. So yeah, I can see that we have no errors. So with this, I'm going to end this video here, and I'm going to see you guys in the next one where we're going to be defining our actual router for our task app. Thank you. Hello everyone, welcome back. In this video, we're going to be creating the default router for our task app, and then we're going to be adding our task list view set to that default router so that we have this resourceful controller actually accessible through our API endpoints. So with that said, let's get into it. So I'm going to create a new file inside of our task app folder, and I'm going to call it router.py. And once I have this, the next thing I'm going to do is that I'm going to go into the file, and then I'm going to import the necessary packages that we require. The first one is going to be from REST Framework, and it is going to be the routers package. Once I have that imported, I'm going to import the view set that we require, and that is going to be from .viewsets import the actually task list view set. Once we have this done, I'll define the app name, which in this case is just going to be equal to task, because that is the name of our app, followed by an actual variable, which we're going to be setting to routers.default router. And then we're actually going to add our actual view set to this router by doing router and then .register. And then we're going to give it the endpoint after which we want our task list view set to be accessible. And that is going to be the task list endpoint, followed by the actual view set that we want to attach, and that is going to be task list view set. We'll do command save, and with this we can do /manage.py and then run server. And if you reload the app right now, you're going to see that we get an error which says that the task wasn't accessible or this API endpoint is not accessible. And the reason for that is because we've not included this router inside of our urls.py file. So for that, I'll go to our task_API folder. I'll go to the urls.py file, and then I'll go to our API URL patrons list, and I'll add the new router URLs here. So I'm going to define firstly a new path, and I'm going to say that we are going to have everything after the task endpoint for everything that's inside of our task app. Then I require all of the URLs that are going to be registered for our actual default router for our task app. So I've got to firstly import the actual router file. For that, I'll do from task import the actual router file as task_API_router. And once we have this, we can actually use the include function and include all of the URLs that are for the task API router. And to do that, we'll do task_API_router.router.urls. Then we'll add a trailing comma, do Alt-Shift-F, command save. And now if I go to our /API endpoint, you're going to see that we get this new API endpoint presented to us, which is like API/task. And I forgot to add the ending /. I'll just add that here because that is important. Reload the app. And now if I go to API/task, you're going to see that we have this task list endpoint available, which uses our actual task list you said. And if I go here, I can actually see the task list that have been created inside of our application. So now that this is done, I'm going to end this video here. I'm going to see you guys in the next one. We're going to be further developing our actual task application. Thank you. Hello everyone, welcome back. In this video, we're going to be creating the 2 remaining serializers for our task application, which are going to be for the actual tasks model, as well as the attachment model. So without anything further to do, let's get into it. So the first actual serializer that I'm going to be working towards is going to be our actual task serializer. So I'm going to create a class, and I'll call it task serializer. Once I have this, I'll make sure that our actual task serializer class actually inherits from the serializers.model serializer. Once I have this, I'm going to define the meta class for our actual task serializer. And then I'm going to actually set the actual model that this serializer is going to link itself to. That is going to be our task model. Following that, I'll define the actual fields that our task serializer is going to be acting upon. And then I'll also define the read-only fields, which is going to be read_only_fields, and I'd set that to an empty list as well. Once we have this, the next thing I'll do is that I'll start defining the fields. So the first field we need is URL, followed by ID. Followed by that, we need the name. Following the name, we need the description. Following that, we also need the status. After the status, we also have created_on. Following that, we should also have completed_on. And then what I'm going to do is that I'm going to add a comma, and then I'll do enter for just readability purposes. And then following that, we'll have the actual created by field. Similar to the created by, we'll have the completed by field. And finally, we'll have the actual task list field. So the actual task list that this task is a part of. And that is it. Now that we've defined the fields, the next thing we're going to do is that we're going to define the actual read-only fields. And that is going to be created on. Then following that, we'll have created by. Then we'll have the actual completed on. And then the actual completed by. And we'll define the logic for actually setting these automatically inside of our API, because we know when somebody completes a task, whoever sends the completion request will mark them as the actual person that's actually marking the task as complete. Hence, we just don't want to pass us information that we already know. So that's why I'm just setting these fields at read only, and we'll just get the actual profile through the request object. So now that we have this, the next thing I'm going to do is that I'm going to define or override some of the logic for some of the fields that we've defined to our own custom logic. So the first is going to be the created by field. And the created by field, I want it to have a representation in the form of a hyperlink related field. And it's going to be exactly the same as our created by field for our task list serializer. So I'll just copy that and I'll paste it in here as well. It's exactly the same. So we'll have a created by field. And it's going to be a serializers.hyperlinked related field. It'll be read-only, many is going to be false, and then the view name is going to be profile-detail, because the created by relationship is a relationship to an actual profile object. Once we have this, the next thing that we're going to have is going to be the actual completed by. So completed by is also going to be the same as created by. So I'll define the first completed by field, and then I'll just copy what we have for the created by hyperlinked related field. So that'll also be the same. Now that we have this, the next thing that we're going to do is that we're going to define the actual relationship for our task list serializer. So instead of showing the ID for our task list, what I'd like to do is that I'd like to actually have a hyperlink to the actual task list. So to do that, what I'll do is that I'll override the task list field. And now what I'll do is I'll set it to a serializers and then .hyperlinked related field. And since this field is not read-only, because we want the ability for users to actually send in an ID for the task list that they want to associate the task that they're creating to, or they might want to change the task list for a specific task. Hence, we have to provide a query set instead of the read-only property. And I'll set the query set equals to our task list dot objects dot all. Once we have this, what I'll do is that I'll set the many property for this to false. And finally, we have to define the view name. And the view name in this case is going to be our actual task list model dash, and then the actual detail key or the detail word. So it's going to be task list, the name of our model, followed by dash, followed by detail. And this is because we're actually using the default router. And this is how the view names are actually generated for that. So once we have this done with our actual task serializer, so we can do command save. Now what we can do is that we can actually create our actual attachment serializer. So for our attachment serializer, it's going to be fairly simple. I'm going to create a class similar to what I did for the previous two serializers that we've created for this app. I'll call it attachment serializer. I'll make sure that the serializer .model serializer base class is inherited by our attachment serializer. Following that, I'll define the actual meta class. For the meta class, I'll define the model, then the fields, and then the read underscore only underscore fields, and set that equal to an empty list for now. Then I'll define the actual fields that I want for our actual task or our attachment, sorry, and it's going to be URL, then ID, then the actual created on timestamp, followed by the data field, followed by the actual task that this attachment is going to be linked to, and that is all. And for the fields, what I'll do is that I'll just set the read-only fields to just created on. And with this, what I'll do is that I'll do command save. And if I leave the attachment serializer like it is right now, our actual task relationship is going to be shown as the actual ID for the actual task that this attachment is going to be linked to. I do not want that. I want it to be a hyperlink related field. Hence, I'll override the default implementation by defining my own task field, and then I'll set it to serializers, serializers.hyperlinked related field. For the actual task, what we'll have to do is that we'll have to give it a query set, because this field is not going to be read only. So query set, and the query set is going to be equal to our actual task.objects.all. And following that, what I'll do is that I'll actually define the many property to be false. And finally, we'll have the view name, which I'll set to task dash and then detail. And with this, I'll do command save. So with this, we've successfully defined all of our three serializers that we wanted for our task application. So with that, I'm going to end this video here. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In the previous video, we had created the two remaining serializer class for our task app. And now in this video, we're actually going to be creating the corresponding view set classes for our serializers so that they can link up to them, and hence we can have the structure that is required for our app to then create the router, which is going to register the view sets and ultimately allow us to interact with the models and perform actions on them. So with that, let's get into it. So to get started, go to your viewsets.py file located inside of the task app, and from there we're going to create a new class, and this class is going to be the viewset class for our actual task model. So I'm going to call this task viewset, and it is going to actually use our task serializer. So once we have the task viewset class created, I'm going to firstly make sure that it actually inherits from the viewsets.model viewset, because we require all of the functionality that model viewset gives us for this specific viewset. With that done, I'm going to firstly define the query set. The query set in this case is going to be task.objects.all, and we've already imported the specific model here, as you can see in this line. So once I've defined the query set, the next thing I'm going to do is that I'm going to define the serializer class, and the serializer class is going to be our actual task serializer. So I have to import it. So I'm going to go to the top, and after our task list serializer import, I'm going to import the task serializer, and then I can set the serializer class to task serializer. Okay, so once we have this done, the next thing I'm going to do is that I'm going to define the permission classes for our task viewset. So I'm going to create the permission classes property. I'll set that to an empty list for now. And with that done, I'm going to do command save, and I'll head on over to our permissions.py file. Once we're at our permissions.py file, we're going to create a new permission class, and I'm going to call this permission class actually is allowed to edit task, else none. And this permission is going to be responsible for actually allowing users to only be able to interact with tasks that belong to their own house. So if you're not in a house, or if you try to access a task which belongs to another house, then nothing's going to happen. You'll get a permission error for even the GET request. So once this is done, I'm going to make sure that our permission class actually inherits from permissions.base permission, and with that, we're good to go. So once this is done, the next thing I'm going to do is that I'm going to just copy this comment line. I'm going to paste it here, and now I'm going to do custom permission for, and then I'm going to do task view set to only allow members of a house access to its tasks, or access to its tasks. So once this is done, the next thing I'm going to do now is I'm going to define the two functions that we require, which is has permission and has object permission. And for has object permission, we'll get self, request, view, and the object. And then for now, I'll just do pass for this just as a placeholder. And now with this done, what we can do is that we can start coding our has permission function. So inside of our has permission function, firstly, what I'm going to do is that I'm going to check to see if the user is not anonymous. And if the user is not anonymous, we'll just return true. And with this, the next thing I'm going to do is that I'm going to return false. And instead of returning true, what I'd like to also see is to make sure that the house is not null. So I'm going to check to see that by doing request.user.profile.house is not equals to none. So if the user's house is not none, then we'll return true. Now all of the actual checking for the permissions we're going to do inside of our has object permission. So we'll only allow users which are in a house the ability to edit tasks for only that house, and only view those as well. And for that, we just need one line, and that is that we're going to return. And what are we going to return? Well, we're going to compare the request.user.profile.house to the actual object's house. And instead of doing object, I'll just do obj as to follow the naming convention that we've been sticking to. And then for the object, what we'll do is that we'll have the object, which in this case is going to be a task. Each task has a corresponding task list, so we'll access that task list, and then from there each task list has a house associated with it, and then we'll select the house, and if they both match, it returns true, else it returns false. With this, I'll do command save. I'll go back to our viewsets.py file. I'll make sure that I import our actual is allowed to edit task else none permission. I'll paste that in for our actual permission classes, and I forgot an S here. And then with this, I'm going to do command save. So once we have defined our new task viewset class, the next class that we have to define is going to be our actual attachment viewset class, which is going to be the viewset that is going to handle interactions with our attachment model. So I'm going to create an attachment viewset class, and then what I'm going to do is that I'm going to actually import the specific functionality I need by inheriting mixins and not the actual viewsets.model viewset class. And in this case, the mixins that are required are going to be mixins.create model mixin, because we want the ability to create. Similar to this, mixins.retrieve, because we want the ability to retrieve. We need the ability to update, so mixins.update model mixin. From that, we also want the ability to destroy, so mixins.destroy. Once we've done this, I'm just going to do enter, and then reformat the code just for readability purposes. And then finally, just for now, what I'm going to do is that I'm going to add the mixins dot and then the actual list model mixin, but later on we'll actually comment this out. And finally, the last thing we need is going to be viewsets generic viewset. And then once we have this, now we can define the actual attributes. So the query set for this class is going to be equals to our attachment object, so attachment.objects.all. Once we have this, the next thing I'm going to do is that I'm going to define the serializer class, and the serializer class in this case is going to be our attachment serializer, which needs to be imported. So where we have our existing serializers import statement, I'm going to add the attachment serializer import and then set the serializer class here to attachment serializer. And once we have this, we are finally ready to define the permission classes, and we'll set that equal to an empty list for now. Then we'll hop on over to our permissions.py file, and inside of there, we're going to define the actual permission. So for the permission, again, what I'm going to do is that I'm going to create a new class, and I'm going to call this class is allowed to edit attachment else none. And then I'm just going to fix the spelling here, attachment. And then what I'm going to do is that I'm going to make sure that we inherit from permissions.base permission. And then what I'm going to do is that I'm going to define the has permission function and do pass for now, and then do has object permission and then do pass as well. And now for has permission, the only thing that I'm going to check is to make sure that the user is not anonymous and that their house is not actually none. So that's basically the same logic. So just copy this and paste this here. And once this is done, the next thing I'm going to do is that I'm going to do all of the magic in has object permission. And in has object permission, I'm going to do stuff similar to what we did for our edit task else none permission, but the check that we're going to be doing is going to be a bit different. So firstly, we'll access the request. So request.user.profile. And then house. And then we'll check to see if that is equal to our actual object. And from our object, we'll have the task. And in this case, our object has the task, which is then going to have a corresponding task list to it. And you might be wondering what this object is, since this permission is going to be attached to our actual attachment view set. Hence, we are going to have the attachment model as an object, and that attachment has a corresponding task to it. That task has a corresponding task list, and then each task list has a corresponding house. Hence, we can check the relationship there, and then we can do command save, come back to our viewsets.py file, and then make sure that we import the actual permission class. So is allowed to edit attachment else none, copy it, put that in for our permission classes, add the remaining comma, do Alt-Shift-F, command save, and we should be good. So now with this, since we do not have the router set up right now, we can't actually test our view sets. So in the next video, we're going to actually set up a router and then actually test to see if our actual view sets perform as intended. So with that, I'm going to end this video here. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In the previous video, we had created our attachment view set and task view set. And now in this video, we are going to be actually setting up our router to actually use these two new view sets that we've created. So let's get going. So we're going to go to a router.py file, which is inside of our task app. From there, I'm just going to do router.register. And this time I'm going to register two new endpoints. And the first one that we need is going to be our actual tasks. So that is going to be tasks. And then we need the actual view set. So I'll import it here at the top. And then I'm going to do task view set. And while I'm at it, I'm also going to import our attachment view set. So once we have this, I'm going to set the tasks endpoint to use our actual task view set. And then with this, I'll do router.register again. And this time I'm going to have attachments. And then for our attachments, we'll set that endpoint to attachment view set. But this I can do command save. So once this is done, what we can do is that we can go to API, and then from there we can go to task. And then you're going to see that two new endpoints show up that are tasks and attachments. And if you go to our actual admin panel and go to tasks, you're going to see that we have this one existing task, which is called buy oranges. And what I'm going to do now is that I'm going to try to create another task. And to do that, I'll just use the Django admin panel. So I'll click on add task, and then I'm going to do created by, and this time I'm going to do the other house. So that's going to be Draco as the user who created it, the task list. So we need a new task list as well. Instead of just navigating here and then opening up another tab and then trying to create a new task list there, you can just click on the plus sign as indicated here. And then with this, you can create the new task list. So the task list that we want to create is going to be created by Draco. In this case, it's going to be the Slytherin house. The name for this is going to be groceries list again, or maybe this time, instead of doing groceries list, we can do actually cleaning supplies, right? And then for the description, I'll just leave it to nothing and then not completed. And with this, I can do save. So now, and then the task list can be set to cleaning supplies. With this, the name is going to be, in this case, we can just say buy, and then we can say trash bags, let's just say. And then for the status, I'll set that to not completed, and I'm going to do command save. So we have another task that's just come up. And now what I'm going to do is that I'm going to go back to our actual API root endpoint. I'm going to reload, and then I'm going to go to the tasks endpoint. And for now, you can see that we can see both of the tasks for the different houses that we are in. And this is functionality that we do not require, and we'll fix that later on in the course. But now what I'm going to show you is that our permissions actually work. So if I go to our actual buy oranges task, which is a task for a task list which belongs to my house, as you can see, house, which I am a member of, you are going to see that I can actually edit the task and get the task, and I have all of those options available to me. But if I go back and I see the buy trash bags task, which is not belonging to my house, you're going to see that I get an error saying you do not have permission to perform this action. So now how do we limit actually this functionality where we do not get a list of tasks? So there are two ways. One of the ways would be to actually just disable the functionality for actually showing us the specific task list. And the way you would do it would be to go back to your viewsets.py file. Instead of inheriting from viewsets.model viewsets, you would implement the mixins that you need and just omit the mixins.list model mixin. But sometimes you may want to get a list in that case. Oh, and what in that case you can do is that you can modify the query set. And the way you can modify the query set is that you can actually define a function inside of your view set, which is called get underscore query set. And then what you can do inside of here is that you can explicitly define what objects the task view set has access to, or what objects should be returned. So to do this, what we do is that we first get the query set. That is the global query set. And to do this, we use super, and then we do task view set as the first argument. So we get the query set for the super class, and from there we do dot get underscore query set. So you get the query set from the actual super class. Once we have this done, the next thing we do is that we have to get access to the actual user profile, which has sent us the request. So that is going to be self.request.user.profile. Once we have this, the next thing we can do is that we can do query set, and then we can set that equal to the query set, the global query set that we got. And this is going to be the updated query set, we can say updated query set. And then we can set that equal to query set dot, and then we can filter the query set, and we can only get the objects or model instances back which have the created by reference set to our user profile. So which were created by our actual user who's sending the request. So for that, we'll filter by the created by property, and we'll set that equal to user profile. So filter the query set and return everything to us where the created by field is equal to our user profile. And once you're done with that, just return the updated query set. With doing this, you can do command save. And now what you're going to see is that once I actually reload the /tasks endpoint, it gives us an error saying that the user object is to attribute user profile. And yes, the object attribute is profile and not user profile. Reload, and you're going to see that now we get only the actual task that we created. So the API/task/tasks endpoint returns us a list of tasks that were created by us. Okay, so now we fixed this problem, but another problem arises, and that problem is that now we can only see the tasks that we have created, and we do not have a way of actually accessing all of the tasks that belong to a specific house. And we're going to fix that problem in a later on video where we'll define a new property for our actual house view set, which is going to give us a list of all of the task lists that belong to a house, and then each task list will then point us towards the task that it contains. But for now, this was what I wanted to show you, and the reason I did it this way so that you guys can actually understand how to define these specific custom tailored query sets. So once we have this done, what I'm going to try to do now is that I'll just test the actual attachments endpoint as well. So for that, what I'll do is that I'll firstly create an attachment, and I'll know that I've created this one attachment for buy oranges. So I'm going to go back and I'm going to go to our attachments endpoint, and you're going to see that we have created this one attachment. And what I would like to do is that I'd like to disable the ability to actually see all of the attachments from here. I don't want a list of attachments to be returned because I don't want users to be able to see other people's attachments. So instead of just defining a query set, this time what I'm going to do is that I'm just going to comment out our list model mixin, and this would remove the listability for our actual attachment view set. If I do command save now, this method is now going to be available, as you can see. But now how do we actually access specific attachments? Well, what we do is that we go to a specific task that we care about, and from there we can actually access its attachments. And we're going to fix this also in the next video, where we're going to actually update our actual serializers so that they include all of the missing information and actually create up all of the links. So with this, I'll just ask you guys to have faith and don't think like it's getting a lot confusing. In the next video, when we fix everything up and add the missing links and we update all of our serializers, you're going to see that everything is going to make a lot more sense and have a lot more clarity. But for now, you can see that our permissions are working, because if I log out, we can't even access the actual tasks endpoints anymore. We can also access the attachments endpoint. So with this, I'm going to end my video here. I'm going to see you guys in the next one. Hello everyone, welcome back. So now all of the main parts for our task app are complete. We have the view sets that we require, the serializers we required, and we have all of them registered in our order as well. But there are still some minute details that are missing from each of our view sets. And in this video, we're just going to go through all of the different view sets and serializers that we have, and we'll update them to include some stuff that we have missed out previously when our app didn't have all of the parts required for defining those relationships or attributes. So with that said, let's get into it. So the first thing that I'd like to do is that I'd like to update our serializers. And from what I can see right now, our task list serializer has a problem. And the problem with our actual task list serializer is that it does not return us a list of tasks that belong to it. So we're going to fix that. So to do that, what I'll do is that I'll firstly create a new field, and I'll call that tasks. And then what I'll do is that I'll set that equal to serializers dot hyperlinked related field. And then what I'll do is that I'll set this field firstly to read only. Then after this, what I'll do is that I'll set the many property for this equals to true. And finally, the view name for this actual field is going to be our actual model name, which is tasks followed by dash detail. And then we can do command save, but before that we have to include this field inside of our actual fields list. And then after the actual house, I'm just going to add this new field called task and do command save. With this, I'm going to reload our API. I'm going to log in as well. So sane and then test123 hash. And then once we've logged in, we can actually go to our task list endpoint, and you're going to see now that for each of our corresponding task list objects, we get a new field tasks, which gives us a list of tasks that corresponds to it. So this way, now we have an ability to see what all tasks belong to a specific task list. So once this is done, the next thing that I'd like to do is that if we go back to our actual tasks endpoint, you're going to see that our task endpoint does not give us information regarding all of the attachments that relate to it. So we have to add a similar field, such as the tasks field that we added to our task list serializer to our task serializer. And that is going to be the field that is going to show us all of the attachments. So I'm going to call this field attachments, and then this field is going to be also a serializers.hyperlinked related field. And if I don't do hyperlink related fields and I just remove this, and I just add attachments just to show you as a field, and I do command save and reload our endpoint, we'll still get an attachments key and we'll have a list of attachments, but then the actual way the relationship is shown is going to be by providing us the different IDs. And I don't like the way this works. Hence, what I'd like to do is that I'd like to actually use a hyperlink related field. So to do that, I can just do attachments equals the serializers that hyperlink related field. And then what we can do is that we can set the read only property for this equals to true. And this is going to be essentially the same as what we did for our tasks field, many equals to true, because we know we're going to have returned many results. And then finally the view name, and the view name in this case is going to be attachment, which is the name of our model, followed by dash detail. Do command save, make sure the server reloads, no errors, reload, and we get an error which says the field attachments was declared on serializer but not included. And yes, I have to include the attachments field inside of the fields list. So just add this, do command save, reload, and we should be all good. And now we should have access to attachments as well. So now that we have this done, all of the functionality that was required by our taskless serializer, which pertains to how they represent data, is done now. And now what we're going to do is that we're going to go to our view sets and we're going to update them a bit. We can start off by looking at our task list. And you can see that when we go to our task list, we can see all of the different task lists that are inside of our application. But this is not the functionality I want. I do not want people to be able to see a list of all of the task lists that are inside of our application. Hence, I'm going to remove this functionality from our view set by just commenting out the list model mixing for our actual task list view set. Doing this would remove the functionality that allows the actual view set to return us a list of all of the different task lists we have. And you're going to see that this method is not allowed anymore. So now the question comes, how do we access the task list? Well, to do that, what we do is that we go to our actual API endpoint, which is API/house/houses. And from there, we're going to add a new key to our actual serializer, which we're going to be calling task list, which is going to give us a list of all of the task lists that have been created for that specific house. So to do this, what we can do is that we can go to our house app, we can click on serializers.py, and here what we can do is that we can define a new field which is going to encompass all of the logic related to actually showing the task list. So to do this, what I'll do is that I'll create a new field and I'll call this task list, and then I'll set that equal to serializers dot hyperlinked related field. And then what I'll do is that I'll write the read only property for this to true. I'll set the many property for this to true as well. And then finally the view name to actually task list dash detail. Do command save and then go to our fields and add the actually newly created field here. So it's called task and then list. Do command save, reload our app for the specific endpoint, and it says the house object has no attribute task list. And I intentionally did this because I wanted to show you how you can actually fix this problem. And the reason you're getting this problem is because the field that you've defined does not correspond to a field that was on our actual model. And to fix that, you can do two things. Either you can rename this field to refer to a field that exists on our model, which in this case, since we're referring to task list, was list, and then just add it here, command save and reload, and you're going to see that it's going to now work and returns a list of task lists. But sometimes you want to give more meaning to the names that you give your fields, and I think task list gives more meaning. Hence, I'm just going to change things to the way they were before. And instead of changing the name for the field, I'm going to define this new field inside of our actual hyperlink related field, which is called source. And for source, what I'll do is that I'll actually type in the field that I want this hyperlink related field to actually link itself to, and that is going to be list. So source essentially is like where you're going to pull all of the data that this field requires from. And then you can do command save. So if you omit the source property, then it usually just takes whatever the name of the field is and tries to find a field corresponding to that on the model and then pull data from there. So now do command save, reload the app, reload, and you're going to see that our actual API updates. And now for each of our houses, we get a new key, which is called task list, which returns us a list of all of the task lists that correspond to that house. So now if we click on the task list, that takes us to actual task list instance, where if we have permissions, then we can see the task list, else we cannot. Since this was the Slytherin house, I didn't have permissions, but if I go to the Gryffindor house, you would see that I have permission for the task list that belongs to the Gryffindor house. And then once you are at the task list, you get another list which is the list of tasks that belong to this task list. Clicking on them again, if you have permissions, you can see them, else you cannot. You can see all of the task list, and for each task, you have a list of attachments. And this is how the data flow will work. So now you can see how it actually works. So now all we have to do is that we just have to fix up the functionality and make sure that the task list endpoint, the task endpoint, and the attachment endpoints work as intended. So now the task list endpoint is working as intended. It gives us the ability to create a new task list, but we cannot see a list of task lists, which is a good thing. That's what we want. For tasks, we are now only getting the tasks that we've created by ourselves. You can change this functionality to just be the way the task list view set works, where we just remove the list functionality from our task view set. And I wanted to show all of the different techniques that you can do to achieve different results. Hence, I'm just going to leave it as it is, and we can still create new task lists. And finally, the next thing is for our attachments. You can see that we do not get a list of attachments, but we can still access them by going to our actual houses endpoint, and from there navigating to the specific task list, then to the task, and then to the attachment. So with that, I can see that all of the permissions are working, and our view sets and serializers are set up the appropriate way. With this, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be updating our task serializer and actually adding the ability to our task serializer to actually create tasks. Now, some of you might have a question saying that why do we need to implement that functionality since we already inherit from serializers.model serializer, and it gives us a default implementation of the create method. What's the need for implementing custom functionality for the create? And the reason for that is because we're not validating the data that is getting passed to us. Well, we're validating the data, the necessary checks are being performed, but there's this very specific validation that is specific to our use case that is not being performed. And the one I'm talking about is that the task list that gets provided by the user when they want to create a new task has to correspond to a house that they are a member of. So if you try to create a task for a task list that does not belong to your house, you should get an error. And for now, if we go back to our actual API/tasks endpoint, and then I try to create a new task, and I'll create a new task and I'll call it by apples, for example. And then what I'll do is that instead of adding it to a task list that belongs to my house, because I'm logged in as Hussein, who belongs to the house Gryffindor, I'm going to do the task list 2, which is ID 2, which is a task list that does not belong to the house that I'm a part of. And if I do a post request, you're going to see that I actually get a successful response of 201 created. And now if I go to our admin panel, you're going to see that the new task shows up, which is here by apples, and it is for the task list 2. And if we go to our task list 2, you're going to see that that task list belongs to the Slytherin house, which I'm not a part of. So we have to fix this problem. The way we're going to fix this problem is that we're going to be implementing validation logic inside of our task serializer and then updating the actual create method definition as well, or overriding it. So to get started, let's first implement the validation, and then we'll look at the create function. So to implement the validation check, there are two strategies that we can employ. The first is that we can create an actual validate function. And in this case, we're going to get all of the attributes that get passed to our serializer, and then we can go and check all of the attributes we want. But I'm going to define the validation logic in this case separately, where I'm going to have a function that is going to only validate our task list field. And the way you do that is that you have a function that is named as validate. And after you've named your function validate, you add an underscore followed by whatever the name of the field that you want to validate is, so task list. Now this validate function is not a validate function that is going to be passed all of the data that gets passed to our serializer, but only the specific value that relates to our task list, because this validate function is going to only validate the task list field and nothing else. And the reason I'm doing it this way and not actually just implementing a validate function is because I wanted to show you another way of actually working with validation logic. So the actual validate function would then have everything passed to it, and it would have self and attributes as the things get passed, while the actual validate task list function, it's going to get itself passed to it, but instead of having a list of attributes passed to it, we'll just have a value that is given to us, and that value would correspond to whatever field this function is going to validate. And in our case, we're going to validate task list. So what I'm going to do first is that I'm going to get the user profile. And the way to do this is that self, and then there's dot, and then we do context. And then following that, we do request. And then once we have the request object, we can do user and then profile. Once we have this, the next thing I'm going to do now is that I'm going to check to see if the actual value, and what's the value? Well, the value is the task list. So if the value or the task list, you can say, is not in, and what is it not in? It's not in the user profile dot house and then dot lists, because that's how you access all of the task lists for a specific house dot all. So if the task list that we get, which is value, is not in all of the task lists that belong to the house that the user is a part of, then we have to return an error. And what we're going to return, well, we're going to raise a serializers dot validation error. And then inside of here, I'm just going to copy and paste the error in. It's just a string, and it says the task list provided does not belong to a house for which user is member. And once we have this, what I'm going to do is that I'm just going to add an enter here just for readability purposes, and do Alt-Shift-F just to reformat the code. And now finally, if this is not the case, and if the if statement does not run, that means that our check was valid and we don't have to raise a validation error. Hence, we can just return the actual value. And with this, we are done with our actual validate function. So now that we've implemented the validate task list function, the last thing we have to do is that we need to implement the create function. So for the create function, I'm just going to create the actual create method. And you're going to see that now we get validated data passed into us. The first thing I'm going to do is that I'm going to get the user profile, and the user profile is going to be obtained the same way. So self context, from there we get the request. And once we have the request object, we can do user.profile. And then we have the actual profile. Once we have this, I'm going to create the new task by doing task, task dot, and then dot objects, and then dot create. And make sure the task is inputted from the models dot create. And from there, what I'm going to do now is that I'm going to pass in the validated data by doing star validated data. Once we have this, the next thing I'm going to do is that I'm going to do task and then dot created by, because we need to set who the task was created by, and that is going to be equal to user profile. And finally, the last thing we're going to do is that we're going to perform the transaction on the database by doing task.save, and then we'll just return the actual task. With this, we can do command save. And then what I'm going to do is that I'm going to actually go to our tasks. I'm going to show you that for buy apples, when we had done the actual post request and we've actually created it, not only did it not validate the task list that was provided to it, but it also didn't populate the created by field, but now it should be fixed. So I'm just going to delete this task. I'm going to go back and I'm going to go to our API root. From there, I'm going to go to tasks. So I'm now at /API/task/tasks. And from there, what I'm going to do is that I'm going to now create a new task, and I'm going to call this buy bananas. And then from there, I'm going to set the grocery list to 2 this time, just to show you this is not going to work. And if I do a post request, I should get an error, and it should say 400 bad request, and it should say for the field task list, the task list provided does not belong to host for which user is a member. So now I'm going to change that to a task list that that belongs to a house that I'm a member of, which is 1. I'm going to do post. I should get a 201 response back, as you can see here. And now if I go to our admin panel, I go to tasks, you're going to see that the new task is here. And if I click on it, you're going to see that the created by field is also populated, and the task list is the right task list, as you can see. So with that, we've fixed the functionality for our task serializer. Our task serializer now has custom validation logic for validating the task list that is provided to it and only allowing users to create tasks for task lists that belong to their house. So thank you for watching, and I'll see you guys in the next video. Hello everyone, welcome back. In this video, we're going to be addressing a issue that can be seen for attachment serializer, where we can create attachments for tasks that are not belonging to our house. So a user can just go to API/root and from there to attachments, and they can create a new attachment for any task that is available to them, regardless of whether that task belongs to a house they're a part of or not. So what we're going to be doing in this video is that we're going to be implementing custom validation logic inside of our attachment serializer to actually address this problem and make sure that users can only attach attachments to tasks for houses that they're a part of. So let's get going. So to get started, we are going to go to our serializers.py file present inside of our task app. From there, we're going to browse down over to our attachment serializer class, and then here we are going to create a new function, and I'm going to this time create a validate function. So the difference between the validate function and a validate function that has underscore followed by the name of a field is that validate function just gets run on a specific field, while this validate function gets passed in all of the data that gets passed to our attachment serializer, and then we can perform validation of all of the data at once. So in this case, what I'd like to do is that I'd like to use the validate function, and we're going to have attributes passed to us. And the reason I'm doing it this way is just to show you another way of how to achieve the same result. So to get started, the first thing we need to do is that we need the user's profile. So that is going to be accessible the same way we do self, and then from there we do context, and then we get the request, and then we do user.profile. Once we have this, the next thing we do is that we get the task. So to get the task, what we can do is that we can do attributes, which is a dictionary, and then the key that we need in this case is task, which corresponds to whatever field that you want to get the data for. So I want to get the data for the task field, hence I do attributes, which is a dictionary of all of the fields that get passed to attachment serializer, and I get the task value out of there. Once we have access to the task, the next thing I need to do is that I have to get the task list that corresponds to this specific task. To do this, I have to run a query on the database, and in specific a get query. So to do this, what I'll do is that I'll do task list dot objects, and I want to get an object. And what do I want to get? Well, I want to get an object where the tasks underscore ID underscore is exactly equal to. And what is it exactly equal to? Well, it is equal to our task.id. So now that we have the task list, we can just check to see if the task list is not a part of the house that the user is a member of. And for that, we do if the task list is not in the user profile .house.lists.all, then that means that the task that we were trying to attach the attachment to does not belong to our house. Hence, what we can do is that we can raise a validation error. So that's a serializers.validation error. And then we can pass in a message. And the message that I'm going to pass is going to be exactly the same. So that is going to be task provider does not belong to a house for which the user is a member of. And I'm going to actually create this into a dictionary. And then I'm going to add a key to this, and the key is just going to be the name of the field, which is task. And then with this, I'm going to do Alt-Shift-F, and we should be good. And I've reformatted the code. Alt-Shift-F just reformats the code. And then finally, if this if statement does not raise a validation error, then we have made all of the validation checks, and I'm just going to return the attributes. And then we can do command save. So with this done, we are ready to actually test out our implementation. So I'm going to go to our attachment lists, and I'm going to try to add a new attachment. So I'm going to go and I'm going to just look for receipt. Go to images, then maybe save this image on my desktop. And once this is done, I'm going to go back to attachments. I'm going to reload the page, and I'm going to try to go to our desktop and then set the receipt that we just recently downloaded, and then I'm going to try to attach it to a task that is not belonging to my house, and a task that does not belong to my house is buy trash bags. So I can do post, and we should get an error which says the task provided does not belong to house for which user is a member. Nice. So now if I just change that task to a task that does belong to our house, and that could be, for example, buy bananas, because I'm logged in as a sign, I do post. I have to submit the file again, so just do this. Make sure the task is correct and do post. You're going to see that I get a 201 response back. The attachment is created. I get the URL to actually access the actual downloaded image, and everything looks good. So with that, we've implemented custom validation logic inside of our attachment serializer that allows us to validate that the attachment that we're trying to create is only allowed to be attached to tasks that belong to a house that we are a part of. So with that, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be implementing the automated logic inside of our API to actually update the points for a house every time the status of a task is updated. And we're also going to be implementing a function besides the update house points function, which is going to be responsible for actually updating the status of a task list if all of the tasks that are present inside of that task list have a status of completed. So with that said, let's get into it. So to get started, we're going to go to our task app folder, and here we're going to create a new file, and I'm going to call it signals.py. Once we have this, the next thing I'm going to do is that I'm going to import all of the necessary imports that we require. So firstly, we require the actual signals, and that are going to be imported from django.db.models.signals. And the actual signals we need are actually post delete, post save, and pre-save. Once we have this done, the next thing I'm going to do is that I'm going to import the actual decorator, and the decorator we need is the receiver decorator, which will allow us to actually change the normal functions that we define into signal handling functions. And finally, the last thing I need is I need models that our signals are going to work upon, and for that I'm going to import the task model from the .models file, and besides this I'll also import the complete and not complete variables. So once we have this, the first thing we're going to do is that we're going to be implementing the function that is going to be responsible for updating the house points every time a task is set to complete, or every time the status of a task changes. So to do this, first we have to define the function, and we're going to call our function update_house_points. And our function is going to get sender instance created, and then additional arguments at **quargs as arguments passed to it. And then to actually mark as function as a signal handling function, we have to decorate it with the receiver decorator, and then we have to tell the receiver function what signal does it have to run on. In our case, it is going to be post save, and who the sender for this function is going to be. In our case, that is going to be the task model. So now what is going to happen, that this function is going to run every time something happens to an instance of a task object inside of our database after it's saved. So now what we have to do is that we have to first get the house that the task corresponds to. To do that, what we can do is that we can access the task by the instance variable that has passed to us. We can get the corresponding task list for the task, and then we can access the house that task list corresponds to. Once we have this, the next thing I can do is that I can check to see what the status of our task is. So if instance.status of our task is equals to complete, then what I have to do is that I have to increment the points. And the way I'm going to increment the points is going to be house.points, and then we can do plus equals 10. So we're incrementing the point by 10. Else if the instance.status is equal to not complete, then what we have to do is that we have to decrement the points. But I'm going to just make a check before decrementing the points to make sure that our points never go in negative, by making sure that the house points are greater than 10. And if they are, then we're going to decrement the house points by -10. So once we have this done, finally, once all of the logic inside of our function is done, the last thing we have to do is perform the transaction on our database for the changes that we've made to our house object instance. and then just do command save. And now our signal is all set up. So now the next thing I'm going to do is that I'm going to define another function which is going to be responsible for actually updating the status of our task list once all of the necessary tasks have been marked as completed. So to do this, what we have to do is that we have to create a new function, and I'm going to call it update underscore task list underscore status. And then what I'm going to do is that I'm going to have sender instance created and star quargs as arguments that get passed to our function. I'm going to define the actual receiver decorator for this function and then tell the function that this is going to run on every post save signal, and the signal we're going to be receiving is going to be from the task model. So now what is going to happen is that every time something changes inside of our task model and it is saved into the database, this function is going to run. The first thing we're going to do is that we're going to get the task list from the actual task object, and that is going to be done by doing instance.task underscore list. Once we have this done, the next thing we have to do is that we have to create a new variable, and I'm going to call this is complete, and I'm going to set this equals to true to start off. Now what we have to do is that we have to loop through all of the tasks that are present inside of our task list. So to do that, what I'm going to do is that I'm going to do a for loop, and I'm going to do for task in, and then I'm going to do task list dot tasks dot all. So I'm going to loop through all of the tasks inside of our task list. If the task dot status for any task is not equals to complete, then what we can do, and I'm just going to do complete, then what we can do is that we can mark the is complete Boolean value as false, and we can break from the for loop. And if all of the task statuses are complete, this is never going to happen. So is complete is always going to be false. Once we're done and out of our for loop, we have to set the task list status to whatever new status that we have calculated. And then the way I'm going to do this is I'm going to set the task list dot status to complete if is complete is true. And this is a tertiary statement. And if this is not the case, else, if this is not the case, then what we're going to do is that we're going to set it to not complete. And finally, the last thing we have to do is that we have to perform the transaction on the database. So that is going to be done by doing tasklist.save, and then we can do command save. So now our signals are defined, but we still have to do some actual integrating work for our task app to actually tell Django to actually load up these signals. So the first thing we have to do is that we have to go to our apps.py file. And inside of our apps.py file, we are going to define this function, which is called ready. And inside of the ready function, what we're going to do is that we're going to import our signals, and the signals are going to be imported by doing task.signals. So now that the signals are imported, the last thing we have to do is that we have to go to our init_.py file, and there we have to define a variable which we'll call default_app_config, and then we're going to set that equal to task.apps.task and then config, and then we can do command save. And now hopefully our API should be reloaded and our tasks should be working. So the first thing that I'm going to do is that I'm going to check to see that the points of our house get updated every time we change the status of a task to complete. So to do that, what I'll do is that I'll go to /API/house/houses. From there, I'm going to select my house, which is Gryffindor. And then I'm going to go to the corresponding task list of that house. And then I'm going to select a house or a task, sorry. So I'm now at this task, and as you can see, that status for this task is not complete. And if we go back, you're going to see that the points of our house for now is 0. So with this done, what I'm going to do is that I'm going to mark the status of our task as complete, and I'm going to do the put request. The status is now changed to complete. And if we go back to our house instance and I reload, you're going to see that the points of our house are being updated to 10 now. And now I'm going to go back to our task list, and you're going to see that our task list is still not complete because task 5 is not complete yet. So I'm going to go to our task 5. I'm going to mark it as complete as well, do a put request. And now the status of our actual task is complete. And if I go back to our house instance, reload it, you're going to see that the points are at 20. And if I go to our task list, you're going to see that the status of the task list is complete as well. And if I now go back to our task 5 and I set the status for it to not complete, and I do put, and I go back and I reload the task list, you're going to see that the status again is now been set to not complete and the points of the house have been returned back to 10. So with this, we have successfully implemented the functionality of actually automating the logic for updating the task list status as well as the amount of points a house has, dependent upon the status of the tasks that pertain to the task list or to the house. So with that, I'm going to end this video here. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be updating the logic that is going to be used to actually change the status of a task from complete to not complete and from not complete to complete. The way we're going to be achieving this is that we're going to be defining a custom action for our task view set, which is going to handle all of the logic that relates to updating the status of a task. And once we have that done, then we're going to be actually going and updating our serializer to change the task status field inside of our serializers to a read-only field to disable the functionality for users to change the status without using the action that we are going to be creating in this video. So without anything further to do, let's get into it. So to start off, what I'm going to do is that I'm going to create a new function, and I'm going to create this function inside of our task view set after the getQuerySet function that we had defined, and I'm going to call our function update, update underscore task underscore status. With this done, what I'm going to do is that I'm going to define the arguments that are going to pass to our function, and that is going to be self, request, and then primary key equals to none. Once we have this done, the next thing I'm going to do is that I'm going to make sure that I import the appropriate decorator. So the decorator that I have to import is the action decorator, and that is going to be imported from REST Framework. So I'm going to do from REST Framework dot decorators import, and what are we going to import? Action. Once we have this done, the next thing I'm going to do now is that I'm going to go down back to where we were defining our function, and I'm going to decorate our function using the action decorator. And then for the actual action decorator, I'm going to define some parameters for it. So the first one is going to be detail, which will be set to true. And then following that, we'll have the actual methods that this action allows. And in our case, the method that is going to be allowed is going to be called patch. And be careful, patch in this case is going to be all lowercase. Once this is done, I can continue onwards to define the actual body of a function. So we're going to have a try except block. And inside of our except block, we are just going to catch an exception as E. And for now, we'll just set that to pass. So once we have this done, the first thing we have at hand is that we have to get the actual task for which we want to update the status. For that, what we can do is that we can create a new variable task, and we'll get the actual task object by doing self.get underscore object. Once this is done, the next thing I have to do is that I have to get the profile of the user that is actually trying to update the status for a task. That can be done by doing request.user.profile. And once we have this done, the final thing that I have to do is that I'm going to extract the key that is going to be sent to this specific endpoint regarding the status that we want to set for our task. And that is going to be done by doing status is equals to and then request. And we're going to go to the data dictionary of our request. And from there, I'm going to extract the status key. Okay, so once this is done, we are good to go. So the first thing I'm going to do is that I'm going to do if and then status is equals to not complete. So if the provided status to us is not complete, that means that we have to set the task status to complete. But before that, we have to make sure that the task is already not marked as not complete. So to check that, what I'll do is I'll do if task.status is equals to complete. That means that now we can mark it as not complete, and that can be done by doing task.status equals to not complete. And we have to import these actually, and for me, VS Code automatically did this, but for you, you might have to actually import the complete and not complete variables yourself, and that can be done by doing from.models import and then complete and not complete. So now the task status is being set to not complete. We also have to set the task dot and then completed on value to none. And we have to set the task dot completed underscore by value to none as well. And if we send a status of not complete and our task status is also not complete, like else, then we have to actually raise an exception and tell them that the task is already marked as complete. And for that, I'm just going to copy and paste it in, because we've been doing this a lot, where we just raise an exception and say task is already marked as not complete. So once we have this done, the next thing we are going to do now is that we're going to have the other clause to our if statement, where we're going to check to see if the status that was given to us is complete. And this is going to be the complete opposite of what we've done above. So if the status that is provided to us is complete, then I have to make sure that the task that I'm going to update the status for that as of now is set to not complete. So we'll do if the task.status is not complete. And if that is the case, then I can set the task.status to complete. Then I can set the task.completed on property equals to, and what is that going to be equal to? Well, it is going to be equal to the time that is on the server right now. And to access it, what we can do is that we can go to the top, and then what we can do is that we can do from Django.utils import time zone. Not time since, sorry, time zone. And then we can go down and we can set the completed on field to timezone.now. And with this, it should be populated automatically to the correct time that was running on the server. And finally, what we'll do is that we'll do task.completed by, so who completed the task, and that is going to be set to the profile that we had extracted earlier. And once this is done, we have successfully implemented the logic for actually executing the completion of a task. But what if we try to set the status of a task as complete, but it is already complete? Well, in that case, again, we have to raise an exception, this time with just a different error saying that the task is already marked as complete. And then what we can do is that we can have another else statement. And this else statement is going to be for our actual if statement. And if we provide any other status that is other than complete or not complete, then we have to raise an exception to actually let the user know that the status that was provided was incorrect. So I'm going to do that by doing raise exception incorrect status provided. Finally, the changes that we've made to our task, we have to do the transaction on the database. So we can do task.save. And then we also have to return a response to the user. And the way I'm going to return a response is that I'm going to create a new serializer instance. So I'm going to do serializer is equals to, and then it is going to be equal to task serializer. And then for the instance of our task serializer, I'm going to set that equal to the task instance that we had retrieved by doing self.getObject. And then for the actual context that our task serializer is going to get, and that context is going to be equal to a key request or a dictionary, which will have a key request and will give the request that we were passed to us to that specific key as its value. And finally, the last thing we are going to do now is that we're going to return. And what are we going to return? Well, we're going to return a response. But before we can return the response, we have to actually import it. So to import the response, we're going to go to the top, and then where we are importing the view sets and mixins, I'm going to import response package. And then we can do return response.response. And then we can actually set the responses data. So that is going to be equal to serializer.data. And then the responses status. And the status in this case is going to be 200 because our request was completed successfully. And then I'm going to go up and I'm going to import the actual status module. And then I'm going to set the status of the house equal to status.http 200 OK. But what I have to do is that I have to import the status package as another name because status is already defined, as you can see. So for that, I'm just going to go to the top and I'm going to do from REST Framework, import status as S. And then Once we've imported it like this, then I can do s.http 200 OK, and that will reference the correct module, and we can do command save. So once this is done, the final thing we have to do is that we have to actually define the logic inside of our exception block. And here it's going to be really simple. All we're going to do is that we're going to return a response.response, and we're going to have a dictionary with a key inside of it, which will be detail. And then what I'm going to return is going to be the string representation of the error that we receive. So that might be task already marked complete, incorrect task status, or some other exception that might be raised. And then finally, the last thing I have to do is that I have to define the actual status for our response, and the status is going to be set to s dot, and then it's going to be http underscore 400 bad request. And then I'm going to do command save. And with this, we have successfully implemented our update task status method. So now if I go to our actual tasks endpoint and then to a specific task, you're going to see that we have this extra action available to us, which is update task status. And now it is time for us to actually test the endpoint. So to test the endpoint, I'm going to open up Postman. Once Postman's load up, what I'm going to do is that I'm going to create a new request by clicking the plus icon here. I'm going to change the method for request to patch. And I'm going to go to our extra action button here for the specific test that I want to update. And I'll copy the URL. I'm going to paste that in here. And then after that, I'm going to go to our body, and I'm going to click on form data, and I'm going to set the status. And right as of now, the actual status of our task is set to not complete. So I'll try to change that to complete and do save. And then I'm going to save it inside of Taskly API. I'm going to create a new folder. I'm going to call it task. And inside of the new folder, create a folder task. And then inside of the new task folder, I'm going to name this request as update task status, and then do save task. And then once this is done, I've defined the body. The last thing I have to do is that I have to define the authorization headers. So I'm going to click on authorization, and I'm going to click on bearer token. And now I need the specific token. For that, I'm going to go to our already existing username authentication request. I'm going to make sure that I authenticate as the correct user who has the ability to actually change the status, which is, in this case is Hussein, because this task belongs to House Gryffindor, and Hussein is also a member of the House Gryffindor. Send the request, get the token, come back to our update task status, change the token to the new token, make sure that the header panel now includes a new authorization header which has bearer and then the value inside of it. And with this, we can now test our functionality out. So I'm going to do send, and you're going to see that we get a status of 200 OK. We get a representation of the instance given back to us where the status is now complete. And if I reload this same exact instance of that task here, you're going to see that the task has been marked as complete here, and the completed on date has been marked correctly, as well as who it was completed by has been marked correctly as well. If I try to mark it as complete again, you're going to see that it says task already marked complete. Furthermore, if I try to now do not complete, that would work as well. And if I try to do not complete again, it would say the task is already marked as not complete. And if I said any other gibberish like ty1, for example, it'll just say incorrect status provided. So with that, we've successfully implemented the functionality for updating the status of our tasks. And with that, thank you for watching, and I'll see you guys in the next one. Thank you. Hello everyone, welcome back. This is going to be the last video in our task app module, and in this video we're just going to be quickly fixing one small issue with one of our serializers for our task app, and after that just looking at the functionality that we've implemented in this module. So with that said, let's get going. So to fix the small issue that we're facing, you can just go to your task serializer, and then you can actually go to the fields property, and then for the read-only fields, make sure that you add the status as a read-only field. And the reason for that is because in our previous video, we had actually implemented a custom action for our task view set, which allowed us to update the task status. And now here inside of our task serializer, we want to change the status field just to a read-only field. Doing command save and then making sure that the server is running, I am just going to reload this specific task instance that is right now up in my browser, and you're going to see that the status field is now going to be removed from the pre-generated form that the Django REST Framework GUI gives us. And now, as you can see, the actual status is just read only. So with that said, now just take a quick look at what we've implemented in this module. So now in this module, we implemented a new API endpoint, which was /API/task, where we had 3 new endpoints: task list, tasks, and attachments. To create a task list, you go to the task list endpoint, and from there you can give a task list the name, a description, which is not required, and then select the host that you want to create the task list for. We implemented the necessary permissions so that you can only create the task list for the host that you are a member of. Moving onwards from that, we also had a tasks endpoint where people could create their own tasks for a task list, and we implemented the necessary logic where a task would only be created for a task list that belonged to a host that you were a part of. And we also tweaked the actual query set functionality that returned the list of tasks to us that were created by our user, just to get a sense of how to define custom queries. Following that, we also had an attachments endpoint, and for our attachment endpoint, we did similar logic to what we did for our task list endpoint, where you can create new attachments for tasks that belong to your house. So with that, hopefully everything works. We have the 3 major parts of our app now done, and now in the next module, we're going to be doing the final finishing touches to API, and by the end of the next module, you would have a fully functional, full complete version of the API that we had started to develop at the start of this course. Thank you for being along with me in this ride, and I'll see you guys in the next module. Hello everyone, welcome back. In this module, we're going to be finalizing all of the functionality that pertains to our API and completing it with all of the functionality that we had intended to include in it at the beginning of this course. And by the end of this module, we should have a version of our API in a production-ready environment being hosted on Heroku. So with that said, let's get going. In this video today, I want to focus on a really powerful feature that Django REST Framework allows us to do, and that is filter capabilities. And the way we're going to implement filtering capabilities in our API is that we're going to be installing a package which is called Django Filter, which is going to give us really powerful Django filtering functionality that can be then integrated with our Django REST Framework API. So let's get going. So to start off, you want to make sure that your virtual environment is activated, and you can do pip install, and from there you can do Django-filter. Once the requirement is downloaded, you can do clear for the terminal just to remove all of the output, and from there you can actually now tell the Django application to actually load this plugin up. So to do that, you can go to the settings.py file, and from there you can go to the installed apps list, and I'm going to add it after our REST Framework Social OAuth 2 package, and I'm going to create a new string, and I'm going to call this Django dash, and it's actually underscore filters. With this, I'm going to do a comma, I'm going to do command save, and then I'm going to just run our server and make sure that we get no errors. So as you can see, our server spun up successfully. So we know that all of the necessary files that were required from the Django filters package have now been imported by Django. So with that said, the first thing we're going to be doing is that we're going to be implementing filtering capability to our task view set. So let's get into it. So what I'm going to do for that is that I'm going to go to our task app, and from there I'm going to click on the viewsets.py file. So the view set that I want to implement filtering functionality on is going to be our task view set. And specifically, the field that I want to filter by is going to be the status of our tasks. So for example, if I go to API/task, and from there to /tasks, so what I want to have here is that I want to have functionality that will allow me to filter the results that I get back on the actual status field. So to start off, what we can do is that we can go to the top, and then we can actually import from the Django filters package the actual filtering backend that we require. So for that, I'm going to do from and then Django filters.rest framework import Django filter backend. So once we have this, the next thing we're going to do is that we're going to go down to our task view set, and we're going to define a new field, and that is going to be called filter backends. And then that is going to be set to an empty list for now. And the first thing that we're going to be adding to this is going to be our Django filter backend. So now this will let the task view set know that it has to use this specific Django filter backend as one of the filtering backends for this view set. And now that we've defined this, the next thing we are going to do is that we're going to define a new field, which is called filter set. And just let me fix my spelling. It's called filter set underscore fields. And this is a property that the Django filter backend expects to be present on our task view set, or any view set that actually implements Django filter backend as one of its filter backends. And then inside of here, we can have a list of strings, which each corresponds to a field for our serializer, which we can filter upon. So what I'd like to do is that I'd like to filter upon the status. With this, I'm going to do a comma, and I'm going to do command save. And now we've implemented filtering functionality inside of our task view set. But now if I reload as of now, you're going to see that we get this filtering functionality. And if I click on this button, you're going to see that now it allows us to filter by the status. So I'm going to click complete for the status and hit submit. And you're going to see that now the results that get returned to us are just the tasks that are complete. And similarly, I can do not complete, and that'll be then the not complete ones. And I can just do all of them by just selecting nothing for the status. And you're going to see that on top here, our URL actually changes. So if I want to get all of the tasks for which the status is complete, I can do a question mark here after our URL. And then I can actually this is the start of our query string. And from there, I can set the status equals to C, which means complete. And if I send a request here, we should get all of the tasks which are just complete. So now that we have this filter capability implemented for our task view set, what I'd like to do is that I'd like to go to our house view set, and I'd like to implement some filtering functionality there as well. And the filtering functionality that I want to actually implement is going to be filtering houses by their members. So to do that, I'm going to go to our house app, and from there, I'm going to click on view sets. And then similar to what we did for task app, I'm firstly going to import the necessary Django filter backend. So we have that. And once this is done, the next thing I'm going to do now is that I am going to go down to our house view set. I'm going to define the filter backends list, and then I'm going to set it to Django filter backend to start off. And just don't forget the ending comma. I just like to add it as a habit. Once that is done, then I'm going to define the filter set field. So filter set fields, and then I'm going to set that equal to members. And then I'm going to do the trailing comma, do command save. And now if we go to our API / house, and then from there / houses endpoint, you're going to see that we should have this filtering button that pops up. And if we click on this, we should now have the ability to filter by members, and we can filter by multiple members as well, or just a single one. So what I'm going to do is that I'm going to filter by member Hussein. So all the houses for which Hussein is a member of, click submit. You're going to see that Gryffindor shows up. I can also combine them. So I can do Hussein and Hermione. And the way I do this is that I hold command on Mac. And then from there, I click Hussein and Hermione Granger. For Windows, this is going to be control most probably. And then I can do submit. And this way it should link it up. And as you can see at the top, it just like links it up by saying the query string members equals to 1 and members equal to 4. So with this, now we have also filtering functionality for our house view set implemented. So with this, I'm gonna end this video here. We've successfully implemented filtering functionality with our house endpoint as well. And now I'm gonna see you guys in the next video. We're going to be actually implementing search functionality to our view sets. Thank you for watching. Hello everyone, welcome back. In this video, we're going to be implementing search functionality inside of our API, and specifically for the house view set and our task view set, which will allow us to actually do text-based searching on specific fields that we specify to be searched, and then have a list of results returned to us which contain those specific keywords. So with that said, let's get going. So to start off, what I'd like you to do is that I'd like you to firstly go back to the viewsets.py file for our task app, and then go to the top where you're importing viewsets mixins response from the REST framework package. And from there, I want you to import filters as well. the filters package from REST Framework. Once you've imported that, the next thing I'd like you to do is that I'd like you to go back to your task view set and to the filter backends list, and then I'm going to add a new value here, and the new filter backend that we're going to be adding is called filters and then .search filter. So this is a filter that comes out of the box provided to us by Django REST Framework, and we do not need a third-party package for it, which allows us to do text-based search on fields that we specify for a specific model. So I'm going to do command save and make sure that we do not get an error in our API reloads. And now what I'm going to do is that I'm going to define a new field, which is going to be called search_fields, which is a field that is expected by the filters.search filter class to be present for our task view set. And inside of here, similar to what we did for our filter set fields, we're going to define the fields for which we want to enable searching. So I'm going to specify name and status as the two fields. And all of this information is also available on the Django REST Framework's actual home website, so you can go and read about search in more detail. And it's a really powerful feature that I would highly recommend you to look into. So with this, you can do command save. And now search functionality should also be implemented in our view set. So if I go back to our actual task endpoint, so that is going to be API/tasks/tasks. And you're going to see that we still have this one button, which is filters, but if you click on it, we should have this search functionality. So whatever I type here, whatever text I type here, it's going to try to match that text that I specify to the name and status field and try to, or not status, sorry, description field. And then we can do command save and then reload the app to make sure that our changes are now present. So for the search, what I'm going to do is I'm going to specify that I want the task which says buy and then orang, for example, just this much. And we can click on search, and you're going to see that we get results returned to us where either the name or the description contains at least this word. So as you can see, buy orange contains the buy orange keyword that we wanted. So now that this is done, the next thing I'm going to do now is that I'm going to show you that if we do orange, if we just do buy and we do search, you're going to see that we get two results back, which is like buy here and buy bananas. So with that, now we've implemented search functionality inside of our task list, task view set as well. So now what I'm going to do is that I'm going to go to our house view set and I'm going to implement the same search functionality for our house view set, but on some different fields. So to do this, what I'm going to do is that similar to how we imported the filters package from the REST framework, I'm going to import it here as well. So I'm going to do from REST framework, import filters. Then I'm going to go down to where we have filter backends and I'm going to add filters dot, and then I think it's called search filter as a new filter backend. And then from there, I'm going to add a new property, and the property is going to be called search and then underscore fields. And then we can set that equal to a list of fields that we want the search to work on. So I want to search by the name and then also the description of the house. And then I can do command save. Hopefully our API loads up without any errors. And now if I go to /API/house/houses, you're going to see that we now have search functionality, and I can type in, for example, Griff and search, and you're going to see that Gryffindor pops up. What if I want to actually match word for word a specific keyword and make sure that the exact word is present, not like just a subset of it inside of any of the fields that we specify for our search fields? Well, to do that, what you do is that you just add an equal sign before whatever field that you want to do an exact match for. So if I do this, do command save, reload the endpoint, and now if I do a search for Griff, you're going to see nothing changes. And the reason for that is because our description contains Gryffindor as well. So what I'm going to do is that I'm going to change this, and to fix this problem for now, I'll set the description to equal as well. So exact match, which we do not want for now, but just to show you how this would work. And if I reload our search now, you're going to see that we got no results back. And the reason for that is because it wasn't able to do an exact match for the name and description to just be this keyword that we provided. I can change the description back to the way we were, where we just want the keyword that we want to search for just as a part of the description. Do command save and reload. while having the search query string here, and you're going to see that now we get the results back. So now we've implemented search functionality for our house view set as well. So with this done, I'm going to end this video here, and I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be implementing ordering functionality inside of our API, which will allow us to actually order results by a specified field in an ascending or descending fashion. So let's get going and let's see how to do that. So to start off, what I'd like you to do is make sure that you've had the filters package imported from REST Framework, and then you have to go to the filter backends field that you've defined for the house view set class, and we're going to be adding a new filter, and the filter that we're going to be adding is called filter dot, and then from there it's called ordering filter. And then once we've defined this, the next thing we're going to do is that we're going to define a new field, which I'll call ordering underscore fields, which is going to be a list of fields for which we want ordering functionality. And what would I like to order the results that I get back by, and that is going to be points. So if I want to get the list of all of the houses inside of our API relative to their points, so the houses with the highest points or lowest points come up first, and then that's how it continues. And apart from points, I'd also like to do the completed task count. So that is going to be completed underscore tasks underscore count. Similar to this, I'm also going to do the not completed task count. So not completed underscore tasks underscore count. And with this, I'm going to add a comma, do Alt-Shift-F, and Command save. So now the ordering functionality should be implemented. If I reload, you're going to see that now we can click on filters, and we should have like this new table that appears inside of the filters pop-up, which allows us to order by points, by completed task counts, and not completed task counts. So I'm going to order by points ascending, and you're going to see that I have to actually remove the search key, because it's also searching. And you're going to see that now we have an ascending order, where the house with the lowest points come first, and then house with the highest points come second. And if I just switch this to descending, you're going to see that now the house with highest points come first, and then house with lowest points, and this would just keep continuing. So now with this implemented, the next thing I'm going to do is that I'm going to be creating a new house. So what I'm going to do is that I'm going to go to our Harry Potter fandom, and the house that I'm going to search for is called Hufflepuff. And I'm just going to click on Harry Potter fandom. From there, I'm just going to copy some data to actually create the house to Hufflepuff. For the image, I'll just save this image to our desktop, and then use this image as the image for the house. And then finally, for the description, what I'm going to do is that I'm going to go here, I'm going to copy the first paragraph, I'm going to put it in for the description. I'm just going to remove the references that you can see here. And that should be all good. And I'm going to do post. And now our new house should be created. So now if I go to houses, you're going to see that we have 3 new houses: so Hufflepuff, Gryffindor, and Slytherin. So now that we have this done, we've implementing ordering functionality as well. We can order stuff by all of the fields that we've specified for the ordering field. So we can do like completed task count and all of that stuff. So with this, I'm going to end this video here. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be integrating Google Cloud Storage with our Django API, which will allow us the ability to actually save media files to Google Cloud and serve them from there. The reason we're doing this is because our production-ready environment, which is going to be hosted on Heroku, does not provide us the ability to host media files. Even though we can still try to upload our media files, and they essentially would look like are being saved to Heroku, over a long enough period of time, we'll come to realize that those files are automatically deleted because the storage solution that is given to us by Heroku is not persistent storage. So with that said, let's get into it and let's see how to integrate Google Cloud Storage with our Django API. So to get started, what I'd like you to do is that I'd like you to go to cloud.google.com. So once you click on console, you're going to be presented with this UI. Here, what you're going to do is that you're going to click on this top button here, which if you don't have any projects, is going to say add project. And from there, you're going to click on new project, create a new project, and then select it. Once you have the project selected, the indication for that is the top button is going to change to whatever the name of your project is. Once that is done, make sure that you activate your free trial, which is going to give you $300 in credits that can be used on Google Cloud Storage. Since Google Cloud Storage is a paid service, you need to activate this trial. And to activate the trial, you're also going to require either a debit or a credit card, depending upon which country your Google account is going to be created in. So with that done, trial activated, you can click on the navigation menu, and from there you can click on storage. And once you have this done, you're going to see that you are presented with this kind of a UI where you have an option to create a bucket. This bucket is what we require to actually save our media files to, and you can consider this bucket to be an actual directory inside of Google Cloud where we can put all of our media files that are uploaded to our API. So to do this, what you're going to do is that you're going to click on create a bucket, and then you're going to name your bucket. What I'm going to do is that I'm going to call this main_bucket, or instead of doing main bucket, I'm just going to do prod bucket, let's just say, so production bucket, and click on continue, and it says that it's been taken. So what I'm going to do is that I'm going to name it prod_taskly_API_bucket, and then I'm going to click on continue. From there, you can select the region that you want. So as you can see, the description for the location gives you what kind of a performance you can expect. What I would recommend, if you have a API that's going to be highly content focused and the media files that you upload are going to be accessed quite frequently, then select multi-region. But keep in mind that if you select multi-region or dual region, your costs are going to be higher than if you just had selected region. And from there, you can select for the location that you want. I just going to select US, click on continue. From there, for default storage class, just click on standard. Continue. For the access control, you can say fine grained, and then for advanced settings, just make sure that you have Google managed key selected and there's nothing else you have to do, and click on create. Now we're going to wait for a bucket to be created, and once it's created, you should be back at this page where you are actually inside of your bucket. But if you click back, you're going to be here. So just select your bucket, and now you're going to be inside of here where you can see the name of your bucket. So now that we have the name of our bucket, the next thing that we have to do is that we have to create an actual user that is going to be able to perform actions on this specific bucket and actually give our Django API the ability to then push stuff to this bucket. So to do that, what we're going to do is that we're going to click on navigation menu, and from there we're going to click on IAM and admin. Once you've clicked here, the next thing that we're going to do is that we're going to click on service accounts. And once you've clicked on service accounts, you're going to click on create service account. Once you've done this, what you're going to say is that you're going to name your service account. What I'm going to name my service account is going to be Google Cloud Storage, so GCS_service_account for the Taskly app. So I'm going to say GC service account Taskly app, or to follow the naming convention, I'll just call it API. And then I'm going to click on create. Once we have this, we have to grant this service access to projects. So what we're going to do is that we're going to grant specific roles to our service account for the different features that it can have access to inside of Google Cloud. Since this account is going to be solely responsible for interacting with one of the products that Google Cloud Platform gives us, that is Google Cloud Storage, we're going to click on select a role. So now what I'd like you to do once you click on select a role is that I want you to type in GCS. And from there, what I want you to do is that I want you to click on storage object admin, which says full control of GCS objects. So this service account is going to have the ability to actually have full control over objects inside of our Google Cloud Storage. And objects just refers to individual files that are uploaded there. So we do not have, for this service account, the ability to have full control over Google Cloud Storage where it can create new buckets and stuff like that, but it has full control over objects that are actually saved inside of those buckets. With this, what we can do is that we can click on continue and we can click on done. And now we should have a service account. So once we have our service account, the next thing we're going to do is that we're going to click on actions, and from there we're going to click on create key for it. And what we're going to do is that we're going to click JSON, and then we're going to create, and this is going to create the key and actually download it to your computer. What this key would allow us to do is that this key is going to save some data that is then going to be used by our Django API to actually authenticate itself with Google Cloud, and then have the ability to actually upload stuff to Google Cloud Storage. So now all of the setup that was required for the Google Cloud site is done. And what I'd like you to do is just click on navigation, go back to storage, and then select the bucket that you had created and just leave it here. Now what we have to do is that we have to do the settings on our Django API side. So to get started, what we're going to be doing is that we're going to be installing a plugin, which is going to allow us to actually have this functionality of saving files to Google Cloud, and that is known as Django Storages. So to start off, you can install this plugin by doing pip install Django-storages. And once the plugin is installed, you have to also tell Django to actually load it up. So you're going to click on the Taskly app. From there, you're going to go to settings.py file. And then in your settings.py file, we're now going to define some variables which are going to indicate to Django as to which file storage system it has to use. So you're going to scroll down and you're going to create a new section, which is going to replace our media root and media URL section. But for now, we'll keep these. And I'm just going to comment these out so you guys have for reference how local media storage works. Once this is commented, the first thing that we're going to define is known as default underscore file underscore storage. And we're going to set this to storages dot backends dot gcloud dot google cloud storage. And you can read more about how to actually implement all of these different storage endpoints by actually clicking on whatever hyperlink that corresponds to your storage solution. In our case, that's Google Cloud Storage, so I'll click on that. Once we have the default file storage defined, which is going to be storages.backends.gcloud.google cloud storage, the next thing we have to do is that we have to define our GS bucket name. So this GS underscore bucket underscore name is going to be the name of the bucket where we actually want to save our files. And this is the bucket that we had created in the previous steps. So I'm going to go back to Google Cloud. I'm going to copy these bucket names and I'm going to paste it in for our GS bucket name. So once we have our GS bucket name defined, the next property that I'd like to define is going to be GS underscore file underscore overwrite property. And I'm going to set this to true. And what this means is that if we upload a file which has the same name as a file that already exists in our bucket at the same location, then we're just going to overwrite that file and we're going to replace it with the file that was just uploaded. Finally, we have to now tell the plugin where it can find the credentials to actually authenticate itself with Google Cloud Storage. And for that, we can define the GS underscore credentials variable. But before we can define the GS credentials, you have to install a package which is known as pip install and then Google OAuth. And for me, it was already installed, but you have to install that. And then after that, also don't forget to pip install Google as well. And once this is done, you should be all good to go. So once we have this, we can go to the top and we can actually import from google.auth2 import and then service account. Once we have this, we can go back to our GS credentials and we can now actually create a service account from the file that we had downloaded in the previous steps from Google Cloud when we created a key for a service account. So I'm going to do service account dot credentials dot, and then from there we're going to do from service account file. And once we've done this, the next thing we're going to do is that we're going to actually define the name of the file which has our actual account credentials. So the first thing I'm going to do is that I'm going to actually move the file that we are just downloaded into my source folder and make sure that it's here. And I'm going to blur out all of the settings here, but it should have a bunch of settings. And then we're going to go back and we're just going to copy the name of the file and we'll just input it here for the credentials.from service account file name and do command save. So now we have the credentials set up as well. And this was all of the settings that had to be done for our actual Django API integration with Google Cloud. So now by default, Django is going to use Google Cloud Storage as its default file storage solution. So we can do clear, and now we can actually try to run our API. So I'm going to do /manage.py, run server, and hopefully the server should spin up as it did. The next thing I'm going to do is that I'm going to go to API/house/houses endpoint, and it says that could not load Google Cloud Storage binding. Okay, so fix the error that had just occurred. What you can do is that you can exit the API, and then once you've exited the development server, you can do pip install and then do Django-storages, then do a square bracket open, and then type inside of it Google, and then do an closing square bracket, and then do enter. And with this, it should install a bunch of other plugins that are required by Django storages to interact with the Google Cloud platform. And then with this, you should be good. And now if you do /manage.py run server, the server should actually run as intended. And if I reload the endpoint, now it works. And if you are confused about the actual installation command for installing the packages, it can be found here on the actual Django storages package website, which I'm going to link in the course resources section. So now that our actual storage solution is completely working, we have to test it out. So to test it out, what I'm going to do is that I'm going to create a new house, and the house that I'm going to be creating is going to be Ravenclaw. So I'm going to save the image of Ravenclaw as Ravenclaw crest, and then save that to my desktop. Then I'm going to go back to our house list. I'm going to choose the image for Ravenclaw. Then I'm going to name our house, and the house name in this case is going to be Raven and then Claw. And once this is done, I'm going to input a description, and the description, I'm just going to copy it from here and go back, paste it in, and then remove any of the references that we might have. And this looks about good, and I'm going to do post. And once the post is done, you're going to see that we get this new HTTP 201 response. But if you look closely, you're going to see that for our image, the URL has now been changed to a URL that has storage.googleapis.com inside of it. And if I click on it, you're going to see that we get the image that we have just uploaded, and it actually being stored at Google Cloud Storage. To further solidify this, we can actually go to our bucket, and then we can click on refresh. And you're going to see that this new folder appears, media, which then has houses inside of it, which then has the house ID, followed by images, followed by the actual image of the house. And this path is actually derived from the actual custom path that we had defined inside of our model class for the house model. And now we can see that we have successfully linked Google Cloud Storage to our Django API. So with this, I'm going to end this video here, and I'm going to see you guys in the next one. But before we end this video, the last step that we can do is that we can actually delete the media folder because we don't need it anymore. And for the other houses that had already been created, for which the media files had been saved in this folder, you'll have to go and re-update their image files and re-upload them. And this time when you upload the files, they're going to be saved in Google Cloud. So with this, I'm going to end this video here. Because it's been a fairly long one. I'm going to see you guys in the next one. Thank you. Hello everyone, welcome back. In this video, we're going to be implementing background task functionality inside of our Django application, which is going to allow us to periodically run pieces of code which can perform different functions inside of our application. Specifically, we're going to be defining a function which is going to be run periodically and is going to be responsible for calculating different statistics for all of the houses that we had inside of our application. And primarily its focus is going to be on calculating the completed task counts and not completed task counts present for each of the house that we have. We could have gone an easier way of actually implementing this logic by just making sure that every time a task status was updated, updating the amount of completed task or not completed task counts for the corresponding house that the task was linked to. But the reason I decided to go this approach was to actually show you how background tasks could be implemented in a Django application and how they can be then run to do periodic tasks that you might want to have done for your Django application, such as calculating statistics, or maybe if you had an app where you would have user subscriptions, going over user subscriptions and seeing if users have paid, and if not paid, then like removing their subscriptions and stuff like that. So with that said, let's get into it and let's see how to actually implement this. So to start off, the first thing that we're going to do is that we're going to be using a package which is going to actually help us run background tasks. So to get started, the first thing we're going to be doing is that we're going to be installing a package which is called Django Background Tasks, which is going to allow us the functionality to actually create these tasks and then run them periodically. So to start off, what you're going to do is that you're going to do pip install and then install the package by doing Django-background and from there -tasks and making sure that the package is installed. Once the package is installed, we have to let Django know that it has to actually use it. And for that, we're going to go to our settings.py file. And once we're at our settings.py file, you can go up to where you have the installed apps. And then after Django filters, I'm actually going to add this new package that we just downloaded for background task. And you install it by adding background_task to your installed apps. And then don't forget the command, we can do command save. So once this is done, you can do /manage.py run server, and hopefully it should spin up, and an indication whether the package was successfully loaded would be that you get an error for unapplied migrations. So we can exit and quickly apply these migrations by doing manage.py and then migrate. And this should apply the migrations, and now we should be good. So we can do /manage.py run server, and we should now be all good to go. So once this is done, the next thing that we have to do is that we have to create an actual app that is going to encompass all of the logic for our background jobs. So to do this, what I'm going to do is that I'm going to do /manage.py, then start app, and then I'm going to name my app background_jobs. So instead of doing background task, which was the name of our actual package, I'll just make it background jobs and then enter. And hopefully a new folder should appear for the new app that we have created called background jobs. So once this is done, I have to now let Django know that it has to also use this app. So I'm going to go to our installed apps list, and then I'm going to install this new app by doing background_jobs by adding background jobs to our installed apps list and then doing command save and then making sure that the server runs. So everything looks good, and now we're actually ready to implement the functionality for the tasks. So to get started, what we're going to be doing is that we're going to be creating a new file inside of our background jobs app, and I'm going to call this tasks.py. Once this is done, we are going to do the necessary imports that are required. The first is going to be from background task. So the package that we had installed from background tasks, import the background decorator. And following that, we'll also have from background tasks.tasks import task as BT. And the reason we can't import just task is because remember that we have a model inside of our actual Django application, which is called task. So hence, to make a clear differentiation between that task model and the task model that is provided to us by Django background task, I've renamed it to BT. So once this is done, the next thing we're going to do is that we're going to import the models that we require ourselves, which is the house model and also the task model. So from task.models import complete. So from task.models, we just need the complete variable, and then we can do command save. Okay, so now that we have all of the necessary imports done, the next thing that we're going to do is that we're going to be defining the function, which is going to run periodically. And I'm going to name our function calculate_house_stats. And then we can, for now, just set the function definition to pass. And before we can actually define what the function is going to do, I'm going to decorate the function with our background decorator. And then I'm going to schedule it to 10 minutes. And what the schedule does is that it tells the package that when we call the specific command, which I'm going to show later on this video, how much time of that command being called should this specific function be run, and I've set that to 10 seconds. Once that is done, the next thing that we can do now is that we can actually define what our actual house statistic function is going to do. So what we have to do is that we have to go through all our houses and then calculate the completed task and not completed task count for it. So we can loop through all of those by doing for house in house.objects.all. Then for each of the house objects, we can set the underscore total task count to 0. We can set the completed underscore tasks underscore count to 0 as well. And then finally, what we can do, total task counts to 0, completed task counts to 0. And then the last thing that we're going to do is that we're going to get all of the task lists that correspond to this specific house by doing house task list equals to the house.lists.all. So now that we have all of the task lists available to us for the house, what we're going to do is that we're going to loop through all of them individually. For that, I can do for task list in, and I'm going to do lowercase list in house task list. I am going to increment the total tasks count by the amount of tasks that this task list has by doing task list.tasks.count. And this would return the count of tasks that are in this task list. Once we have this, I'm going to set the completed task count equals to plus equals, and then we're going to perform a query on our database by doing the task list.tasks.filter, and we're going to filter through the tasks where the status of that task is equals to complete, and this complete was actually imported from task.models. And then we're going to get the count of the query that gets returned to us. So for the task list tasks, we're going to filter through all of the tasks for and where the field for these task status is complete, and then we're going to have a query returned to us, and then we're going to get that count of the query by doing the count function. Once this is done, we can exit out our for loop, and then once we've looped through all of the task lists, we can do house.completed underscore tasks underscore count equals to completed task count. And then what we can do is that for our house dot and then not completed underscore tasks underscore count, we can just take the total tasks and we can subtract the completed task count from it, and then we should have not completed task count, and I just misspelled count here. And finally, we have to perform the transaction on the database, so we can do house.save, do command save, and we are all good to go. So now that this function is defined, the next thing that we have to do is that we have to run our server. So I'm going to do $manage.py run server. And we can go to our actual admin panel. And once we're at the admin panel, you're going to see that we have now this new section available, which is called background task, where we have completed tasks and tasks. But if I click on tasks right now, you're going to see nothing shows up. And the reason for that is because we've not yet run the actual command, which is going to actually register our task and then run them. So let's take a look at how to do that. So the first thing that we have to do is that we have to go to our apps.py file, and then we have to define the ready function for our background jobs config class. And then here, what I'm going to do is that once the inside of the ready function, I'm going to do import background jobs.tasks and then do command save. And once this is done, I'm going to go to our init__.py file for our background jobs app, and I'm going to do default_app_config equals to our background_jobs.apps. And then the name of the class, which is going to be background jobs config, and I'll paste it here. And this is going to point towards the default app config, which is background_jobs, the name of our app, the .apps file, and then background jobs config class. And now the setup side should be done. But still, if you reload, you're going to see that nothing changes. And that is because we still have to run the management command, which is actually going to run our tasks. So for that, what we're going to do is that we're going to be running a command, which is known as $manage.py, and then there's this thing called process_tasks, and this command is actually added by the module that we just installed, which is the Django background tasks module. And if I click enter, you're going to see that this is a long running process. But if I go back to our select tasks to change, you're going to see that if I click on completed tasks, and my server needs to be running, so I'm going to open up another shell terminal. I'm going to make sure that our virtual environment is activated. And then once our virtual environment is activated, I am going to actually run the app by doing /manage.py run server. And then if I reload and go to our admin panel and click on completed tasks, you're going to see that nothing happens. And that is because even though we call the process task command, the process task command doesn't even have any registered tasks inside of our Django admin application to run. So to actually register these tasks every time, what we can do is every time the API runs up or spins up, we can actually create these new tasks, and then they can be saved. And then once they are saved inside of our database, then we can call process task, and that is going to run them. So now how do we create the actual task? Well, it's fairly simple. You can go to your task.py file, and then inside of here, every time this file is imported, what we can do is that we can just run some piece of code, and the piece of code is just going to be called calculate house stats. And then what we're going to do is that we're going to pass in a property which is called repeat, which means how often should this function be repeated. And what I'm going to do is I'm going to do bt.daily. So remembering bt is the task model that is imported from our actual background task.task module. And now that we've defined the frequency of repeated, then we can define a verbose name. So verbose name just means how the name of this task is going to be saved in the database, and I'm going to just save the verbose name to be exactly the same as the name of our function. So I'm just going to copy the name of the function and paste it in here, excluding the brackets. And then finally we'll have a priority. So what's the priority for this function? And I'm going to set that to 0, and the lower the priority, the higher the actual priority is going to be. And if you have a bunch of tasks, then the tasks with the lower priority are going to be learned first, and then higher priority are going to be run later on. So the lower the number, the higher the priority, essentially. Now we can do command save, and we can actually run our actual app. And if we run our app, you're going to see that if we reload our Django admin panel, that we have these new tasks that have been created. But now the problem is that every time we restart our API, we're going to have just these duplicate tasks being created and created and created. And we do not want that. We just want one background task job for our calculate house stats. We don't want three jobs that perform the same action. And for that, what we can do is that we can have an if statement where we can check to see if the job already exists in our database. And if it doesn't, then we can create it. For that, what I'm going to do is I'm going to do if not, and then I'm going to do bt.tasks, bt.objects.filter, and we're going to be filtering by the verbose name, and where the verbose name is going to be equal to calculate house stats. And then if this exists. So if there exists no task with the verbose name of calculate house stats, then that means that we have to actually create a new task. Else we don't have to create it. It's already been created in the database. We don't have to do anything. So we can do command save now, and we can go back and run our server. And you're going to see that the task count doesn't increase, but I'm just going to delete these tasks by doing delete. And now I'm going to exit our server and I'm going to run it. And fingers crossed, we're going to see that we just get one representation for our calculate house stats function actually saved. And as you can see, we have this new task that's been now registered inside of API and is ready to run, as you can see. So now once we have the task registered, it's now in the API. How do we run it? Well, to run it, now we're actually going to be using the /manage.py process task command, which is going to be a long-standing process that is going to keep on running. It's never going to end, and it's going to periodically ping our database, see if there are any tasks that need to be run, and then run them, and then go back into a sleep mode and just keep on doing this. So it'll just keep on running. And now if I reload, you're going to see that we have this task still here. But if you go to our completed task, you're going to see that we have this completed task, which says that it was run at December 8th. And it didn't have any errors, and it was attempted once, and it completed successfully. And then once the task has been completed successfully, the background task is automatically going to create a new task, which is going to be run the next day, and actually save it inside of the tasks model for the Django background tasks package. So now this task that we have, calculate house stats, now this is going to be run tomorrow when manage.py process tasks is called. And to see that our actual function actually worked, if you go back to our house list for our API route, you're going to see that for our house, now we have not completed task count to 1. For here, we have completed task count to 1 and not completed task count to 1. And for here, we have 0, 0, and same here as well. So you can actually see that our function actually ran. So with this, we've successfully implemented background task functionality into our Django API. So with this, we're going to end this video here. I'm going to see you guys in the next one. Thank you. Hello, everyone. Welcome back. In this video, we're going to be learning how to connect our Django application to a PostgreSQL database. Our PostgreSQL database is going to be hosted on Heroku.com. So with that said, let's get into it. This is going to be one of the first steps that we're going to be doing to actually deploy our API into a production-ready environment. And the first step in this process is going to be linking our API to a production-grade database. So with that said, let's get into it. So just as a side note, Heroku is totally free. So any of the steps that I'm going to be performing here do not require you to enter any kind of financial information. So with that said, let's get going. So to start off, what I'd like you to do is that I'd like you to go to Heroku.com, register, and then log in. Once you're logged in, you're going to be presented with this start screen where you're going to have the option to create a new app. If you have a bunch of apps already existing, then there might be an option somewhere which says create new app. So you're going to click on create new app. And once you've clicked on it, the next thing you're going to do is that you're going to give your app a name. So what I'm going to do is that I'm going to name my app Taskly App Django API. And hopefully that name isn't taken. As you can see, it's available. And then I'm going to select the region where I want my app to be hosted. I'm going to select the United States. And then from there, I'm going to click on create app. This is going to take some time. And once that is done, you're going to see that the app is created. So the next thing that we're going to do now is that we're going to, for now, not deploy anything to our actual application, but we're going to be adding an add-on to our actual app, which is going to be the PostgreSQL database. So add-ons in Heroku just mean additional features that you would like your app to have access to. In our case, an additional feature that we want from Heroku, apart from it serving our Django application, is a database where we can save the data that gets transmitted to our API. And for that, what we can do is that we can click on overview once we're inside of our application, and then we can click on configure add-ons. And once we're there, what we can do is that we can go to the add-ons search bar, and here we can actually type in what add-on we need. So in our case, the add-on we need is called Postgres, and it's called Heroku Postgres. So just type in Post and you should see Heroku Postgres pops up. So I'm going to click on it, and you're going to see that a pop-up is going to appear, which is going to ask me to select a plan. What I'm going to do is I'm going to select just the basic AllGoodDev plan, which is free. And if you want a premium plan, you can go through, read about what all of the other plans offer. But for the purposes of this course and the way the actual implementation works, regardless of whatever plan you take, everything's going to be the same from this point onward. So I'm going to select AllGoodDev, and then I'm going to click on submit order form. And once this is done, we can click on our overview tab again, and you're going to see that a new database has been provisioned for us. So now that we have the new database and it's been provisioned for us, what we can do is that we can actually click on this. And I'm talking about clicking on this hyperlink URL, and it's going to take us to this other website where we can see information for our database. Keep in mind that since this is a free database, the row count for this database is going to be limited to 10,000 rows. If you exceed that limit, then any new data that you try to add is not going to be possible. However, if you upgrade to a paid plan, then this row limit is going to be removed. So with this done, what we're going to do is that we're going to click on settings, and from there we are going to click on view credentials for our database. And I'm just going to remove this app after we're done, so these credentials are not going to work. But once we have these credentials in front of us, the Heroku side of the things are done, and now we're going to go to our Django application and actually fix stuff there. So to start off, what we're going to be doing is that we're going to be going to our source folder. And from there, what we're going to do is that we're going to be going to our settings.py file. And inside of our settings.py file, we're going to be browsing down to the databases list. And here we're going to be replacing the default definition for the database that we're using. So instead of using the default database, which Django gives us, which is a SQLite database, what we're going to be doing is that we're going to be using a Postgres database. And to do that, the first thing that we need to do is that we have to replace the definition here for the default database. So to get started, first we're going to replace the engine. The engine is now going to change from the actual SQLite database, and now we're going to do Django .db backends and then from there we're going to do Postgres SQL underscore and then psycho pg2. So django.db.backends.postgres SQL underscore psycho pg2. And this is going to let Django know which type of database do we expect it to be interacting with. Once we have this, the next thing that we need to do is that we have to define the name for our database. So the name for our database we can get from our actual Heroku database credentials. And as you can see, the name for my database is this. So I'm going to copy it, I'm going to paste it in. Once this is done, the next thing I'm going to do is that I'm going to be defining the user for our database. So that's going to be user key. And then the user for our database is going to be this user. Following that, what we have to do is that we have to define the password as well. So password, and then that is going to be equal to this password. And then we're going to paste it in. Once we have the password in, the next thing we're going to be doing is that we're going to be finding the host. So the host is going to be the server where our database is located, and that is going to be this. Since Heroku runs on the AWS architecture, that's why we have a host that points to an AWS. And finally, once we have this, the last thing that we're going to be doing is that we're going to be defining the port. And the port in our case is going to be 5432. So once this is done, we are all set with the actual implementation part of actually defining the settings inside of our Django application. But for now, if I run the app, and I'm just going to show you, I do run server, you're going to see that our app is just going to crash. I mean, I'll give it some time to actually load up for the first time. And we have an error, and the error is because I've added these two double S's here, so you have to remove one of the S here. It's like this, and then if I do command save, you're going to see that our app is going to reload, but it's still going to crash because it says that it has an error loading the psychopg2 module, so we have to install that. So to do that, it's fairly easy. All we have to do is that we have to install a Django package, which is going to allow us the ability to actually use psychopg2, and to do that we'll do pip and then install, and then we're going to do psychopg2, and then we can click enter, and hopefully this package is installed. And it's going to take some time to actually build the VL for psychopg2, so I'm going to wait for this to complete, and once it's completed, I'm going to resume this video. Okay, so once that the psychopg2 module is installed, we can do clear again, and this time we can try to run our server by doing manage.py run server, and hopefully our server should actually spin up. And now once we restart our server, you're going to see that it gives us an error saying that background tasks, it is unable to find any of them. And the reason for this is because we haven't applied the necessary migrations for background tasks. So to fix this, and this is only going to be a problem if you implemented background tasks, is that you're going to go to the background jobs app just for now. And from there, you're going to click on the actual tasks.py file. And once you are at the task.py file, what you're going to do is that you're going to comment out all of the stuff that's inside of here. So once everything is commented, you can do command save, and you can try to run the server again. And hopefully this time the server should spin up without an issue. So just waiting for the server to load up, and it's performing checks. And as you can see, the server loaded up and it's saying that you have 37 unapplied migrations. So this means that our Django API can now actually talk with the actual PostgreSQL database, and it's not giving us an error, and it's working. So now all we have to do is that we have to apply the migrations. The way you apply the migrations is the same. You do /manage.py, and then you do first make migrations, just to make sure that there are no migrations that have not been made yet. And once that is done, then you can do manage.py, and then you can click on migrate. And this time the migrations are going to take some time. So I'm going to pause this video here, and once the migrations are all applied, then I'm going to continue. Okay, so as you can see, the migrations are all applied, and now if I do /manage.py run server, and I click enter, you're going to see that our server is going to spin up. And now if I go to the actual endpoint, you're going to see that we can actually see all of the API route, but we don't have any users. So that's all good. To test that our implementation works, I'm just going to go to the admin panel. Oh, and I have to add a /, and with this, I'm going to realize that I don't have a user right now to log in. And the reason for that is because we've linked our API to a new database, hence we've lost all of the previous data that existed inside of our db.sqlite3 database. So I have to create a new user. To create the new super user for our actual Django application, I'm going to do manage.py create super user, and then I'm going to wait for Django to actually prompt me to give the username. I'm going to leave the username as Hussein. For the email address, I'll just do support@perneur.com. Password, just the dummy password that we've been using. Test123. And once the super user is created, we can again start by running our server. And then once the server is up, we can just send a request by doing Hussein as the username, and then password test123. And you can see that we can log in to the Django admin panel. So now the last thing we're going to be doing is that we're going to be firstly deleting our db SQLite3 file. So I'm just going to delete it. And once that is done, then I'm going to go to our task.py file inside of our background jobs app, and I'm going to uncomment all of the code that we had there. And then with this, what I'm going to do is that I'm going to exit out our API, and I'm going to do manage.py make migrations to now make the migrations necessary for our actual background tasks. And then just go through this as a good measure to make sure that we didn't miss anything. Oh, and I had to do /manage.py migrate. I misspelled it. Hopefully it all goes through, and it's good if it says now migrations to apply as well. But now if I do run server, the new job should hopefully load up into our server. And if I go back to our admin panel and then I click on actual tasks, you're going to see that our task now appears, which is calculate house stats. So with this, we've successfully linked up our Django API to a PostgreSQL database that's being hosted on Heroku, and specifically on an Amazon AWS server. So with that, I'm going to end this video here, and I'm going to see you guys in the next video where we're going to be working towards actually pushing our API to Heroku. Thank you. Hello everyone, welcome back. In this video, we're going to be starting off the process of actually setting up an API to be deployed to Heroku. And since this is a lengthy process, what I'm going to be doing is that I'm going to be dividing this process into multiple different videos. So with that said, let's get going and let's see how to deploy our API to Heroku. So to get started, the first thing that we're going to be doing is that we are going to be initializing Git inside of our source folder. And the reason we need to initialize Git is because the deployment functionality that Heroku uses actually requires your project to have Git integrated with it. And for those of you who do not know what Git is just a version control system. And I'm not going to go too much into what Git is and how Git works because this is not a Git course, but I'm just going to show you the necessary steps that are required to actually get the API up onto Heroku. So the first thing that we're going to be doing is that we're going to be making sure that Git is installed inside of our computer. Once Git is installed, the next thing that I'd like you to do is that I'd like you to navigate using the terminal or the command prompt in Windows to the actual source folder. So make sure it's the source folder and not the actual folder that contains the source folder as well as the virtual environment folder. I want you to be inside of the source folder because we only require the stuff that inside of the source folder to be actually uploaded onto Heroku. So with that said, what we're going to be doing is that once we're inside of the source folder, and to check what folder you're in, you can do pwd, and it'll show you as to what the path is. And from there, you can do git init. As soon as you do this, you're going to see that it's going to say that it's initialized empty Git repository. And that means that you've now integrated Git inside of your app. So now that we have integrated Git, we have to tell Git as to what files it needs to keep a track of, or what files it needs to keep a version history on. And to do that, since we want all of the files to have a version history kept on them, I'm going to do git add and then dot. And this is going to add all of the files that are present inside of our source folder, even within the different folders that we have, as files that are going to be considered by Git to be used for the version control purposes. So now that we have done this, the next thing that we're going to be doing is that we're going to be committing our changes to the actual Git repository. So for that, I'll do git commit, and then I'm going to add a message to our commit, and I'm just going to say initial commit and do enter, and you're going to see that it's going to give us a bunch of output, and these are all of the files that Git has now added inside of the commit. So a commit you can think of as a grouping of all of the changes that we've made. So now that we have our first commit, the next thing that we have to do is that we have to establish a connection between our local repository that we have on our computer and the repository location where we're going to be uploading code on Heroku. So to do that, what we have to do is that we have to firstly interact with Heroku, and to interact with Heroku, we need the Heroku CLI. To install the Heroku CLI, you can actually go to Heroku's website, and I'm going to include all of these different links in the resources file that is attached to this course. And once you're at the actual installation page for the Heroku CLI, you can follow the commands for the operating system that you have. Since I have Mac OS, what I'm going to do is that I'm going to do the command that is this one, which is brew tap Heroku /brew, and then after that we install Heroku. I already have Heroku installed, but once you have gone through this command, then Heroku is going to be installed for you as well. So now that the Heroku CLI is installed, the next thing that I want to do is that I want to log into Heroku. So for that, I'm going to type in Heroku and then login. And this should open a browser window if you press any key except for Q. And once it opens, you can click on login to Heroku, and it's going to log you in, and it's going to give you some output here. So once this is done, we are now officially logged into Heroku. So the next thing that we have to do is that we have to actually add the actual remote repository where we want to push our commit that we've just created. For that, I'm going to do Heroku git and then remote, and then I'm going to do -a, and then I'm going to add the actual name of the app that I just created. And in our case, the app is called Taskly app Django API. So I'll copy this and I'll paste it in. And then I'll do enter. And as you're going to see, it says that set git remote Heroku to this, which is the actual output that we expect, as you can see. So once this is done, we're going to take a pause on actually deploying the code to Heroku, and we're going to be doing some other small configurations that we have to do before we can actually deploy the code to Heroku. So the first thing that we're going to be doing is that we are going to be adding the actual proc file that is going to be used by Heroku to actually know how to run our server. So for that, I'm going to click on the source folder, and then from there, I'm going to create a new file inside of it. And the name for the file is going to be really specific, and it's going to be called proc file. And make sure that the P is capital, and you can do enter. Once we have the actual proc file created, the next thing that we're going to do is that we're going to add web, followed by this colon, followed by gunicorn, which is the web server that we're going to be using to actually serve our Django application. And I'll get back to gunicorn in just a second. And after that, we'll add this taskful _API, which is the app that we created, which has our wsgi.py file, which will tell our web server how to actually interact with our Django application. So wsgi.py, and then we can do command save. And that's all we have to do for our proc file. And we can close it. So now that we have this, the next thing that we're going to be doing is that we're going to be installing the actual web server that is going to be serving our Django application. And in our case, the web server that we're going to be installing is going to be called gunicorn. So to install gunicorn, it's really easy. Make sure that the virtual environment is activated, and then we can do pip install and then gunicorn, and then do enter, and this is going to install gunicorn. Once gunicorn is installed, the next thing that we're going to be doing is that we're going to be installing another package, which is optional, but in our case required, and the optional package is white noise. And the reason we need the white noise package is because it will allow our Django app the ability to actually serve static files during production. And static files are different from media files because static files are just files that are bundled with our application source code, such as JavaScript files, CSS files, or HTML files, which we expect not to change and are things that are not uploaded by the user. And for that, we can use the white noise package. So once we've installed the white noise, I can click clear. And from there, what we can do is that we can go to our settings.py file. Once we are at our settings.py file, we can browse down to where we have our media root and media URL. And above this, I'm going to be adding a new field, and that is going to be, or a new variable, sorry, which is going to be the static root. And I'm going to add it above the actual static URL, and it's going to be os.path.join base there, and then static files. So once we have this done, we can do command save. But before we can actually use the white noise package, we have to also configure Django to actually use it. For that, we can go to the top and try to find the middleware section. And inside of the middleware section, what I'm going to be doing is that I'm going to be adding the new white noise middleware, which is going to be white and then noise dot middleware and then dot white noise middleware. And from there, I'm going to be adding this comma. So white noise dot middleware dot white noise middleware, and then do command save. And once this is done, the final thing that we have to do is that we have to add a new variable to our settings.py file, which I'm going to be adding at the same location where we've added the static root, static URL. That is the static file storage, which is going to be, in this case, the white noise package. But this we can do command save, and there's nothing else we have to do now. We can just do a test run and make sure that our app spins up. And we're just going to wait for the server to load up. And as you can see, we get no errors and the server is running. So I'm going to quit the server and I'm going to end this video here. And then in the next video, we're going to continue the process of actually setting up and then deploying our API to Heroku. Thank you. Hello, everyone. Welcome back. So in this video, we're going to be continuing off from the point where we had left off in our last video, where we had implemented the white noise package inside of our Django application. And now we're going to be continuing on with the process of actually setting up our API to be deployed to Heroku and then actually deploying it. So now that we have our static file storage set up, the next thing that we're going to be doing is that we are going to be adding the actual requirements.txt file to our source folder. And the reason we need our requirements.txt file is because we're not uploading our virtual environment. So how does Heroku know what packages does the Python environment that is going to run our Django app requires to actually run it? And the way we tell Heroku that is by adding a requirements.txt file inside of our source folder's base directory. And then Heroku actually goes, looks inside of that requirements.txt file, see all of the packages named that are there, and then installs them into the Python environment that's up there in the Heroku Cloud that is going to run our Django app. To see all of the packages that have been installed in a Python environment, you do pip freeze. But one thing that you can do is that you can actually pipe these into a new file by doing pip freeze and then adding the greater than equal to sign, which is redirecting the output that you get from pip freeze to a new file. And I'm going to call this requirements.txt. And if I do this, you're going to see that a new file is going to appear here, which is called requirements.txt, which will have all of the requirements or the packages that are required by our Django app to be run successfully. If you're unable to do this, you can simply create a file and you can name it requirements.txt. After that, you can do pip freeze. You can copy all of the output starting from the first package to the last one, and then you can just paste it in requirements.txt like this, and you should be good. And then you can do command save. So with this, we've completed all of the setups that's required to actually upload our API to Heroku. So all that's left now is to actually add the new code to Git, which we've added. And in this case, those are the two new files, which is the proc file and the requirements.txt file, and any of the changes that we've made to our settings.py file. And once that is done, actually upload the code to Heroku. So the way we're going to add the newly added changes that we've made to the code, we're going to create another commit by doing git commit -m, and then from there, I'm going to just do this second commit. I'm not good with naming commits. And it's going to say that it says that change is not staged for commit. And the reason it's saying that is because we've not added these files. So for that, what I can do is that I can do git add dot, and from there we can try to do git commit again. And this time the commit is going to work, and we can do clear. So now that we've committed our new changes, the last thing that we need to do is that we have to push our code to Heroku. So for that, we do git push, and then we do Heroku, and then master. And then we can do enter. And you're going to see that it's going to start giving you some output saying, I'm compressing the source, building the source, Python app detective. And how do we know it was a Python app, or how does Heroku know? Well, if you include a requirements.txt file, be very careful with the naming here. Heroku would automatically know what type of a app this is. And in our case, it automatically understood that the requirements.txt file points towards a Python app. Hence, it started to create a Python app. And as you can see, it's now starting to install all of the stuff that's required. So with this, what I'm going to do is that I'm going to pause this video here. And then once this process is complete, I'm going to resume. So the actual remote deployment had actually failed. And the reason for that is because the Heroku app tried to collect static files and it was unable to do so. And I think the reason for that is because we've added this additional static file there's here, and we've defined the wrong static file directory. So instead of just having here static, it needs to be static files. So we can command save this first. Once we have this, the next thing that we're going to do is that we're going to be running the collect static command. And the way we're going to do this is that if you scroll through the output, you're going to see that it says that error while running this specific command. So we're going to copy this and we're going to paste this, and it's going to be python manage.py collect static -- no input. And this should collect the static file. And it says that the static files there's setting should not contain the static root setting. So I'm just going to remove the static files there altogether. I think we don't require this at all. Maybe Heroku hasn't updated their documentation. I'll do manage.py collect static, and you're going to see that a new static files folder is going to appear. Okay, so now that we've collected the static files ourselves, what we're going to be doing is that we're going to be disabling the Heroku CLI's ability to actually collect static files, and we're just going to be uploading them ourselves. So to disable the collect static functionality, I'm going to do Heroku config set, and then I'm going to do disable collect static is equal to 1. And with this, I'm going to do enter. And this is going to disable the ability for our Heroku app to collect static files, because we've already collected them ourselves by using the collect static command. Once this is done, we've had to add all the files that we've collected to our Git repository. So I'm going to do git commit -m, and then just going to do static files added. And I forgot to do git add first, so I'm going to do git add dot, and then the same command git commit. Once all of this is done, I'm going to do the command again, where I'm going to do git push Heroku master, and we're going to wait for this to complete, and hopefully, fingers crossed, this time it should work. Okay, so now as you can see, the command ran successfully, and the way you know that the command was successful was because you're going to get an output that says launching, and then there you're going to be presented with a URL from where you can actually access your deployed API. So I don't know if it's still working correctly or not, but we can just open this up in the browser by copying and pasting it, and it says that there's an application error and check your logs for detail. I know what the error is, and the error is that for our settings.py file, we forgot to actually add the domain at which our API is accessible. So what we have to do is that we have to firstly open this URL up in the browser, and then we have to copy this domain name, and we have to paste it in for the allowed host. And you could just remove everything here and add the asterisk value, but I wouldn't recommend that in a production environment. And we can do command save, and with this we can do clear, and then we can try to run our server again. And the way we're going to release a newer version is that we're going to do git commit -m and then do updated settings file. So we've committed all of the changes, and I have to add the changes first, which I keep forgetting. So this, then commit, and once this is done, we can do git push Heroku master, and then I'm going to wait for this command to complete and then reload the URL, and hopefully this time it should work. Okay, so the command ran successfully, but we still have an error, and I made a small mistake as to why we're getting this error. And the reason is because our proc file wasn't configured correctly, and it wasn't taskful_api.wsgi.py, it's just wsgi. With this, we can again first add our changes to git because we made a change to a file. We can do git commit, and this time I'm going to say updated the proc file. And with this, we can do git push Heroku master, and then this time, fingers crossed, our app should work. So I apologize for all of the hiccups. Fingers crossed, this time it's going to work. Okay, so the command successfully completed, and now if I click on the actual URL to access our application, open it up in the browser, you're going to see that it actually loads up. So our Django API is actually running on the server. So I apologize for all of the hiccups that have occurred during this video. Thank you.